So, kia ora, good morning, everyone. Welcome to this 113th edition of the Zak World of Façades Conference Series. My name is Ahmed. I just quickly want to introduce you the conference once before we get into details. Right, okay. For those who don't know the Zak World of Façades Conference Series, we've been doing this events across the globe since 2012. We finished around 112 editions in 33 countries around the globe. For New Zealand, this is our second event. We did the first event in February 2019. Unfortunately, things changed after that by the time we wanted to come back in 2021. We've been locked down for quite some time, and I think now is the time was right to come back, and here we are. So we've got events all across the globe, across different continents. Every event is different. It's adapted to that local country, to that local region, so that makes every event exciting for us as event organizers to organize them. Every place has its own challenge, but there are a few common things which I will probably highlight, which are common all across the world of facades. But before I come to that, I'd like to thank our event partners. All of them have a booth outside. Please do visit them in the breaks. So we'll start with our presenting partner. Presenting partner for this event is Thermosash. Thermosash is one of the leading aluminium curtain wall door window contractors based here in New Zealand. I don't need to give much of introduction about them, but they've been very instrumental in bringing this event here to Auckland and New Zealand. Associate partners, starting with AGC. AGC Glass are one of the top 5 glass manufacturers of the world. This is their active glass division participating, which has products for building integrated photovoltaics and more. AkzoNobel is a leading supplier of powder coating for aluminium profiles and panels. DC Tech, Proctor Group Australia are breather membranes and vapor barrier solution providers with and also a rain screen, rear ventilated rain screen cladding system solution supplier. FMI Building Solution is a local New Zealand-based high-performance door window facade systems company. Glasscorp is is a local New Zealand company, distributors of AGC Glass and Dow Corning, which is now Dow. Dow is the sealant company. Guardian Glass, again, one of the global top 5 glass companies, high-performance coated glass solutions. Insol is a New Zealand manufacturer of shading screens, of louvers, wind testing, and more. Kingspan is an Irish company. They have insulation. They've got cladding products also. North Insulation is a German company. They have high-performance insulation solutions for facades and roofs. Gobain Glass, again, one of the top 5 glass companies in the world, high-performance glass solutions. Search Ferrari is a French company. They have fabrics which can be used for architectural applications, including the facade and roof. Siderise is a British manufacturer of cavity barriers and pacifier stop protection for rain screen cladding and curtain wall. They are here with their local partner, the building agency. Technoform is a German manufacturer of polyamide strips for thermal break, and they have warm edge spacers and few other new products they're launching at today's event. The Tile People is a distributor of high-performance cladding products from Europe and other parts of the world. Vector Foiltec is a German manufacturer of ETFE, manufacturer, contractor, engineer of ETFE solutions. You'll be hearing from them later today. Vitro Architectural, again, one of the top 5 glass companies, a Mexican company, formerly known as PPG. High-performance glass solutions, coated glass solutions. Wood Glass is a leading New Zealand-based glass processing company and glazing solution, part of the Thermosash group. And then after this event, we go straight next Wednesday to Dubai, where we have our 114th edition. That's our 8th edition in Dubai, which we've been doing. Singapore after that, Istanbul, Madrid, Mexico City, for a break for a month, and then we've got Birmingham, and then in the region, probably our next event is in Australia and Sydney. So we had an event in Melbourne last week. We have a few attendees from that event over here. So this is it about the conference series. I just want to quickly take a couple of minutes to talk about what's happening in the world of facades. So obviously we all faced different circumstances from March 2020. I think one thing which is common, so we started organizing events since from March 2021. We had a full year which was wasted. But then as soon as we started from March 2021, one thing which was very common amongst all our events were embodied carbon or low carbon designs, products, solutions. So that's something which is driving facade design in most parts of the world, not yet in Asia or Australasia, but yes, you're definitely seeing this in the US, you're seeing this in the UK, in Europe, where clients, where architects, where product manufacturers are talking about recyclability, they're talking about embodied carbon in materials and things like that. So that's something which is very evident throughout the globe, and we have certain references to that in terms of products, in terms of designs today. Things which were not in fashion, let's say stone cladding is coming back. People are talking of opaque structures now back in America, in New York City. The new law, is pushing for more opacity in buildings, so the all glass building might not be a trend in New York City anymore because of the carbon content. But then you've got innovators like these glass companies who are using recyclable cullets and other materials to recycle the glass to reduce the embodied carbon in glass. So we have a lot of reference to all that today in today's event. Then came the war in February 2022. I think after that, energy security became a big challenge. That's pushed for photovoltaics on the building in a bigger way. Photovoltaic revolution has clearly started, at least in Europe now, and the new technologies in photovoltaics are very different from what they were earlier. Those ugly-looking panels, you've got colors on them, you can print on them. There's even transparent photovoltaics. So every investor now wants to take care of their own security to safeguard their clients and things like that. And photovoltaics are the best way to do that. And they have improved a lot in the last few years. We have a few people speaking on that today. Of course, there's a saying, Australia is scared of fire, New Zealand is of water. So we have airtightness also as a topic, moisture, membrane. All that will be discussed in the second half of the day. And of course, we've got issues also with respect to contracting, with maybe, let's say, not good quality overseas procurement and things like that. So we've tried to cover all of that today. And then also not to forget the recent H1 code, which has now been implemented or being implemented. I think we have a small discussion on that also. So we've tried to bring everything which is a trend in other parts of the world, which is probably going to be a trend in New Zealand and other parts of the world soon, and also what's local to this market. So I hope you enjoy today's event. Just to let you know, we are recording today's event. So in a week's time, we'll give you the YouTube link. We no more give the PowerPoint presentations. We are giving the video going forward, which will be in a form of a YouTube link. We don't have the handouts anymore for those who attended last time around. So those who have a delegate badge will have a USB stick hanging on your lanyard. So that has all the brochures of all our partners of this event, and then their contact details and other stuff. That's it from me. We're not going to take any questions for today. We'll have all our presentations. You can ask the presenters questions in the networking breaks. And then I also please urge you to visit our sponsor booths. They've been waiting. As I told you, this was a pretty delayed event, originally planned for February 21, did not happen. And here we are back after 2 years. So they've been waiting to meet all of you people. So please do see, we've got 18 companies, all different product ranges, and things which will help you design your next project. That's it from me. Before I'd like to call upon the today's event host and convener who will be taking you through for the day. Oliver NG, he's the managing director of BG&E Facades. BG&E BG&E is an Australian consultancy firm. Oliver is the managing director for the facade division. He's a veteran in the facade industry. He's based out of Melbourne, and he's happily agreed to host today's event. He'll be taking you through the day. So over to you, Oliver.
Veteran makes me sound old. Welcome to the 112th edition of Zak Facades. I'm Oliver Ng from BG&E Facades, and I'm honored to be your host today. The floods have been terrible, and I do feel for those who are unable to make it today due to the due to the damages caused. Our thoughts are with them. I must comment that working in New Zealand, I feel that the quality of work is extremely good. In my opinion, the producer's statement is very good. In Australia, we're now only looking at this, insisting facade consultants sign off on waterproofing. We've got this thing called the FP 1.4 pathway from the NCC, and when you look at it in detail, it's very similar to the PS methodology. So they've really taken a leaf out of how New Zealanders do it. One of our insurance lawyers noted that 70% of insurance claims are facade related. And 70% of those claims, so 70% of 70%, are related to damages caused from water ingress. And this includes mold, damage to property, and loss of amenities. So that's a pretty big percentage of issues in the facade that is water related. Now, as envelope consultants and engineers, we have a major role in this. And as you know from the leaky building syndrome, our role to help get the details correct is paramount. As I've said, this is Zak's 112th conference, so 111 times we've done this before. A group of like-minded people talking about things we love, which is facades all day long, right? So when Zak started this a while back, there were already few companies doing this, and they were never really very successful. But when I met Ahmed, he convinced me with his exuberance, vision, and love for facade. So it takes a computer programmer to get a bunch of facade people together this many times and talk about facades. A lot of his passion, I think, and knowledge comes from his father, Mr. Zak, hence the name. So sit back and enjoy. We're here to learn from each other, share our successes and failures. Maybe we just share our successes. We're not competitors. We're just companies or consultants or disciplined people who we're just doing the same thing for the same goals, trying to deliver another successful facade projects for our client. So talking about facades all day, and this guy can talk about facades all day, please welcome our first speaker. Well known in the facade industry in New Zealand, technical director, Mr. Karl Jones. He's the technical director of the built environment of MacDonald's, talking about lifting the lid on enclosure boxes.
All right. Thanks, Oliver. Tēnā koutou, tēnā koutou, tēnā koutou katoa. My name's Karl Jones. As Oliver said, you said I was the technical director of MacDonald. I'm not sure who that is. Mott MacDonald. I'd get in trouble if I didn't correct you. Heaps of friendly, familiar faces in the audience today, and a few that I don't recognise. Just a brief introduction, and then we'll get on with what I've got to talk about. It's good going first because I can be a little bit provocative and obtuse probably, and then get into the nitty-gritty a little bit later on. Anyway, my background is I studied architecture and then engineering. I practiced structural engineering for a while, and then was sort of merrily walking down that street and saw this sort of side alley that looked appealing. Facade engineering was down that alley, and it's been interesting, challenging, exciting, but and certainly something that I can't not do. Even my new role as built environment sector lead for the MacDonald business in New Zealand, I'm still deeply involved in practicing in the area of facades. So I thought I'd just mention a few things that we've been up to since we last met and I last spoke at this thing. This is the Britomart Hotel. Pretty proud of this project. I've got fond memories of sitting in a hotel in China, drawing the preliminary or the schematic for the idea of a window solution that turned out pretty well, we think. And shout out to our friends at Cheshire's and Cooper and Company, the client on this building, for embracing trying something on this project, committing to testing of a window system really early in the process. And it's I think it's a pretty special building for the Britomart precinct. Lakeview Taumata, a large mixed-use development in Queenstown. So MacDonald is undertaking all engineering services. We're the engineering lead for this project with our friends at Architectus and Monk Mackenzie. This is pretty exciting for us because we get to pull together all of our disciplines, really drive some of those interdisciplinary outcomes. Hard mentioned carbon, which is obviously key. A lot of building performance outcomes are really hard to do, we think, when you're looking at them in a single discipline way. And this should be a really exciting project for Queenstown. The Airport Hotel. This is, I think, Jonathan's going to talk about this a little bit later, but another really fun job, working closely with Thermosash, Simonite, on the cladding systems on this building. Really proud of the work that we did to help understand the risks around concentrated solar reflections on this project. Shout out to John Robinson for the work he did there. And you can just sort of see in the bit behind the curve of the soffit there, the area of the facade that starts to get a bit jagged, where we helped Warren Mahoney resolve a geometry that was going to produce less burning people and things. In addition to that, we're doing quite a bit of work on some big projects in New Zealand, some big billion-dollar airport thing, some big towers, and luckily we've got the, privilege now to help our friends in Australia and Singapore and around the region. Some great work in Australia with the National Gallery of Contemporary Art in Victoria, another gallery in Adelaide, which is really cool, and then the biggest building in the world is back on in the post-COVID world with the new terminal at Changi that we're working on with Thomas Heatherwick and KPF. I thought it'd be remiss of me really in this room to not just acknowledge this guy. So John Sutherland, for anyone that doesn't know. If you don't know, you should know. He was a great friend of mine and a colleague. So when I came back from Australia to start practicing facade engineering, John was the first guy who said, yes, I'll do that crazy thing with you. He was at Unitec at the time, having practiced as an architect, prominent figure in technical building design, introduced high quality performance specifications and specifications to New Zealand. And he passed away towards the end of last year. And I was in Singapore at the time, and I kind of feel like I didn't really get to say goodbye to John. So I just wanted to say thank you, and for us all to remember, I think, what John strove for, which was really just good buildings. So, my title, Opening Enclosures Box. What's that all about? My colleague John Hawkins and I, at about 10 or 10:30 in the morning, when he's in Auckland, we head off to Williams Cafe in the Wynyard Quarter and chew the fat on things. And far too close to the deadline for this talk, I was down there with John and I was like, what on earth am I going to talk about? This Zak Façades thing, got no idea. And both of us sort of oscillate between quite extreme optimism about our industry and extreme pessimism, to be quite frank. And sort of occurred to me, I'm not a great studier of the classics, but all of a sudden, I don't know why, the sort of Pandora's box story came into my head, the idea of hopes and horrors. Anyway, so I decided to tell some tall and medium tales. Apparently tall's over 25, is that right? Yeah. Tall. Medium, I don't know, that's less than 25, but more than something else. Apparently this is, this is a self-rating. It's an R rating, so for anyone that's a bit sensitive in the room, you should probably, apologies, really. But it is self-rated because we're still waiting for the council rating. Enough said. I understand there's a third censor that needs to get involved there. So apparently I did some Wikipedia searching, as you do. So the story of Pandora's box involves a god called Zeus. And then I did some Googling and found this photo of a god called Zeus. I think that's an actual photograph of him. So I believe that he decided to put a gift Pandora box and told her not to open it. And in the box was some horrors and hope. Anyway, long story short, Pandora decided to open the box. Horrors were out. Depending on which story you read, she slammed the box shut, leaving hope inside the box. Or maybe there's hope still inside the box. It's sort of a little bit ambiguous as to whether or not hope is actually a good thing or a bad thing. And so maybe some of the hopes that I talk about today might be equally ambiguous. We'll see. You can make up your own mind. Should start referring to the notes. So, horrors. The first horror, I think, is a little bit of an obsession about titles, the names of people that do things. And it was only recently, I think it was on LinkedIn or something, I came across a quote, this quote. And so Angus Lowe is a bridge engineer. He too had just recently passed away. And apparently he said this and wrote this in 2015. Said it in a quite cool video, actually, that you can find on YouTube. So I'll read it. I do get asked from time to time, who should design a bridge? An architect or an engineer? And I deflect it by saying, bridges should be designed by bridge designers. The important thing is that it is designed by someone who really understands bridges, who understands their role and relationship in the landscape and society, and in society, and understands the constraints of building them, which is basically related to the engineering and construction methods. Anyway, why am I talking about bridges at a facade conference? This is weird. So anyway, I changed bridges for facade. And so now this is my quote. I'm not sure if that's allowed, but anyway. I do get asked from time to time who should design a facade, an architect or an engineer. And I deflect it by saying facade should be designed by facade designers. The important thing is that it is designed by someone who really understands facades, who understands their role and relationship in the building and the environment, and understands the constraints of building them, which is basically related to the engineering and construction methods. A few more horrors. All clear glass buildings. What's that about? Clear glass fins and clear glass sunshades. I'm not sure we want to debate a climate emergency, but I'm pretty sure that lots of people have signed up to be architects that declare and engineers that declare. Someone decides to put clear glass fins on buildings. Someone decides. Sunshades on the south in New Zealand. That's another good one, eh? How about one-off tests as definitive things, definitive predictors of anything? Statistically implausible that one result of something predicts something else. Frankenstein facades. Those are that's my description for the bit of everything facades. Let's throw a bit of stick curtain wall, let's throw some precast at it, we'll have a bit of unitised curtain wall while we're at it, a good rain screen, a bit of everything. We make our life really, really hard for ourselves. Each one of those systems has to be designed, considered, thought about, tested, engineered, documented. It's hard. Why would you throw 12, 14 types of facades at a building? Kill your darlings. Save 1 or 2 or 3 or 4. Save half of those facades for the next job. There's plenty of work out there. How about the conservative off? This is a good one. This is when you get a bunch of facade engineers in the room and they just conservative off each other. I can be more conservative than you. It's really cool because you can I reckon that factor should be 1.2. No, it should be 1.25. It's sort of the same thing when we argue ad nauseum about whether the wind pressure is 4.2 or 4.3. Those are the same numbers. Does not matter. It's distracting. You're not actually managing risk by talking about those things. You're distracting yourself and distracting your client from understanding real risks. Let's talk about real things that matter. Oliver mentioned producer statements. Producer statements are somewhat helpful, but they can be distracting. The sort of obsession with the idea that you can have a producer statement for everything on a building, perhaps, that you can add up all of the producer statements and somehow get a whole, that's completely flawed. This weird idea that you can have a certification from someone for something, for some performance aspect of the building code, be it B1 structure, E2 weather tightness, which are pretty simple clauses, right? Resist the forces that are applied to the building. Don't let the external water into the building. But they're all nonsense. They don't count without a for long enough clause. B2 is the for long enough clause. It comes along and says, do that thing for long enough. And if someone's saying they can do a thing, and then they're saying, and they're certifying that, And then they're saying, oh, I'm not really keen on putting the B2 thing on my producer statement because there's no acceptable solution that tells me how to design the thing. Well, that's a bit dumb, isn't it? For long enough. Our buildings need to do the things that we need them to do for long enough. Similar sort of thing around the matrix. So often I'm hearing this idea that the answer's in the matrix, the responsibilities matrix. We can somehow allocate responsibilities to a bunch of discrete individuals who design a bunch of discrete things and bring them back together and call them a building. Well, that's dumb. That's not a building. A building is a whole thing that works together. It's a system of systems. It has to work together. The best way to think about your matrix is to think of it as subtractive. You have to have someone that's doing the whole thing, and then you can consciously and diligently subtract things away from the whole. You cannot add up discrete things and get a whole thing. While I'm at it, what is it with boxes with fins? I sometimes do a little thought experiment. Someone told me once that Einstein did thought experiments, so I thought, oh, that's a good idea. So my thought experiment involves thinking about aliens who are perhaps on a research trip. They've worked out how to build spacecraft, but they're keen on understanding how to build buildings. I don't know, don't ask me. But they're here and they're on their research trip. And they really love boxes with fins, so they come to New Zealand. Like, okay, well, how do you design these things? This is cool. Well, we do a picture, an image of a box, and put some fins on it, and render it, sell that to someone. We get a bunch of people to do design, but we don't really know what the building's going to be, but we'll lock them into a scope and a fee right at the start. That's a good idea. Okay, so the aliens are like, oh, okay, well, that's cool. And then what do you do? So who decides that? The project manager. What? The aliens are like, what? So the person designing or the people designing don't decide, or the person in charge, they don't decide who? No, not really. Someone else does. Oh, okay, good. It's a bit weird, right? I reckon that if you gave a blank sheet of paper to almost everyone in this room and said design the way we should design buildings, I'm pretty sure that no one would design what we do now. I don't know, maybe you would. But it gets some outcomes, right? We build some buildings. There's a book that I've been reading just picked up just recently. It's called How Big Things Get Done, by a professor at Oxford, Bent Flaveberg, a Danish guy. This is a pretty depressing graph. It's not specific to buildings, it's about projects. 100% of projects on the left there, half of them on budget, 8.5% of them on budget and on time, and 0.5% of them on budget, on time, and on benefits. Wow. What's the definition of insanity? Doing the same thing over and over again, expecting a different result. The graph on the right is sort of a power law distribution of cost outcomes on projects. So he points out that cost outcomes aren't a normal distribution, they're a fat tail distribution. And right at the end there is 10 times the actual overestimated cost. And the blip there is because all the tens the tens and overs are lumped into one. Pretty scary. Oh, sorry. Couple more horrors before I get to hopes. It seems to me that the risk owners are getting further and further away from the risk creators. That's always, always bad. The ownership of risks should lie as close as possible to the creation of the risk. That allows for appropriate understanding and management of risk. We have a system that's designed to do almost the opposite. And in terms of one-off testing, and critique that, the same goes for certain simulation tools. They do not predict real life. They're a clue, they're a hint. They need interpretation. They need someone who can understand what real life is versus simulation. That's enough about horrors. Hey, we should be a little bit positive as well. I think facade people are amazing. Lots of them are T-shaped people. Breadth of knowledge and a depth of knowledge makes them a T-shaped person. If you haven't come across that, have a read, it's quite interesting. But that's really, really important in today's world in terms of building design. Facade people are really, really good sometimes at balancing competing demands. The aesthetic demands, the performance demands. There is no perfect answer. You will not build or design a perfect facade. I actually think that facade people have a role to play in leadership and teaching, really, the rest of our building industry how to deal with some of these competing demands. There are other parts of our building industry that are not very good at it. Our people can help with that. I think we can take a greater leadership role in doing those things. Facade people are also modular experts. We've been doing modular for a long time. Thermosash is probably New Zealand's biggest modular building company, I reckon. They're really good at managing logistics. They are so much better at managing logistics than main contractors who don't know where to start with modular. Wouldn't it be wonderful if we got our expertise communicated across into the whole building process? I reckon that'd be pretty cool. So how do we do that? I think we can think carefully about the ways that we organise projects. We can undertake projects with a far more collaborative, a sort of enterprise approach where we focus on getting the right skills in the right place, not the right box or the right name or the right firm in the right box. Focus on skills. What's it going to take to get me from this blank sheet of paper to a building that's on time, on budget, on benefits? Who do I need in the room? Who can I trust? That's where we need to focus. I have another hope, a sort of hope that this sort of craziness that I've described, some of these horrors, leads to a sort of moment of truth, a realisation that we can do better. I'm happy to perhaps start a Facades Anonymous group, if that helps. Part of my reading recently, I've been reading, or off the back of the How Big Things Get Done, I sort of went down a bit of a rabbit hole into some of the social science theory at the moment. And the author of that book is a social scientist, as I said, teaches at Oxford, and he talks a lot about the sort of Aristotle's approach to knowledge and wisdom and things, and phronesis, practical wisdom, comes up a lot, right? Social science is about that, practical wisdom. I actually believe too that facade people have an awful lot of practical wisdom. That's why I'm so pissed off that architects are often dismissed as not being able to design facade systems, they come at it from a different angle, but from a practical wisdom angle. Practical wisdom should not be dismissed as a valid, perfectly valid way to make informed and reasonable decisions about what to do. It is not inferior to episteme or science, scientific knowledge. It's complementary to it. So, in closing, I really just want you to remember one thing. When we're doing these projects, we're trying to decide what happens, or we're trying to document a building. You know, how do we do that? Why do we do this? Someone decides. We have to know who decides. I've sat in meetings with council, embarrassing meetings sometimes, and council has said, well, who's designing this? Literally a tumbleweed just blows through the room. All the designers for the project are there. I was there as a peer reviewer of the project. We'd asked in the start of our commission, who's designing this, got an answer. Those people were in the room. And when council asked, well, who's designing this project? No one put their hand up. How sad is that? Someone decides. Someone decides to put glass fins, clear glass fins on a building. Someone decides to put aluminium fins on the south facade of the building, despite the fact that they claim to want to be low carbon. Someone decides. So, let's see if we can focus on the hopes. I think acknowledge the horrors. John Sutherland would have wanted to acknowledge the horrors. He knew all about the horrors. In fact, we talked at length about the horrors. But he was so optimistic that there was still some hopes. So I don't think we've slammed the lid shut on our enclosures box. I reckon we've got some hopes. But someone decides. I'll leave you at that. Thank you.
I like your use of word horrors, Karl. And you can see who the real veteran in facade is, because most people will show lots and lots of details. He talks about the philosophy of facades, the philosophy of delivery. So that was very good. You left a bit of hope there. I'll join you in that. Yeah, I think when you get the design wrong, it's expensive, and we've all had that before. So to our next presenter, I've worked with her before in the past, and Gosha Haley, Associate Principal for Grimshaw, talking about facades beyond performance. And yeah, thank you.
Hopefully I kept some answers for Karl. And obviously, the question, who to trust the architect, and that's no joke ever. And I've got answers for everything, why we're putting something on a building. So today I will tell you those answers. So here, thank you. Our practice was founded in 1980 by Sir Nicholl of Grimshaw on belief that performance, rather than style and aesthetic, should drive design. I would like to use one of the Sir Grimshaw quotes as a preamble to my presentation. My great hope is that in the opening decades, in this new century, architects will lose their obsession with style, the horrors that Karl is talking about, I think, and image, and will design buildings which actually express the forces that act upon them. And forces that act upon buildings are climate conditions, location, the function of the building, but also a place, community, and a local culture. but also locally available materials, as we're finding out as we're working in New Zealand more. Materials and technologies, local construction experience, and not to forget, time and cost. As an architect, the joy, the challenge, and maybe the horror is orchestrating, synthesizing, coordinating, and simplifying all these parameters together with the project team, consultants, stakeholders, clients, contractors, to create a highly performative but also expressive design that is connected to its place. Today I'll describe 6 public buildings from Grimshaw International and local portfolio, focusing on their highly performative features, which also work to create an expressive connection to place. This project span across the past 2 decades, with some commencing design in 2003 and some that are currently under development. Each of these projects illustrate a variety of responses depending on their location, climate, context, and culture, starting in America. So Fulton Center is a transit interchange situated in the heart of Lower Manhattan World Trade Center district. It was just a block away from Ground Zero. The station handles up to 300,000 passengers per day and links 9 train lines. We started this project in 2003. Initially, it was to be completed in 2007, but GFC happened and it was completed in 2014. The focus of the project was to provide an experience of daylight and to energize the maze of diverse subway lines, street entrances and underground corridors. At Fulton Street, the trains arrive 3 stories below the ground, and they arrive at 3 different levels. The civic space is located under a large atrium that is organizing transfer of passengers around the central space. The original form of the atrium was sort of a version of the Pantheon, but as we work through with our design team, the atrium kind of changed the shape to be a lot more efficient to do the work that we were hoping for, meaning distribute the light. The atrium is topped with the glass oculus and lined with the internal reflective scheme. It is shaped to minimize capture and distribution of daylight and sign line to the deepest level of the transit center through the year. All this was carefully analyzed by Arab lighting, so all the angles and all that, how it was to be positioned. Then the lining was developed in partnership with the artist James Carpenter, and having that input from the artist is always great to have a new collaborator on a project that brings the kind of different angle to the project. So it's a hyperbolic paraboloid cable net, supports a filigree metal inner reflector. This web of 6mm cables supports a series of perforated polished aluminum panels. And as always, we had to refine the design so that we could achieve the maximum benefit with minimum material. So here it is under construction, which happened over a 2-week period after a trial crane suspended erection in a fabricated yard. So only 2 weeks, this massive structure. And here is the completed project with a view up at the oculus. The space becomes animated but changes light, which connects rushing commuters to time and a place, with the quality of light also changing in accordance with changes of the season. So, and it offers you this kind of moment of reflection, or where you are, what place and time of the day while you're rushing to work. Next, to Melbourne. So this is the project that we worked on with Oliver. The Doherty Institute is a unique and innovative building, played a massive role during the COVID-19 because that's what they're doing there. They research into infectious diseases and immunity. So the client group, along with the design team that comprised Grimshaw in JV with Billard Leased Partnership, and the consultant team, importantly, work closely together to realize this aspiration of the project to create this unique and innovative building that brought together 7 group of stakeholders across 2 organizations, Melbourne Health and University of Melbourne. Bringing this organization was the strategic aim to enable them integration and research in a strategic sense to respond to the crisis like COVID-19. The institute is located in the heart of biomedical Parkville precincts at the edge of Melbourne CBD. Internal spaces are contained, vary between teaching, collaborative, focused spaces to more control, highly technical and precise research spaces such as laboratories, lab support, and plant rooms. This section illustrates the tight stacking of the research and support functions, which are tightly packed within an enveloped building to the very edge of the site. So we had so much to fit in, and we kind of couldn't fit it in really. And now actually they're expanding and building another building that's twice as big. But we're completing this one in 2014. Woven into is a central to institute collaborative spaces that connects the building to the public realm. So that's the right-hand side diagram that kind of shows how those public spaces are linking ground floor, tea room, and boardroom to the outside. The planning strategy split the floor plate into 3 zones. So office, dry lab, collaborative spaces that require access to daylight, these were placed along the perimeter. Sensitive control conditions were situated in the core, and the support labs with the hardworking support spaces to the back. Because the site was constrained to the south, that's where the extension is going at the moment, it sort of pushed us to the one-directional facing north floor layout. The north facade wanted to maximize the views, but also needed to provide the shades in a high summer sun and allowed for heat gain. The east and the west provided preserved the views along the Elizabeth Street to the parks, but also protect from a harsh low sun and insulate against heat loss. So the office is located at the perimeter, created an environmental buffer for the open lab. So the planning was very critical to the performance of the building, including the acoustics, which were highly considered, with the entire envelope needing to create acoustic buffer to allow focus work within the building. But as well as drawing inspiration from the surrounding, we had ambition to use timber due to it allow us to reduce the building's carbon footprint by reducing the use of aluminium, which also creating a visual connection to nature and Parkville precinct. It doesn't sound very ambitious, but the building was going for 5-star green star, and obviously achieved it. But for such a high controlled laboratory building, it's actually really ambitious. So how we brought the timber into the building. The initial idea was to shade the outside by using a timber material to create a warmth, as per example from another project, which in England, to the right. However, this approach brought with the following issue: maintenance, cleaning access and depth required, so it just would blow up, the depth of the external layer would blow up, and then maintenance. I don't know if any of you knows the client who likes cleaning building, and especially institutional clients. Sorry, got something on this screen. Oh yeah, it's gone now. And then timber weathers in Australia, so it just became grey, so there will be no colour left after a long time. So, and obviously the cost this solution provides, it's 2 layers of the facade, so it's obviously twice as expensive as it will be just a single facade. So the proposed alternative was an oca wood, an Ocalax product, which Oliver actually suggested at the time. So it included 5 timber batten screen with relatively clear glass DGU, which allows for color and variation of the timber to be visible. And putting external shading into cavity in obviously reduced the complexity, but provided also a more durable and low maintenance solution at a slightly lower cost. Obviously, bringing a unitized system from Germany, it's not exactly the cheapest solution, but it was only 1.5 price as opposed to twice expensive. So still a saving of a quarter. The institutional timber batten curtain wall provides, that integrated system provides close to 100% shading. Creates warm appearance, you can see in the image on the right what it is looking like during the day, and allows the warm light to come into the office. The spacing of the battens were finely tuned with the help of our environmental engineer just to provide optimal lighting, but in balance with the shade. And the additional positive was providing the privacy to the people inside. And as this was the first time that this system was used in Australia, there was concerns how the timber would behave inside the cavity. And before it was used in the northern hemisphere, which is the sun is not as harsh. So Auckland found that a laminated timber was a lot more stable, but it also, so there was a kind of a unique system that was developed on this project, but it also was able to be curved, which allowed us to have fancy curved corners. And with additional interesting thing, we had to use laminated glass to the outside to increase the acoustic protection for the internal spaces, but that additionally gave us a protection for the color of the timber too. And the result is beautiful filtered warm light. The light and the quality of the internal environment is remarkable and unique to the Institute. Physical and contrast for these spaces with the labs, which are kind of quite cold and controlled. So it's quite a lovely open and warm face. This contrast is also seen externally. The high security, highly controlled building presents an open and engaging face to the city. Quite different at night when it's all illuminated from outside. It's quite animated and feels open to the public realm. There's another Melbourne building, Monash Woodside, that's a little bit more recent. This building is at the Monash University Clayton campus. So that's 25 outside of Melbourne CBD. It's a teaching and learning laboratory that brings together facilities of engineering and information technology. So it was 10 years after the PDI, and by that time, the awareness of climate emergency obviously kicked in a lot more in Australia even. And Monash University committed to achieve net zero by 2030. And a set aspiration for Woodside to be a passive house certified. So it's a lot more challenging than the previous project. So what's the building about? Central to this design is maximizing internal interface between the learning, practical work, and academic workspace. So as you see that the section is the physical connection through the building, vertically and horizontally expose students, work practices, I think, and the equipment. In this axonometric, we illustrate how the key strategies that allow Monash Woodside to meet the passive house standard. So PV panels, high performance envelope, which I will talk a little bit more about, skylights, layered internal space, roof frame, water catchment, high performance surfaces, and obviously really well sealed corners everywhere. And a heat exchange, which is kind of an interesting thing too. With all these features on show within a building, Monash Woodside is a living laboratory. That's where engineers are learning about how to build buildings, so why it's the best place to see how it's done and how it performs. So you can see the sensor, and there's a couple of places, and you just see sensors on the columns. This is monitors how the building behaves over time. You can also access the roof with these photovoltaic panels and drone launching pad, but obviously you can access all the spaces, and the structure is exposed quite a bit. So focusing on the high performance envelope a little bit more. When we think passive house, we imagine well-insulated solid box with few sparsely located windows. they had the strategy for what Monash would say, they can't develop it through a thorough analysis, but also creative planning, so to speak. You know, in the end, after that, they managed to, so they carefully distributed differently solid and non-solid facade around the building, but provided them with amazingly well connected to the outside building. So 100% solid facade on the north, whereas the highest loads, then high transparency to the south because there is not much heat there. And the main long east and west facades, 50% solid and 50% glazed. That was paired with the distribution of the functions within a building, so the heavy, high energy use in the center of the building, which includes the heat generation for lots of students in one space and equipment. So that was on the inside, those purple boxes, and then more sort of informal teaching spaces positioned close to the facade. The predominant east-west facade, this is really the feature facade of this building, that's most predominant and most visible, connects the building to the campus. Oops, I should go back. How do we go back? No. It's a unitized curtain wall, consists of 50% solid and 50% glazed, clear glass, or very clear glass, but it's highly insulated and thermally broken system with high performance glass. So it's double glazed with argon fill cavity. It has 550 millimeter deep vertical and horizontal thin screens, which screen most of the direct sun and heat. And it is a beautiful hand-drawn detail by the facade engineer, Alberto Signorino. Nothing more to say, it's just beautiful. The 50-50 glazed facade results in a surprising amount of daylight internally. You can see it doesn't look like a box at all. The connection to place also, it's not just achieved through the connection through the windows. Here you can see that materiality, detail and tonality derived from the indigenous landscape, dark grey louvers from the ironbark and the rose gamlet flowers describing the circulation provide a visual reference to gamnat flowers. It's just a little video to close this with. The east and west orientation of the building embraces the sunlight. Facades capture light and redirect them. It's actually quite beautiful. Now to America, to Arizona State. The Arizona State University Interdisciplinary Science and Technology Building 7. That's the full name of it. Now it's named Rob. Ooh, that goes. Didn't mean to do that. Now it's named Rob and Melanie Walton Center for Planetary Health. This high-performance building serves as a new gateway to the campus and it's a visible commitment towards a more sustainable future. They don't have the LEED certification yet, but they're applying for platinum. So they've got lots of number of various institutes co-located in this particular building, but the main functions is the public outreach, and they're focusing on a sustainable research into sustainability of food, water, and energy, and housing also lots of dry labs, research labs. So it's a very hard-working building. But what I find the most intriguing about this particular building is just that it is attuned to the building and its environment. It's in Arizona desert, so it's quite a harsh condition. So, rather than transplanting a conventional building for that typology and turning up a spec to meet their requirement, the design included traditional and natural strategies, or drawing from the natural and traditional strategies tested in its climate, like shaded courtyard or canyon, or the canal image you can see on the side. There was an ancient canals located in that particular area, so it's kind of reinstating them. It's 281,000 square foot, because it's America, so it's foot. And it's defined by the geometry of the site. It responds to the constraints and the building program defines that courtyard, because obviously the depth of the floor is limited, so that creates that natural courtyard. But the courtyard adds that additional living room for the campus. But also lifting the building off the site creates a porous space and allows the cross flow, so it can stay cool. This diagram illustrates the key sustainability strategies of the facility. But interesting enough, the biggest contributor to the reduction of carbon was use of void form concrete, which I think reduced about 65% of the carbon, which is quite staggering. And obviously there's a variety that I'm not going to focus on this other strategy, but go to the glass fiber reinforced concrete self-shading facades. When I reached out to the team in New York when preparing for this presentation, they shared the material that Bureau Happel environmental team prepared. The research they had done and thorough analysis which allowed them to achieve the most efficient strategies for the building envelope. But this particular slide made me really surprised that in the harsh conditions of the Arizona desert, people and their equipment are still creating the most heat. Maybe that shouldn't surprise me, but it did. But amongst many other parameters, the analysis also identified the optimum window to wall ratio per orientation, which is a great segue to talk about this feature facade of the building. So not lots of windows. So the main building envelope, exterior, applies biomimicry, so learns from the local plants of the Sagara cactus, which have self-shading ribs, as you can see on this image. The panels on each facade provide optimal shading for the windows while allowing for quality interior day lighting and views. And this is a mock-up that was done with the contractor during the design development. So the other interesting thing, the envelope is comprised of glass fiber reinforced concrete, which is a lower density material and allow for less banking of solar thermal energy. We also lifted the skin. As you can see, there's little hoods or visor, so that you blocked from the sun in one direction, but you may see out in the other direction. As such, the skin is really responsive to the solar angle. But at the same time, it still provides a strong visual connection to the outdoors. So it's kind of neat, square windows inside, but beautifully textured facade on an outside. Beautiful and playful facade, quite unlike the cactus. And as you walk around the building, you'll find that some of the panels are more open and others are the south. Although I was talking about facade, but I think this space is the coolest, literally the coolest, because you can sit during the day in a heat and there's a breeze, there is a water, and just feels like this oasis in the desert. So it's this, and the fact that it's got this additional meaning because learning from ancestors of indigenous people, but that is actually quite old canal system that the Westerners adopted when they moved in, but it was set up by indigenous people. So it provides the kind of welcoming, open connection to the site's past, but also to the future. And coming home here to New Zealand, ACRL project, we started to work on it in 2012. I think majority of people know that what project aims for significant uplift of capacity, frequency and performance of the train to enable the growth of the city, I guess also to enable the city to move a little bit more fluidly at last. It provides 2 new underground stations and the third at grade. Reference design was developed by Grimshaw and Jasmax with Mana Whenua. Then now, since 2018, we part of a Link Alliance design team with WSP and Grimshaw on a delivery of it, and our contractors with it as well. So the connection to local identity and an overriding organizational idea was developed during the reference design and it was a creation story. This was gifted to us to the project by Mana Whenua. So in essence, the story is, before life, there was darkness. Through the close embrace of Ranginui, the Sky Father, and Papatuanuku, the Earth Mother, who are then pushed apart by their children to let the light in, with the children becoming deities. Story is then translated into components of the architectural language. The sky element, the threshold element, which has this those are the unique component. The fourth element, common component that go across the stations, and the earth element, which is the precast base that you can actually now see at Taiwa Horotu Station, which is the one that I would like to focus on about today. This station runs under Albert Street, and in particular, I would like to look at the development of the sky element facade over the main entry building on Wesley Street. The sky element represents Father Sky and its line-wind system, and yet somehow unique at each place. So it's a quite, although there is a lot of symbolism with what it represents, it's actually quite a hard-working piece of building. It's got big plant rooms behind with lots of air handling equipment, very functional louvers. I wanted to say ugly, but they're not ugly, they're just functional. And they are enclosed in a precast panel that provides fire-rated enclosure and acoustic screen. So it's a very practical envelope, elegant and unique. And we have a beautiful colored precast with it. So, and in front of it, it's the screen. When we were looking at a variety of ways that we wanted to do the screens to meet variety of requirements that were not all of them aligning. We just, we need to visual screening of the plant, and it wasn't not obscuring the airflow and ventilation. There's some real magical things that we needed to achieve with it, and then also we needed to express the cultural narrative, so we needed this beautiful ephemeral. But at the same time, obviously, needed to be modular, needed to be simple, maximizing this, minimizing the unique components, and obviously material consumption. So how we achieved this miracle? With the help of Thermosash, obviously. On this particular one, we were lucky to have an early consultant involvement in that particular one. So they came on board to provide us with local industry knowledge. And we eventually landed at the Unitas aluminium screen system. The screen responded to mechanical requirements by positioning shingles at 45-degree angle and aligning most of the shingles in front of the vents in the same direction to minimize disruption of airflow. So, we had a whole, group of people talking about how the sky element be. And when you talk about who designs the facade, everyone on a team designs the facades because it's a highly performative scheme that responds to so many things. So we initially had the shingles on the left folded, but then we designed a Volto extrusions to optimize the performance of the facade and how we can visually control these elements. And we had two depths that were flipped, one on the other side, to create that kind of variety. So those two depths were cut to 3 different lengths and painted 3 different colors. So we had altogether 12 12 different components that we could play with. And each shingle was coded, so it will be nice and easy to assemble. And I hope it is easy to assemble, isn't it? No? No. It's not up yet, but hopefully we can see it soon. The sky element is a unitized system that consists of modular subframe with intermediate transoms, extruded aluminium fixing rails, and shingles. A typical module is 2.25 wide and 5 meter high, which is the height. 5 meter height is the height of the plant room floor. So it's got a limited number of components that we're playing with to provide a quite intense and interesting texture. So the steps to create this variety, or this perceived variety, where you utilize Grasshopper script that involved sampling various images to create a perceived variety and lushness of the pattern, and support associated local cultural narrative. And here you can see those steps. So first, we dividing the facade into equal panels, then sampling images. So we're varying the horizontal rail, then we're varying orientation of the shingles, then sampling images, so the shingle sizes, and in the end, the materiality or the color. So you have that image 5 is this sort of ephemeral veil that kind of creates the backdrop for artists to weave in something a little bit more specific based narrative. So once the backdrop was created, the design team worked with the local Mana Whenua artists, in the case of Te Waihorotu Station, Graham Tippiner. And Graham was integral to creating a more expressive and clear representation of cultural narrative that was woven into textured veil at the station, which is, they keep us honest to make sure that we actually really express the local identity, and sometimes tell us that we're wrong, which we do need to be told occasionally. So I think it's, obviously we haven't seen it on the station yet, but the evocative result is visible in this artist's impression. And will be realized on site in the near future. I've seen the mock-up last year, and I believe some of those panels maybe not on this station, but I was told on the K Road station will be coming later this year. And I will close my presentation flying to the airport, Auckland airport, with this project that looks into the future. We are working on this project with our partners Jasmax and engineering team at Mott MacDonald. I'm not able to share much detail about it today, as the facade are still very much in the midst of development. But watch this space, hopefully soon. So the project is Auckland Airport Domestic Processor, which previously was called on this image New Domestic Hub, and aims to put domestic capacity for the terminal into one building to connect seamlessly with the international terminal, simplify the travel experience, and future-proof for expanding capacity in the long term. This diagram illustrates a key idea that the Grimshaw Jasmac team put forward. It's basically optimization to achieve more efficient, symmetrical sections, simpler structure, a better space for passengers. But also, this sketchy axonometric shows the key components of the peer optimization concept, which is the modular grid, repeatable inserts for the common conditions that exist within this module, such as window of gate lounges, fixed gate bridges, insulated walls. This common detailing and set of common solutions for these components are being developed now, bringing the local construction and supplier knowledge. So by the end of March, we should finish it. This is my last slide. Perfect timing, isn't it? On budget, on time. Together, the projects I have shared with you today illustrate a variety of responses depending on location, climate, context, and culture. The 6 projects also illustrate the journey evolution of high-performance facade in response to urgent environmental needs of the planet. Thank you.
Amazing projects there, Gosha. There you go, Karl. There is hope. There is hope. Our next speaker is passionate about glass, especially when it's in a jug holding his favorite beer. So Marcus Tan will be a manager from AGC in sales and marketing. He's going to talk about sustainable glass solution towards green carbon neutral buildings. Marcus.
So, good day, everyone. Thanks for the introductions by Oliver. My name is Marcus. I'm from AGC, doing sales and marketing in Singapore. So actually, it's now like 5 a.m., so I expect more energy in this New Zealand since it's 10 a.m. And today I'm going to share with you on the topic of sustainability glass solutions towards green and carbon neutral building. In this topic, I'm going to share on the glass carbon emissions impact to building, advanced energy solutions for facade, and sustainable case studies and reference. First, short introductions about AGC Group. AGC is found in year 1907, 100 over years of history, and is headquartered in Tokyo, Japan. Today, we have more than 55,000 employees worldwide in 3 main regions: America, Europe, Japan, and Asia. 4 main business areas: chemicals, including life science, raw materials for DFE film, or maybe Lumifron, resins for paint and coatings as well. Electronics and display, ceramics, and also glass for architecture and automotive segments. Total net sales for year 2021 is about $15 billion, with architectures and chemicals contribute to the bulk of it. Our HQ for Asia Pacific is in Singapore. Our 4 plants located in Thailand and also Indonesia are our core production space in the region. And we have representative office in Asia Pacific like Australia, Philippines, Taiwan, and so on. And for New Zealand market, we have a distributor, and they are Glass Corp, which actually distributes our glass products for this New Zealand market. Next, let us look into these glass carbon emissions impact to the building and how the world has evolved towards clean, renewable energy. First, let's look at these green building sustainability development goals. By year 2030, the World Green Building Committees call for existing buildings reduce their energy consumption and eliminate emissions as fast as practical, where applicable. And also, new developments and major renovations are to be built, highly efficient, powered by renewables, with maximum reductions in carbon emissions. As you see from the infographic, there are many reasons that benefit all of us, like green buildings helps to improve people's health and well-being, having good designs that spur innovations and also contribute to climate resilience infrastructure, and importantly also helps to combat climate change through producing fewer emissions. In 2016, the Paris Agreements entered into force. The purpose of these Paris Agreements is to keep the global average temperature well below 2 degrees Celsius above pre-industrial levels, while also pursuing efforts to limit the temperatures increase to 1.5 degrees Celsius. It also wants to strengthen the ability of the countries to deal with impacts of climate change, and also make sure that the financial flow support the developments of low carbon and climate resilient countries. You can see that major big countries like the US, Europe, Japan, China, India, and also ASEAN countries are already declaring their emissions target by 2020. As you can see, they are all looking at very challenging target actually. So New Zealand, NDC, the National Determined Contributions, is also committed to reduce emissions or greenhouse gas emissions by 30% below 2005 by year 2030. So you can see that building actually accounts for 39% of global greenhouse gas GHG emissions. 28% contribute from the operational carbon, and actually 11% through embodied carbon. Green buildings can contribute significantly to reduce these GHG emissions, and energy-efficient glass can play a role to actually also reduce the energy consumptions and associated CO2 emissions. At AGC, we also set our environmental targets. By 2050, we are looking at a net zero carbon goal by reducing in CO2, zero in waste, production sustainability, and also conserving natural capital. We aim to reduce these GHG emissions by 30% by 2030, and identify the areas in manufacturing and also the use of the products. We are also committed to reduce carbon emissions from two main aspects: reducing the environmental impact of our glass production processes, embodied carbon through glass processing or manufacturing process, developing innovation glass products that can contribute to green building, operational carbons working towards a high-value performance glass products also. Activities has already been done to reduce these greenhouse gas emissions. Examples in our float-like glass factories in Indonesia and also Thailand plant, with the upgrading of furnace using the latest most advanced energy efficient technology. Fuel oil usage was actually completely phased out in 2008. This significantly also reduced around 25% in CO2 direct emissions. Further reductions of these GHG emissions in Asia as well. For example, full oxygen combustion technology is installed in our furnace in Yokohama, Japan, with using pure oxygens that contribute more efficient combustions. Hot oxygen technology is also installed in one furnace in France, with reusing heat from the furnace gases to preheat the natural gas before it is injected into the furnace. Ammonium combustion technology is also one of the options for the future, because this ammonium does not produce CO2 when burned, and already widely distributed as a fertilizers and also industrial raw materials, and also has the same storage and transportability as propane. Next, EPD is also key to declare embodied carbon. We see an increased need for environmental products declarations, EPD, from our stakeholders to either compliance to green building rating systems and their local building energy codes. Like in Singapore, we are looking at this Green Mark, US LEEDs, UK BREEAM, and also in New Zealand, I think is this Green Star as well. So AGC is proactively arranging these EPD globally, and we start to obtain this EPD for Asia products from year 2022. Next, we look into advanced energy strategy solutions for the facade. So what are the reductions strategy for high energy consumption building? And also the goal is to be a low energy consumption. One is actually by using energy saving glass, which is to reduce the consumption, and also by using this energy generating glass to actually offset the consumptions. Together, it will reduce the dependence on this electricity grid and also a lower operational carbon generated. Energy saving glass can significantly reduce the need for heating and cooling, thereby reducing this energy consumption and also associated CO2 emissions. Wide range of solar control and low E coatings to meet various requirements and are also suitable for residential, commercials, and also industrial segments. With world-leading coating technology and wide range on coated glass like Stopway, Synergy, Stopso, Panel Belt, and more, we, AGC, have all these hard coating and also soft coating products to meet different needs and for every projects around the world. We also have on-site renewable energy generating architecture glass. To have on-site renewable energy, most of us would think about solar panels on the rooftop. But we know that there are limited areas on rooftop areas on most high-rise buildings. They are the HVAC's equipments, ventilation fans, cooling towers, M&D ducts, etc. So why are we only focusing on the roof area? How about other areas of the building, like the facade, the skylight, the balustrade, and also the walkway? BIPV, Building Integrated Photovoltaic, or we call this BAPV, Building Applied Photovoltaic, is a good solution. Solar cell is actually embedded using this interlayer and two pieces of glass and becoming a laminated architecture glass with an air spaces with air or argon and also another piece of glass. It can become an IGU or a DGU unit. Highly customizable and various applications, and so also it will be able to contribute to net zero energy. With it, we reduce the need to encourage land and water waste for solar farms, start stations, and also transmission grid, and also able to increase reliability and sustainability and also enhance energy efficiency. We can do this by actually with the on-site renewable energy that will be generated within the building itself and for a greater environmental sustainability. This will also has the ability to act as an emergency power source in the event of a natural disasters. One instance in these applications, AGC Kajima plant, a net zero energy building project completed in December 2018. In this project, vision stripe is used on the front side of the main building in order to realize a transparent look while maintaining high efficiency of the power generation. On the right, you can see a photo of the main productions factory office building. On the bottom left, you can see the energy consumptions by the building. You have the aircon ventilations, lightings, hot water supply, power needed for the elevators. By using energy-saving measures, such as low-E DGU coating glass, raw materials for installations, it can reduce energy saving by 50.4%. However, the goal is to design and build a net zero energy building. This is where this AGC sign BIPV comes into play. With the additions of visual stripe on the area about 130 meters square, we can achieve an addition of 13.4 kilowatt, giving us 114 reductions of the actual energy consumptions used in the building alone. Together with the rooftop PV, it actually creates energy that goes beyond the requirement after studying on the aesthetic appeal points as well. AGC Signboard BIPV, we have a wide range of both transparent and also opaque solutions products. Transparent range such as these visual square and visual stripe allows lights to penetrate in and also at the same time harvest solar energy. Opaque solutions, stop reactive, are light active, allows you to have a seamless range of glass compositions, colors, patterns, without compromise on the aesthetic overview of the facade while also generating energy for the building. The beautiful point is that AGC, we can customize the dimensions, thickness, the size of the panels to different designs, shapes for different aspects and requirements. The positions of the solar cells can also customize to make the most of the natural light and can create a see-through effect. Example for the projects on the right that you can see is called Hikara Building. It's done in Lyon, France. Visual Square is actually used as an application for the double skin to cover part of the facade. It's the first positive energy building in Europe that comprises of office, retails, and apartments. As you can see on the picture in the center, the solar cells are actually positioned on top and below of the glass facade, but not on the visual area. This is customized so as to enjoy the view while also harvesting solar energy to offset the energy used by the building. Other references like this top left in Thailand using the canopy as canopy. The spacing of the solar cells are also customized to enhance visual light transmission. And depending on the time of the day, it also creates square design on the wall area with the casting of the solar cell's shadow. Unlike active, the light bulb design, you were taught that the light bulb design is actually just there to enhance the look of the building only. You will not know that actually it also harvests energy and also provide power to the building also. It seamlessly integrates to be part of the design of the building. And this bifacial cell is always used on this balustrade in Japan, Tokyo, University of Agriculture. During the morning, BIPV is actually able to harvest energy from the east, and during afternoon and evening, the west side. Furthermore, the position of the solar cell are customized on bottom half of the panel, and the top part of the panels are still able to let the public to enjoy the visual of the wonderful view of the city. One project in Melbourne, Australia, RMIT Design Hub, with the geographical locations of Australia from the equators. This visual square is actually customized on the circular shape facing the north. Visual square is also used as fins in one project in Belgium, acts as a shading device and also harvesting solar energy. Office building in Malaysia, Penang, visual stripe is actually used at the reception and pantry area, look like a blinds, which also able to harvest solar energy and without blocking the wonderful view. Examples like also using on the walkway, the noise barrier, and also many other more different applications. So our team based in Singapore are able to assist in the design stage with data such as solar path simulations, solar aggregations data based on different applications and also elevations. We also are able to give this kind of energy generating properties like the module efficiency and also output energy properties and specifications. And also glass performance like the SC value, U value, and also other light properties for facade calculations. We are able to provide expertise advice, technical assistance, and also with having a good track record with our project reference will give your potential on-site renewable energy project a peace of mind. So let's be a driving force for the future of buildings and the environment. Carbon neutrality is difficult, challenging, but still possible. Everyone, the design, architects, consultants, are actually influential in helping everyone to actually achieve its net zero goals. So I end my presentations here, and thank you everyone for your attentions. Thank you.
Thanks, Marcus. I think sustainability is going to get more and more important. I mean, BIPV, a lot of jobs we start talking about BIPVs and then it gets value managed here, there, and everywhere, and we just end up with clear glass, Karl. But I think it's going to be more and more difficult to value manage these things out, and prices are coming down, so certainly more and more acceptable. Our next presenter, Angus, met you 15 years ago talking about fabrics. Today, he's still talking about fabrics, so welcome, Angus, from Vector Foiltec. Lightweight roof design, doing more with less.
Thanks, all. Cheers. Yes, clickers here. Well, hello everyone. As Oliver said, my name's Angus Macleod from a company called Vector Foiltec. We're ETFE specialists. And if you'd like to know more about ETFE, please come and speak to me. I'm not going to try and talk about ETFE too much in this presentation. I'd like to talk a little bit about lightweight roofing, lightweight cladding design instead, and some of the principles that we use when approaching any particular project. So I thought I'd talk a little bit about the philosophy that we follow, and then segue into a whole heap of case studies from projects around the world that we have done. So as philosophy goes, we generally start with material efficiency. So we're trying to do more with less, which strangely enough is the topic of the presentation. It's not the same as minimum weight for span though, because different materials, different structural systems, they have different priorities for us to try and design for. Obviously these days sustainability is a big thing, so we design minimum energy and embodied carbon and try and communicate that through to the rest of the team through green star ratings, LEED, whatever. Operational efficiency can be pretty much whatever you want it to be. There are different aesthetic principles involved, there's client-defined principles, and so on and so forth. Form versus function, a topic by itself. I could spend an hour or two up here talking about that, but that's dealing with shapes versus the aesthetics. And these are all things that we try and run through with the design team when we get involved on any particular project. Also, the difference between tension versus compression and bending. Different materials have different specialities. Steel, for example, much better in tension than concrete is. So we try and use sympathetic materials for those type of technologies and apply them to lightweight structures. You might recognize the image in the top right there, recently completed Tommy Dome for Auckland Zoo, done with Ignite Architects and Studio Hanson Roberts and New Zealand Strong as the head contractor. And in the bottom left there, you've got a little canopy that we've just completed for a shopping mall in Phnom Penh, Cambodia. So we get involved in projects all around the world. Me personally, I do Australia, New Zealand, and I'm also technical director for Singapore and Southeast Asia, so I get around a fair bit. If there were any tips that I was going to give to the room, I'd say define your constraints early. Lightweight structures are an iterative process, so defining your constraints very early on in the piece allows you the flexibility to optimize later on in the project. We're at a point in time as well now where we've got so many tools available to us, whether it's Rhino or BIM or whatever, that we can, as a group, investigate lightweight structures very simply in our own offices. So that's a great starting point for anyone to try and do lightweight structures. And lastly, I'd always communicate to the client that the design component is a lot higher with a lightweight structure than with any other type of structure, because you've got an iterative process. You're trying to do the design 3 or 4 or 5 times to try and get the most out of what you're trying to do. So flipping through to some case studies, this is one we completed about 2 years ago in Penang in Malaysia. The client came to us. They were a private consortium backed by IKEA, which is a nice big blue box that you can see at the end. They wanted to create an urban street environment for a series of shop houses. The initial concept that was presented to us was a very rectilinear style flattish roof with returns on the ends. And Vector Foiltec were retained as principal consultant on the job with another architect. So all the services engineers, facade engineers, everyone was underneath us. We did design, supply, and install of the whole lot, including the steelwork. Like I said before, the initial concept was a very flattish roof. We ended up with a slightly different scheme where we actually clad the bottom of the soffit of the system. So an overslung structure, 40-meter odd clear span, about 2.75-meter deep truss, Ended up about 55 kilos of steel per square meter, so pretty efficient from that side of things. And about 12% of the equivalent carbon content compared to a glass-style system. About 320 meters long as well. One of the interesting approaches that we did with this project was to recognize that Asia has a problem with steel and with welding and that side of things. They've actually very heavily invested in robotic welding because people and the QA of the welding were a problem. So robotic welding, fantastic, we love it. Custom box sections suddenly become a lot more economical. It allows us to put the weight where we need it. So around the support. So we can go away with a 320 by 450 high box section around the perimeter, but we might be changing the wall thicknesses of that from 16 mil around the supports down to 10 mil in the middle. So we start to create buildings using these shapes, which are not exactly off the shelf, and obviously plates are a lot easier to get hold of than hollow sections these days. We printed it with a light grey dot pattern as well to control the solar heat gain. And we changed the form as well. We introduced a wave shape, and that was partly to try and get rid of various returns that the client had originally had to control the wind-driven rain. That was just adding weight and structure where you didn't really want it, and use the shape of the structure to try and promote some other things, not just wind-driven rain, but maybe ventilation and airflow as well. The shape of the roof draws air through, gets rid of the vehicular smoke, fumes, etc., build up. Also, it allows us to concentrate the water drainage as well. Being Penang, very high amount of rainfall, so we've got to control that water and try and harvest it as well for use around the rest of the complex. This is the final result, painted the steel a dark grey colour, which works very well with the local theme of black and white for shop houses, and gives it a very striking look. And just so that you know these aren't photoshopped, here's a nice little drone footage of what it's like to actually go underneath it. So I think you'll agree that it's quite a positive response to the environment. Next case study. This is a project we completed in December for a shopping centre in Canberra, Australia. So Canberra is quite an interesting environment, very cold in wintertime, very, very hot in summer. Shopping centre client, link bridge in between two halves of the shopping centre, and they wanted a freestanding canopy on either side of the link bridge. Now, the more eagle-eyed amongst you will notice that this is a grid shell, and that we've actually introduced compound curves into the structure as well to try and promote some structural efficiency and give it a bit more of an architectural look rather than a standard grid shell. So we got down to about 60 kilos of steel per square meter on this one, with columns and connections. Again, Vector Foiltec were the principal consultants. So I had structural engineers, mechanical engineers, and so on and so forth sitting underneath us. Utilizing standard size CHSs in this case, because the Australian industry isn't quite set up for the robotic welding. Potatoes, potatoes. And again, down to about 13% embodied embodied carbon. One of the key things that we did on this job to try and maximize the efficiency and reduce risk was a wind tunnel test. Now, the engineers in the room will go, it's a freestanding canopy. You can get straight out of the code, no problems. We were a little unsure about this because of the proximity of the adjacent buildings and also the effect of the link bridge in between. So we thought, for $25,000 in 4 weeks, that's all it cost us. We were able to really reduce the overall risk on the job and really get the design efficiencies out of it. We managed to reduce the code-based pressures by over 35%. Plus, we were able to identify that there were key areas around the structure which had the local pressure coefficients weren't quite as bad as what the code was saying. So the code was saying about 1.3, 1.5 kPa local pressure coefficients, and you can see that those higher pressures, the 940s of this world, are only happening in various different locations. The rest of it is much lower, less than a factor of 2 in some cases. So that enabled us to introduce more design efficiencies into the system. Yeah, significant improvement. Same project during the day from above versus at night from above. So ETFE is quite an interesting material like that. These cushions are around about 3 meters wide by 35 odd meters long, or thereabouts. We designed for various different conditions. There's the unbalanced loading from installation as well. On the left here, you can see we're using a trafficable safety net system, which is very popular here in New Zealand. Also, the structural trees, the columns in this case, the client really wanted to, as one of these operational parameters, he wanted a tree trunk. He wanted the mass of the tree there. So we created this out of lighter gauge sections and then bunching them together to make them work compositely. Much more efficient and much easier to get a small diameter CHS than a big one. And going back to the idea of extra design, when you're pushing the boundaries of lightweight structures, you're optimizing the system, you're optimizing everything, and you've really got to go that extra mile to make things work. But that's only going to be efficient if you communicate that information through to the steel detailers and the steel fabricators as well, and get them on the same page. Extra design, extra coordination. Little closer to home, a project we finished about 2, maybe 3 years ago down in southeast Auckland called Botany Garden Lane, again with Ignite Architects. Here, again, we were one of the principal consultants engaging the structural engineer and the wind tunnel underneath us, but the rest of it was done through client-based consultants. And they also sourced the steel locally as well. Steel grid shell on the top, supported by timber arches. Next. There we go. So about 77 meters long. This is an example of some of the EPD information. I heard Marcus talking about his EPDs earlier, and that's definitely the way the industry is going. You know, communication of all those sustainable criteria through to the rest of the team. So here, this is an example of one of the calculations I did for this project, where you can see that we're using about 17% of the primary energy of an equivalent glass style system. We've got about, I think it's 20, where's the CO2 down the bottom there? 43 tons of carbon, which is around about the same as 10 cars would produce over the course of a year. We got to 55 kilos of steel for this one as well. So it's not bad from the click. Yeah, the center white one's not working. That's all right. We're just going back to the computer. One of the operational parameters that the client introduced for this job was, I want maintenance to be really clearly defined, maintenance and access. So we instituted a trafficable section down the center line of the top, complete with static lines and anchor points so that it could be effectively maintained, and that addressed his concerns. From inside during the day versus inside at night, so the reverse of what I was showing you before on camera. Again, the eagle-eyed amongst you will notice that the right-hand side there is a slightly darker print than the left-hand side. So this is customizing for the retail environment, putting a heavier print on the north side where you're getting the summer sun coming through, and a lighter print on the south side to try and regulate the heat gain in that space. But you really can't see it at night, so that's fine. And again, a short video just to show you what it's like on the outside. During installation, you can see these are highly curved, warped style cushions, very irregular geometry of structure as well. All fully modeled in 3 dimensions, worked closely with the steel fabricators and the architects as well to try and create this shape. It's meant to be reminiscent of an eel net, by the way. This is one of my personal favorites. I've spent way too much time designing this one. Surbana Jurong in Singapore. Surbana Jurong are a big engineering consultancy. They work for a lot of government style projects over there. Their speciality is tilt-up. So nothing lightweight about that at all. They came to us with Moshi Safdie Architects and said, please fill in this hole. We've got a nice big roof. It's about 40 meters span at the back, about 25 meters span at the front. Fill it in for us. So what we decided to do was to put in a cable truss. Now, these are very rare. I've personally only done about 4 or 5 of these over the last 20-odd years. Cable trusses are fabulous. They look amazing, but they require a lot of structure around them to support the pre-tension loads from the cables. So we had 3 separate roofs here bound by 4 different buildings. We took it all the way up to BIM 350 for them. Custom print pattern, just because the architect just wanted something else that was custom on the job, as if the cable truss wasn't enough. And about 4.2 meter wide cushions. And installed. So the dots you can see there in the cushions on the right, in the center, are something called the water ponding valve, which I'll come to in a short while. We've got a folded plane style geometry to try and funnel the water to a central gutter, and then we collect it at the bottom again for water harvesting purposes. You can see you'll see some images of the print pattern in a few minutes, but in terms of a structural arrangement, and bear in mind that these are 4.2 meters apart, we've got 2 28mm diameter stainless steel cables as a top cord. Bottom cord is a 32mm diameter stainless steel cable and 16mm tie rods tying it together. So we've got opposing curves giving it structural efficiency, getting down to less than 10 kilos of steel per square meter. And Vector Foiltec, again, design, supply, and install on this job. Tensys we had as our engineering partners, but working with them to get the best result for everybody. We do a lot of design on these projects, whether it's water drainage from the top surface, water reticulation. There's also, with ETFE, there's a disaster scenario of what happens if the power goes out and it starts to collect with water. So we have to analyze, particularly for a cable truss system, for those style of events, because point loads in the middle of a cable truss is going to be a very bad day. So there's a water ponding valve technology that we've developed to try and drain water through if the water level gets above a certain amount. So those really help us achieve structural efficiencies. We also decided to make the gutter part of the structure. You know, if we're going to have a gutter there, then we might as well do something with it. So rather than having 2 pieces, we have 1. So we embedded the gutter within the cable truss arrangement, make it nice and solid, so we've just got 1 element up there. Installation was a bit interesting, but we got through it. Custom designed stainless steel clamp arrangements to try and connect the cables back to the gutter or to the rest of the structural truss. You can see the stripy pattern here because the architect really wanted to go that way. I'm not really sold on it, but okay, whatever. Another custom clamp there you can see on the right-hand side. We call that one the football for obvious reasons. And then detailing around the perimeter as well. Cable trusses are notorious for the amount of movement that they have. So having to design cast-in connections into the concrete, integrate the air supply hoses. We actually cast in the pipes into the concrete as well, and still allow for the rotational movement that all of these systems require. And I think you'll agree that the end result looks visually spectacular. It's about as lightweight as you can theoretically possibly get. Big reaction forces? Yes. Big structures beside it? Also yes. But visually magnificent. Anyway, thank you very much for your time. I believe coffee is next, unless we've all gone over. Thank you very much.
I think sustainability, like you said, is getting it right, using less efficient design, durability, and all that. Anyway, we've got a 25-minute break for coffee, but can the presenters please stay back for a... sorry, come on stage, and we've got some photo sessions, but coffee is served on, David? On the right. As instructed, we shall proceed. Our next speaker is from St. Gobain, Jean Lorenzzi, Studio Director of Digital Building Glass. He's going to talk about decarbonization and digitization. Thank you very much, Jean.
Thank you, Olivier. So the presentation, how can I shift there? Perfect. So before I start, I just want to tell you, St. Gobain in Oceania, we have a representation that is, the people that are here is Bill Segard and Cleet Elliott. So if you want to talk a little bit more later on about what St. Gobain can offer for you in New Zealand and of course and also in Australia, come to discuss with us, okay? So I will start with a very important topic for St. Gobain. Mainly two important topics. One is the decarbonization of our process and our products, and the digitalization. As you know, we need to do something because climate is changing quite fast. It's becoming a mess. And as you know, buildings are part of the problem. So there is building are contributing a lot of problems that are happening, and when we look the challenge that we have for the construction market, so we see that carbon, of course, we see also how can we use better our natural resource and make that in a circular way. And of course, working to make the people life better, health and well-being. St. Gobain has committed since a long time ago to be net zero carbon, and by 2050. And in our proposal and the things that we are working on every day is to try to making the world a better home. So in that way, St. Gobain, we launched last year a new product that is a low carbon glass, and then you will talk a little bit about this product. When we see the carbon emission during the life of a glass, we know that operational carbon is very important. So, as you know, we are working a lot to try to make products better, building houses more efficiently. And of course, this amount of CO2 we will decrease in the next years. But it still have the emission during production. And when we look, the BG&E buildings represent today a big part of the cake. Almost 40% of the gases are coming from buildings. And those 40%, more than 70% are operational carbon. And then I think that we are doing a good job. H1 are going in the right direction to improve quality, efficiency, and of course, you will reduce the operational carbon in the buildings here in New Zealand. But studies are showing that because we will work on that way, in 2050, the relation between operational carbon and embodied carbon will be 1-to-1. So we need to do something, but we cannot forget the operational carbon. So if I do something in the embodied carbon and in the way I choose not the right solution or use a double glazing clear instead of a good low E or a good solar control, we can lose quite quick what we gain in the production, okay? This is one of the reasons that we are pushing and we are proposing more and more magneto-coated glass because our products that we know that reduce the operational carbon. And those products is really what we want to move together with a low carbon glass. We are seeing a lot appearing either by regulation, trends, and green labeling, notation of how much is the threshold of your product in terms of CO2. They are asking us, so tomorrow maybe we will have a number for a facade that need to be, I don't know, 200 kilograms of CO2 per square meter of a facade, and then everyone need to contribute glass, aluminum, and the other materials. We are seeing already in Europe those requests, instead of getting, vision light transmission, solar factor, thermal insulation, we are starting to be asked how much CO2 are you delivering as well. And then you remember those almost 40% of emission for buildings. When you will look, the building facade correspond to 10 to 20%. And then when you look close to glass, is between 4 to 12%. So, and then since we are moving more and more to have a 1-to-1 ratio, we need to do something, and the glass will become a very important player to reduce the carbon in the building. This is one of the reasons that Saint-Gobain, we work really hard to try to decrease our carbon footprint. But today, we are trying to do that keeping the same quality of product, same performance, same aesthetics, as a clear glass. But try to do that not in a lab, but in a real industrial scale. Tomorrow, if everyone wants to move that, we need to be prepared. This is one of the reasons that we launched last year. It was the world first low carbon glass. So, and then what is behind OHE? The OHE is the name of the substrate. So, the low carbon glass. It's how we do that. We use highly content of kellet, to produce the glass. More than 55% of the recycled glass that we put back in the furnace are coming from external source. It's not coming from our factory inside. So we are taking back. Of course, today it's the end of life kellet. It's quite hard to get because most of the time, 99% of the during the construction, glass goes to the field. But we are trying to improve that more and more. We are using, of course, in the process, renewable electricity when electricity is required, and at a substantial effort in R&D and with our industrial team. The result of that is a product, in the end, that we have 40% less carbon footprint if you compare with our standard production of a clear glass. That is the magic number that we get, is 7 kilograms of CO2 equivalent per square meter when you compare 4 millimeter clear glass. If you translate that in a glazing, we can go up to 25 to 30% reduction in terms of CO2. Of course, as I said, kellet is a very important part for us because, and then Saint-Gobain, we are trying to push, and then in countries like UK, France, Sweden, we have a kind of complete service to recuperate end-of-life kellet. So we have initiatives that go on the site, we take back the windows, and then we treat that, and the glass come back into the furnace. But as I said, it's important to keep also the operational carbon, and the offer of low carbon glass today is associated with a product that it's deliver, the best in terms of energy efficiency. So we are proposing OHE with our, the best products today. That is our, what we call triple silver product, that in our range is called Extremes. We want to have performance and sustainability together, This is an example of an offer that we have. It's if you take a triple glazing, all the materials is with OHE, And this is already a reality. So we have already delivered 3 projects in Europe, in France. We are discussing more and more with customers. We have projects in UK, Italy, Sweden, and the US, where they are pushing us to have an offer and to have, to have this product for them. Certification, these products, of course, to be able, to have the number, we want also to be certified, and the product, it's a very long process to be certified. EPDs, we did 4 productions already, and we are expecting to get the results by the end of the year, by the end of March, sorry. But the other products of Saint-Gobain, we have EPDs since long time. So any other products, we already have EPDs for that. The second topic that I want to share with you is the digital tools. During the glass selection, as you know, we are discussing with architects, facade consultants, facade engineers, facade makers. It's a very complex process. Sometimes very difficult, each one are pushing for this or that data. And what we, in Saint-Gobain, we are trying to do is to develop a service to support customers in the choice of the right glazing. We have basically 3 main services for that. Calumen, that is the service where you can find all the technical data of the products, even CO2 footprint. Today you can build a triple glazing, double glazing. I can tell you which is the carbon footprint of this configuration. Visualization, that is very important to see how the glass it will look like in a physical, realistic way, not Photoshop, not RGB rendering. And we have also other service that's based on building size, so what we can see and simulate the energy efficiency of the buildings. Today, we will launch, but in 12 hours, because we are 12 hours ahead, a new service, Calumen, where you can find everything there. It's a complete redesign service where you can find, simulate, calculate, choose the right glazing. You have image. You have it's for everyone in the construction business. So Calumen is really one of our main tools. As I said, we have calculation, but we have also nice services to simulate the aesthetics of the building. We know for some of the actors, aesthetic is very important. And the glass, the selection of the glass, is sometimes the project will be done in 2 years, but we need to select the glass today. And what happened mostly is like that. Architects, they have the renderings, that's his artist, is very nice. But the glass, they are expecting that, but in the end, the glass will be like that. Because they cannot predict the aesthetics of the glass. Glass, if you see renderings, glass is transparent. But with, a solar heat gain of 0.2, glass will be a tint, so you'll be a shade, you'll be not like that. Because glass is a complex material for light. Light can be reflected, transmitted, absorbed. Glass is not only one piece of glass, it's several pieces of glass, different materials, interlayers. And buildings are always changing as a function of angle and as a function, of course, the weather. We develop a system where we can assist customers on that we can work directly in the 3D model of the customers. We design an environment and we put the glass on that. And the glass is really a reliable process because what we have behind is physical data. It's a spectral data of our products. And we have a completely process to qualify and to know that what we are doing is reliable. This is basically the process. We get some information for our customers. We have a team that they take the 3D model. We can go and back with some proposition, and then we came out with one proposition, and then in the end we have that. One side we have the art, that's very nice, the concept, when he puts science on that, and then we have the reality. Today we are doing more and more projects roughly 250 projects per year. We are doing for Force and Partners, Jean Nouvel, Renzo Piano. We are doing with a lot for them. If you have any questions, you can come, we can discuss, we can see how can we support on that. And for me, it's all. So we are doing glass since 1665, so it's glass we know. So thank you very much for your attention.
Thank you, John. Keywords: low embodied energy, energy efficient, recycled content. Should we be specifying percentages of recycled content of glass in our specification? Anyway, I'll leave you with that. The next presenter needs no introduction, but I will. CEO of Thermosash, well known and well respected in the facade industry. We're back on Horace. Why are we still specifying? And constructing leaky buildings. Sorry? David Haynes.
Thanks, Ahmed. Morning, everybody. Good to be here. Good to have your company. Cool. I thought I'd better put a stopwatch on this morning just to make sure I behave. I've been told I've only got 20 minutes. Thermosash reached out to Zak 4 years ago and discussed the opportunity of bringing their International Facade Conference to New Zealand as a way of giving something back to our New Zealand construction industry that has supported Thermosash over the last 50 years. As a high-risk producer statement author, I'm very aware of construction risk. In my view, facade subcontractors who accept design, build, guarantee of installed product durability contracts that include responsibility for time as a critical path subcontractor are working in the highest risk area of the construction industry. So why are we specifying and building leaky buildings today? Clearly NZS 1170 has allowable vertical and horizontal building movements. These allowable structure movements must be accommodated by the cladding design solution to provide a durable weathered performance. So you can see here the movements are pretty significant. You've got a beam span of 6 metres and you've got an allowable deflection vertically of that beam of 20 mil. So if you've got a 1200 wide RAB board, you're getting 8 mil rotation across its horizontal width. And because of the aspect ratio of width to height, you're getting 24 mil rotation at the other end. That's why we've got a lot of cracked facades and leaky facades. Cracks allow air infiltration. Air infiltration is the force that drives water into our buildings. The water, once it's in, is degrading our timber, secondary structural walls or steel studs. Because we're in a marine environment, you get an accumulation of chlorine and your steel stud will rot out. So it's pretty simple, people. These rotational movements are much larger than what people seem to comprehend and realise. And this is the result. And we're seeing hundreds and hundreds of buildings around New Zealand in our building stocks in New Zealand. And we don't seem to want to stop building them. So here we've got a similar situation. Obviously we live in the shaky Isles. We're exposed to a lot of seismic activity here in New Zealand. When you start moving a structural braced wall essentially laterally, floor to floor, and you've got thousands of fixings through your RAB material into your secondary stud support wall, then clearly you're going to have a lot of failure of fixings and breakage and air penetration and leakage. And it's the amount of time that goes by before people realise they've got a problem, and it's obviously too late at that stage more often than not. So here's what we design for our curtain walls and window wall solutions. We have these movement joints in our systems, both vertically and horizontally. Where do you see these sort of movements being built into secondary structural walls or even rain screen systems? You see rain screen systems running through continuously over floor slabs, and they're going to fail. It's just when and how long it's going to take. So it's all pretty humbling, really. Professor Tim Sullivan at the University of Christchurch recently seismically tested 4 different floor-to-floor window glazing systems in 10 different combinations mounted on the new University of Christchurch shake table, and tested them to only plus or minus 12 mil interstory building movement, and followed by a weathering test to NZS 4284 2008. This is a testing code for all building claddings. It doesn't need to be just windows or curtain walls. It's supposed to include all cladding systems. So this plus or minus 12 mil seismic movement is typically half to a third of what we're typically designing our facades to accommodate. Remembering that anything up to an SLS movement must remain serviceable and durable for New Zealand code compliance for a minimum 15-year period. The University of Christchurch seismic testing achieved a 100% failure rate. All of the test units failed this New Zealand code compliance performance requirement. What is really scary is that they used tradesmen of a higher skill level than normal, and they knew their work was going to be seismically tested and then water tested, and they still all failed. The 100% cladding failure rate to accommodate even a low-level earthquake of plus or minus 12 mil highlights a number of key failures by the building industry. Risk management, procurement of fit-for-purpose product solutions, limitation in knowledge of code minimum performance requirements, lack of coordination between consultants and subtrades, construction and installation failure, lack of adequate QA/QC, gaps in regulation, lack of industry knowledge and skill. Thermosash complete building inspections for clients purchasing buildings. Typically, we will complete AAMA field weathering tests and check structural adequacy and seismic capacity. This project was 5 years old, a 5-storey multi-floor NZS 1170 structure. Domestic windows were used, and I've been doing this for pretty close to 30 years. I've checked probably well over 100 buildings in this sort of environment, and I haven't found a building yet that complied with code or performed. Our joint and several New Zealand law and 10-year statute of liability period places a high level of liability and risk on any company accepting design build responsibility for work completed, particularly around acceptance of openings and structure prior to starting work, and then submitting a PS3 construction producer statement which formally acknowledges that work has been completed in accordance with the requirements of the building code, confirming that their installed end product will be durable for a minimum 15-year period. Over the last 85 years in New Zealand property, this asset class has increased in value by close to 8% compounded, which means that it doubles in value within 10 years. Let's consider the consequence of time on a 10-year guarantee from a liability perspective, which is also impacted by inflation on labour and materials. It's very likely that a guarantor's liability will likely double over a 10-year guarantee period as well. Roughly 20% of Thermosash's workload involves the recladding of multi-storey secondary structural walls and rain screen leaky buildings, typically 15 to 20 years old. Most have highlighted facade performance problems within the 10-year statute of limitation period, Yet it takes another 5 to 10 years for the parties to work out a way forward. Clearly, the primary structural frame is more durable than the rain screen cladding systems originally specified and constructed. Has the construction industry worked out yet that just about every rain screen clad multi-storey apartment building in Auckland and Wellington has failed and been involved in a reclad, with a significant number of our schools and hospital buildings as well? It's worth noting that the cost of just recladding these leaky buildings, due to the significant consequential costs involved with legal action, redesign, reconsenting, demolition, reconstruction, finance, insurance and relocation of tenants or owners during the construction period, is costing more than the original total project's cost of construction. When the public take out a 20-year mortgage on a property, if the cladding does not perform, it will and has caused massive erosions of wealth for property owners over the last generation and productivity loss for our whole economy. When the cladding system solution costs roughly 10 to 12% of the original cost of construction, why wouldn't the industry use a proven engineered solution with proven durable performance that costs roughly 1 to 2% of the original project's construction value to mitigate and manage this significant risk? Peter Lawless, Karl Jones, John Sutherland and Diane Johnson wrote a world-leading technical paper on weatherproofing risk matrix for multi-storey buildings, which highlights the best solutions and key variables that need to be proactively managed with discipline through a specific design, cladding specification and tender procurement process. If you are a student of history, some of Auckland's reclad projects are now being reclad for the third time. And it's also interesting to note that 60% of Canadians' early leaky building reclad projects were reclad again, which is worth thinking through by the New Zealand construction industry. The architect is responsible for the design, indicative detailing of the cladding solution on NZS 1170 structures, form and function, but they do not sign producer statements accepting design responsibility. On that basis, a facade consultant is normally employed to assist with the facade design and facade specification, which, due to professional indemnity insurance liability today, follows international best practice that very clearly transfers design, build, guarantee of durable performance risk, liability obligation onto the successful facade subcontractor, with the design risk transferred through a tender procurement process involving a main contractor who is also involved in a competitive tender process, which is then eventually evaluated against a client's quantity surveyor's budget. Typically on historical construction data from previous projects, typically clad with secondary structural walls and rain screen cladding solutions. The building industry needs to break this cycle if they want to stop building leaky buildings. The main contractor may not think they have any design liability responsibility. However, one of their key critical path subcontractors does. If there are any downstream durability problems with the installed end product, however, they will be drawn into any downstream legal dispute due to their role as an experienced contractor responsible for coordinating, managing and supervising the work with duty of care obligations. Who then is responsible for the PS1 design producer statement for the secondary structural wall support structure and its ability to accommodate allowable NZS 1170 vertical and horizontal structure movements, and the ULS load transfer of the RAB and rain screen connections? I do not see anyone accepting this design responsibility and liability. Who was responsible for the PS1 design producer statement for the RAB, rigid air barrier, and critical rear air seal? The material used and the stud centres required for structural support under ULS suction loads and its fit-for-purpose minimum 15-year durability, given the thousands of fixings and tension penetrating it, along with lateral building movements and bracing forces. I do not see anyone accepting this design responsibility. Who was responsible for the PS1 design producer statement for the rain screen connections, load transfer onto the secondary structural wall, and the thousands of fixings through the RAB and weatherproofing risk with NZS 1170 allowable vertical and horizontal primary structure differential movement accommodation? Who of the 5 parties involved with this cladding type is responsible for the durable performance of the installed end product? All will be joined in any resultant downstream legal case. How many will still be in business 12 years later to honour their guarantee liability? It's worth highlighting that rain screen solution must be removed to obtain access to resolve any... It's worth highlighting that the rain screen solution must be removed to obtain access to resolve any RAB weathering failure via external access. The New Zealand public purse, through council rates, has largely underwritten the commercial risk of our construction industry end product to date. How sustainable do you think this is with our next wave of E2, VM2 unitary plan apartment construction wave currently under construction, with producer statements now required from industry? So how do the highly litigious construction markets like North America, for example, Canada, who have experienced a significant leaky building construction event, and the USA, how are they cladding their multi-storey, high-rise, high-risk apartment buildings today? These buildings are all clad today with prefabricated, modular, unitised, single-sourced, engineered cladding solutions that are designed to accommodate the primary structure movements with integrated rain screen elements, opening windows and doors with high-performance IGUs. The client and main contractor's P&G cost of time on a project equates to roughly 1% of the project value per month of the total construction cost. This will fund the perceived extra cost of a rain screen secondary structural wall against a single-sourced, prefabricated total clad solution. Essentially, there is a 2-week construction saving per floor minimum between the 2 types of cladding design solutions, with only one solution providing durable weathering performance. A focus on time, the cost of time, and the speed of construction benefits, which also manages and mitigates construction time risk from other typical construction delays, as a benefit. A focus on quality and resultant life cycle durability of the installed end product and its proven weathering performance. The resilience of the cladding solution selected is crucial after an event so that the tenants can continue to trade and pay rent on a hospital to keep operating. The focus must be on best value, which is a function of time and cost and quality to achieve a better outcome. The benefits of one total clad system warranty, and I do not need to tell you that New Zealand has very high levels of combined wind, rain and seismic loading. Multi-storey buildings are obviously exposed to significantly higher weathering seismic loads and risk. The cladding industry, specific design cladding industry, is complex. The prefabrication modular total clad solutions are not cheaper, but they will save time and improve quality and generate a better outcome by managing traditional construction risks. Search Google for any supporting technical articles. There's thousands of them. Prefabrication reduces the number of junctions between trades and construction trade interface problems. Prefabrication and standardisation of process improves QA/QC, increases productivity in a factory-controlled environment under gantry craneage. Prefabrication reduces weather delay risk. Prefabrication reduces the number of trades on site, reducing the volume of coordination and management. Prefabrication reduces materials stored on site with just-in-time delivery. Prefabrication reduces the need for external access, saving the cost of scaffold access. Prefabrication reduces the risk of delay due to council compliance inspection pathways. Prefabrication reduces OSH risk. Thermosash would not be in business after 50 years if the business had problems with their specific design system solutions on the high-risk projects completed over this period of time, which, funnily enough, represents a safety factor of over 300% of the New Zealand durability requirements under the New Zealand Building Code. The building industry will not increase quality, improve productivity, or deliver projects on time until the building industry leaders stop specifying and building leaky buildings. How much more proof does the industry need that what we are building now currently is not fit for purpose? Thanks, everybody.
Thank you, David. Single source of responsibility, I think that's what it is. Our next speaker is an associate principal from Woods Bagot. He's going to talk about tower facade design and respond to site contacts and locale. Blair Parkinson.
We good? Great. Thank you. Kia ora. Today I'm going to be talking about tower facade design, 3 projects that we've recently completed or have been in the works from the Melbourne studio, where I've been at for around about a decade now. So we've got a lot to talk through. I do apologise if I'm going to be talking fast. You are going to have to listen faster, so let's get into it. The first project, 80 Collins Street. 80 Collins Street came to our office in 2006 and received practical completion in 2020, so a 14-year design journey for us. It was a collaboration with UN Studio and Joan Mancu, a Parisian-based design firm, and we're pretty stoked to have picked up the best mixed-use building in the world at the World Architecture Festival. It's also in the running for Arch Daly's Building of the Year 2023. It's a true mixed-use project in the sense that it's got a 42,000 commercial office component, 6-star Green Star PCA, which is the same as PCNZ, premium grade office, a 4-star hotel, and 5,000 square metres of retail at the base. It's located to the eastern end of the Hoddle Grid in Melbourne. If anyone knows Melbourne well, that's what's colloquially termed the Parisian end of the city, which us as architects hate. This was Narrow House. Narrow House was on the site previously. It's been in Melbourne since 1977 and is one of the first 50-storey plus towers in Melbourne. This was the existing ground plane, so you can tell that it was quite brutalist. So our us as designers had to come in and effectively look to reinvigorate that as a precinct. So we retained Narrow House, even though given the size of the site and the location, demolishment would have actually created a really fantastic commercial project, but it was all about sustainability-driven design. Let's keep the tower and let's look at reinvigorating that ground floor plane, building laneways through to, I guess, speak to the current Melbourne condition of quite a laneway-connected city, building up a retail base, the hotel, which is a small component which actually faces onto Little Collins Street, and then the commercial tower to the south, creating a 24-hour precinct. And when you combine the two towers, it's effectively just under 100,000 square metres of NLA. It was a shared sustainable approach. I think a few benefits from having a tower directly to the north is we lessened the impact of north-facing facade and north-face lighting coming in. We also had a western-facing side core, which really meant that the tower itself was facing south for us, which assisted us greatly. The tower is effectively broken into two components. The trunk is coloured in blue there, and the yellow, which we referred to as the lantern. And it was a symbolic reference to the street lanterns of Collins Street. These are the elevations of the facade. You can start to understand how close we got to Narrow House, but given the octagonal floor plate of Narrow House, it actually really helped us with not feeling like we're hard up against the building. It's nestled within quite a densely designed area. There was a lot of existing buildings and towers in and around it. So really we had to stand apart from the rest and create a beacon for this end of the city. One of the kind of the main design considerations that we looked at with this lantern was chamfering the base of it. And we did that for two reasons. The first was obviously the structural loading of this cantilevered structure to tie back into the core. The structure itself sits 10 metres proud of the main trunk and sits about 40 metres above the ground plane below and above heritage buildings below. The other reason was, I guess it's getting designy, but it was about reflecting a pedestrian's street condition back at them. So it was a way of connecting a tower back down to a ground plane. The facade contractor was Yolanda, who is an Australian-based division of a Chinese facade subcontractor. They've worked on a number of projects with us, really actually quite fantastic work that they do. They've also worked on Sydney's Barangaroo, the new Perth Stadium, and also Samri, which is another Woods Bagot design project in South Australia. The facade design for the lantern is a faceted design. We looked at a diagrid pattern, once again referencing the lanterns down on the street, and it fluctuates by 500 millimetres, which meant we couldn't achieve that with standard curtain wall variation. It is a curtain wall unitised system. So in fact, every slab edge is completely different as you go up through the tower. Pulling back down to the ground plane, this is an old painting of Collins Street at the start of the 20th century. We really looked at the staggering of heights and datums and pulled that into a ground plane which is quite different to the tower sitting above it. This is limestone clad with bronze detailing and sits in harmony with the existing heritage buildings that are shown to the right of the screen there. The detailing of this allowed for tenants, or prospective tenants, to come in and work within a set of design guidelines where they could effectively retain the elements of the limestone portal and the bronze entry doors, but put their own flavour on how they're going to detail the internal components of this. A few more images of the street condition and the new entry that we provided to Narrow House. And then once you start to get into the laneways, we broke it down into an even finer level of scale and detail. So that bronze becomes lace-like in its appearance. And you really find quite a more congested and activated ground plane condition that is held by these facades featuring curved glass and moments of operation to allow for a closing down and opening up of the condition. The hotel, located at Little Collins Street, so to the north of the site, is in quite a densely populated area. There's buildings within 4 metres proximity of the hotel itself. So we went about looking at a facade design that was a lot more private based. So a standard fully glazed facade would lead to a considerable amount of, or lack of, privacy. So how do we go through a design where we break that down and start directing people's views out to the north and the south, where there's actually opportunity to see further than 4 metres beyond? The elevations of the tower show the hotel room condition and that faceted facade, and the fully glazed portions are where we introduce the amenity to allow more light and views into those more key public areas. This shows you the contrast between amenity, and it looks like they actually have to clean the glass on the left-hand side, but that is the hotel lobby, which is actually located on level 3. It has a sky lobby and a small ground plane lobby that connects up to it. And then in the hotel room, it's about providing a more private space. The facade was 4mm folded aluminium with Interpon D2015 as the facade finish. Next project we'd like to talk about is 447 Collins Street. 447 Collins Street, sorry, there's a little bit of a lag in the slides here, was a project that we won in 2014, working with Shop Architects, a New York-based architecture firm. We won the Victorian Architecture Awards for Commercial Development and the Best Tall Mixed-Use Building of 2022 and the Best Tall Building in Australia 2022 at the Council of Tall Buildings, which is an American-based outfit. This is even more of a mixed-use project than 80 Collins Street. It's got 50,000 square metres NLA of commercial office, a 5-star hotel, about 184 premium residential apartments, and a larger ground plane consisting of 1,000 square metres of retail. It's located further to the west on the Hoddle grid on an island site. Island site effectively meaning it's bounded by roads on all 4 sides. The massing of the building was defined by a shadow plane leading down to the Yarra River, which is to the south of the site there. It was actually quite interesting through the design process. This building was 10 stories higher because we weren't to overshadow the south bank, so the pedestrian zone of the Yarra River, and then a new government came in and they changed that to no overshadowing of the river itself, losing 10 stories in the process for us. So we took that shadow plane as a mass and then started to articulate it. Introducing public open space at the ground plane was a key concept for us, and also one where we worked with the City of Melbourne to achieve a really fantastic outcome, which we'll show soon. It was about creating a zone for that public open space to breathe, and then looking at idealised volumes that would work with the mixed-use program of the building. The commercial, which faces out to the west on the corner of Collins and William Street, the hotel and residential tower, which is a smaller tower on the eastern side. How do we then pull that up and around to suit the maximisation of that massing envelope? And then it was about pushing the form out to allow for greater views from that commercial volume out towards the east. And that's effectively how we ended up at the mass itself. The project was awarded to Multiplex in 2016 and construction started not long after. It's a 7-level basement with a highly articulated ground plane and varying facade conditions. 4 cranes were used on the project to complete it, and construction was completed in 2020 during COVID lockdowns, which I'm sure you know they were quite extensive for Melbourne. Once we got past the ground plane, it was 6-day cycles for each floor plate. I'll just let this play out. It's a lot longer than I thought it would be, sorry. Okay, so that was towards the end of construction. The ground plane took the time because we looked at really articulating the structure at the base. So there was a number of varying angled columns which were all designed through our software and fed to a facade subcontractor seamlessly to allow for accurate installation, or procurement, I should say, on site. These columns are a raw expression of the structure. There's no GRC cladding. There's no stone overcladding. It is precast concrete, and some of them are weighing 50 tonnes. So you can appreciate it took about 8 months of installation time to get this ground plane structure. But what it does is it really starts to frame a ground plane. This is the amphitheatre design, which faces out to Market Street, where we looked at combining that express structure with black butt timber, it's an Australian hardwood, and then a dual-tone stainless steel retail shop front. The park out to the right is actually a park that we created with the help of the City of Melbourne. We reclaimed half of the street, making it effectively a 1-lane street, so there was quite widespread design council required on that. But what it's meant is a fantastic new public space for the residents or the inhabitants of Melbourne. On the left-hand side there is where we decided to add some tactility into the facade design. We introduced a water wall. The water wall was created with a Brisbane-based firm called UAP. It is a series of curved and concave plates built out of cast aluminium. It actually looks like concrete or stone. That's cast aluminium. The tower facade is predominantly high-performance glazing paired with stainless steel clad nose cones, and it's a hybridised window wall, curtain wall system due to the various instances of insets and tapers and facets that are defined by the building program that they serve. The western facade, which is predominantly commercial, you can see is quite heavily faceted at the base, and that was to align with street datums on the adjacent heritage buildings on each side of the neighbouring properties. That then becomes a lot more of a, I guess, less inflected facade, and as you go up towards the crown where we get into the residential function, that inflection increases to become the inset residential balconies at high level. There's a few details there. I'm not sure if these slides are being shared, but if you want any information, I'm happy to share information after this. But it gives you an appreciation of the different facade conditions that we looked at, so different extensive faceting and tapering to create quite a varied street condition. And when we get into the commercial office building, you can start to see that tapering really doesn't affect the interior of these spaces. You're still getting fantastic views out towards the city, and it's a 1500 wide by 3900 wide high module, which really creates great floor-to-ceiling views. This is the eastern side, so the hotel function going up to the residential function. You can see a much more heavily indented facade mainly because of the residential balconies. But once again, this is the hotel. You can start to see how the facets are working internally there. We just had exposed back pans at high level. This is the hotel pool / amenity where we looked at double height facades. The lack of outriggers is really something we're quite proud of, but you can see quite a hefty wind beam going through there. And then going up to the residential apartments, residential amenity, and the residential balconies that face out towards the south with unrestrained views out over the Yarra River and to Melbourne beyond. You can see the MCG and the like in the background there. What this created, because of the stepping back of the mass, was a really fantastic opportunity to use that cantilever structure to form canopies for each of the buildings, each of the balconies, I should say. So residents are afforded a great deal of privacy and shade and shelter. At the same time, it's working in harmony with the overall development. Taking it up to roof, there's effectively no fifth elevation on this building. We took the roofing detail out, so the facade detailing all the way to the top, fully enclosing the extensive cooling towers and the like up on the roof. So there was no kind of expense spared with this project. $1.6 billion in total. This was also up on the rooftop, level 39 Sky Garden, which is quite a nice hidden moment for the residents up there, where we looked at inverting the nose cone design that we have on the outside facade, and they become planter boxes inside for the Sky Garden. Plant room louvers, there's 4 plant rooms on this project. I think I'm missing one on this slide, but it was about how do we look at successfully integrating that into a facade design. We looked at custom perforated panels that overclad double-banded louvers, so these were carefully worked through with the mechanical consultant to ensure pressure drops were dealt with. Also for great consideration is with a tapered form like this is how do you actually service it with cleaning and maintenance strategy. We have 4 BMUs servicing this entire facade. The piece de resistance, a 107-tonne dual level, or I should say it's actually 3 stories high, but tracks span across 2 levels, and that's located on the roof that serves most of the building. Of course, as architects, we don't want this thing hanging out there all day, so we created a custom garage enclosure for it with operating automated facade panels. There's a series of 4 sliding and swinging panels. I've got a shaky cam here, but you get an appreciation of entire facades being able to open up and close down to house this BMU when not in use. We'll get on to the last project, which I'm sure is probably a bit more familiar for the audience here. Federal Street, 65 Federal Street, so located a block to the north of Sky Tower. We won the design competition in 2018 with our friends at Peddlethorpe, and this is a project that really means a lot for us, so we'd like to see it progress, but yeah, I think the jury's out on it at the moment. We received resource consent for this project in August of last year, so a really fantastic moment for us and for the client, and we hope for the Auckland residents. It's a residential apartment building of just under 360 residences in a ground plane retail condition of 1,000 square metres. There's the site plan. I won't go into detail on that. It was about accompanying the Sky Tower. How can we design a tower facade to speak in harmony with such a prominent landmark in the Auckland skyline? This is a breakdown of the program of the building. So we did have two different stocks of investor and owner-occupier apartments, and then a ground plane condition where we were looking to introduce a marketplace that could work in conjunction with the City of Auckland to really create quite a nice food and beverage precinct that could tie in harmoniously to the Federal Street precinct in and around Sky Tower. A series of sketches highlighting our design considerations as we went through this design at a holistic level. The design was always one that we were looking to speak quite purposefully to the New Zealand cultural and environmental condition. In working through the mana whenua process, which I must say it was fantastic. I'm a Kiwi myself, but for the Australians in the office, it was really an eye-widening process for them, and Australia was leagues behind. But it's coming there. So working with Graham Tippany from Ngāti Whātua Ōrākei, I hope I pronounced that correctly, I'm so sorry if I haven't, and Lorna Rikihana from Ngāti Pawa, we developed the design based on Tāne Mahuta and effectively a separating of Ranginui and Papatūānuku from their marital embrace. So the tower facade design was based on that cultural input and design sessions that we went through mana whenua. You can start to see here on this sketch how the base of the building was looking at a warmer palette of materials and connecting a building to the ground plane, so effectively connecting it to Papatūānuku. And then as we go into the tower itself, it was about looking at how we can introduce materiality and some moves in the facade, which I'll talk through in a second, to extend the tower out towards Ranginui. Our competition scheme was one where we looked at curved glazed facades and quite an eroded facade design, reminiscent of the landscaping that you find in and around New Zealand. It was about $18 million reason why we decided to lose the taper at the top, but we still kept the curved facade so that this tower could speak in harmony with the curved form of Sky Tower adjacent. And when you're looking at it from the ground plane, you can start to see how that podium and the materiality of it really starts to connect it to the more earthy tones, and then the tower itself starts to sweep upwards beyond. The podium was a pretty standard window wall, unitised construction that we were envisaging, 3.2 metre floor to floors down here, and it was also about just looking how we can connect to the materiality of the local fauna and flora, I should say flora. When you're down at a street condition, especially when you've got residential apartments, it's a lot more focused on privacy, but at the same time about activation, so it's a careful balance you have to play when you're designing a facade like this to ensure that residents do feel comfortable in their houses and people aren't staring up into their beds. And at the same time, they can activate the street by looking down onto it and having balconies that can serve out. This is just a few slides to show we're looking at bronze glazing, Oco skin. I'm not sure if many people have used Oco skin. It's effectively the Rolls-Royce of fibre cement cladding, and bronze powder coating. And then when we get up towards the tower design, we went for enlarging the variation in the facets that were on the facade. And the main reason for that was to effectively create a sweeping of one's eye up towards the top of the crown. So you can start to see how the variation in the facade goes from a 2-level banding to a 3-level banding and up to a 4-level banding, directing one's eye up towards the tower and the sky above out towards Ranginui. We were looking at a silver interlaid facade glass with 14% reflectivity, an anodised aluminium facade profile, and also, similar to what we explored on 447 Collins Street, a custom perforated screen over the louvers. And going up to the very roof, where generally there's a lot of plant equipment, we looked at a double skin facade up there to provide a backdrop for a lighting condition to unfold, but also to conceal the plant. So we working with mana whenua, we felt this would be a really great opportunity for the lighting of that tower to work with significant events in the New Zealand calendar, namely Tamariki and New Year's Eve. And then the view from the observation deck of Sky Tower was one that we were strongly considering. There was a 300-metre height limit on the site, which we decided not to go up towards for a good reason. We capped the building off at 7 metres below the observation deck of the Sky Tower to ensure views like this would remain relatively undisturbed. And you can see the top of the crown is tapered out towards Rangitoto, which was a kind of a great nod for us connecting, in this case, city to nature. And that's it. Thank you so much.
Sorry. I think the next discussion we have is the panel discussion, but they'll just take some time to set it up. So I've been told to entertain, oh no, sorry, you do it, to entertain the crowd while they set this up. I like the way you just use angles on the glass to create that beacon on 80 Collins. I mean, our office is on 60 Collins, so we saw the thing go up, and it's beautiful. Question, the jobs where you got the two architects, how did you, how did that go? You got two big name architects, and how did that, how do you split the job up, split the responsibility, split the fees?
Yeah, sure. Hopefully 3 big name architects, ourselves included in that mix. UN Studio were brought on for conceptual design assistance for 80 Collins Street. There was a change of head at the client side and a new direction of thinking, so that's why they were brought on. We have a great relationship with UN Studio. They've just set up office in Melbourne as well, and we'd like to work on more projects with them. So a really great collaborative approach, and Joan Mancu, the Parisian-based firm, helped us with the detailing, that more kind of lace-like detailing in and around the ground plane. Shop were our sub-consultants for 447 Collins Street. So it was a JV, but we're effectively lead architect on that project.
Right. Just go on to... So the next... all right, thanks. I think
All good? Thank you.
Thanks. I think we're almost set up. Thank you, Blair. So now we have the panel discussion. Design facades for a more sustainable future. Ken Nixon will moderate it. He's the general manager of Thermosash, and he will introduce the panel members. Ken?
Hi, everybody. I'd just like to start also just to pick up on something David said before about 4 years ago when Zak, when we look at bringing Zak across to New Zealand. There was a comment raised in Sydney was that we probably wouldn't get enough people in the room to make it viable. Second year in a row, they've had to stop the registrations early. We're at, I think they had 574 registrations, which is an absolute phenomenal turnout, guys. And I think what it actually indicates is that we've got a real thirst for learning about facades. I was talking to a neighbour of mine the other day who isn't in construction, and he was surprised that there would be a conference on facades. He just didn't think anybody would be interested in that sort of stuff. So it's really interesting that we've got such a wonderful, wonderful turnout. So thank you, everybody, for coming along. So it is my pleasure to moderate a small but perfectly formed panel today on the topic of designing facades for a more sustainable future. We will have a particular focus on the implications of the amended H1 code. So the panellists and I are fully aware it's a pretty big topic, and there's a fair bit of detail, but we're going to share what we can in the limited amount of time we've got. So without further delay, I will bring my panellists up. So first of all, we have Richard Voss. Richard Voss is a director. You can just choose any seat you want, Richard. Yeah, it's very cosy. He is a director of Ignite Architects. With over 25 years, he has developed expertise in the industry with a very high calibre of clients in New Zealand, the UK, Germany as well. Richard has an in-depth knowledge and proven track record in all parts of the architectural process, and from brief and concept development to on-site delivery, where he brings to the table his energetic, collaborative and integrated approach. Richard has published a great deal on urban design, sustainability, collaboration and workplace design, amongst some other topics. He is also a regular guest lecturer at the Auckland University of Business School, and we are therefore very pleased to have him here today to help balance some of the science with the aesthetic. It's right. Oh, well, okay. Gemma Craig, do you want to come and join us? I have just modified it from the bio, it's up there, so we'll continue. Gemma Craig is the regional manager for Inhabit, and she is supported by her parent company, Aegis. She is a senior facade engineer and has been registered New Zealand engineer with Australia and iStruct since 2012, and has been involved in a number of iconic projects across New Zealand and Australia, such as the Royal Children's Hospital and Monash University in Melbourne and the Christchurch Convention Centre obviously in Christchurch, as well as some hotels in Auckland. Next, and certainly not least, we have Ben Masters. He is a building scientist and a principal at Becker. He manages the national sustainable building teams and works with many New Zealand architects designing leading sustainable buildings. Ben is currently working on several projects targeting zero carbon certification, where the facade design and performance is integral to achieve a target carbon with an energy and indoor air quality, high quality outcomes. So we're very fortunate. So we have an architect, we have a building scientist, and we also have a facade engineer. So we're very, very fortunate that all we actually need now is a project. We could go ahead. We've also got a facade contractor on stage as well. So the panel, what we actually spoke about when we discussed what this panel was going to do was we're going to discuss one of the most significant changes that's actually occurred in the facade building industry in over a decade. So the Ministry of Business, Innovation and Employment updated the building code to look at energy efficiency in New Zealand's future buildings. And as many of you will appreciate, the primary rationale for the H1 building code update was a step towards the alignment of the government's ambition to being carbon neutral in 2050. And as far as that relates to construction industry and improvement on the comfort of our buildings and our operational carbon, so ideally reducing our dependencies on grid source generated energy. So the H1 code update, the new code requirements for windows and doors, was phased in over a few years, with it becoming firstly effective in 22 with an additional extension through to 2023 for, I think it was projects under 300 square metres, I think it was. There has been a significant amount of work required to get the facade industry to prepare for the implementation of these codes, and we need to appreciate that in actual fact many millions of dollars has been spent by the industry in order to be able to get the industry up to the new codes. So there is no doubt that this new amended code is going to be cause for further increase in cost, and we're going to have a bit of a chat around that as well. So the code has brought with it some higher R value requirements and some lower U values for windows and doors, with a few different pathways for us to be able to get to that process. But what we need to start thinking about, and what we're going to be talking about today, is what the considerations need to be from each of the respective skill sets we have on the table, is how we're going to best manage our new built environment with this code in place, and so therefore what are the implications it's going to have on our commercial buildings. So we're going to start with the design side, so this is the segue for Richard. So Richard, our architect, my question is, thinking of commercial mid-rise projects and taller, how do you as an architect design facades to best strike the balance between the brief, the compliance with the H1 code, and of course the need for sustainability?
Thanks, Ken. I think the need for sustainability has always been there, and as we can see from this morning's presentation, so it's very, very diverse. In the 30 years I've practiced, sustainability has meant lots of different things, and it's meant different things at different times. And I think this code change is really looking at a component that forms this holistic picture. I look back when I was practicing in the 90s in the UK, and we were working on a office development in northwest England. It was a bit cold in this region. And we had to develop sustainability credentials for the project. And before we had the BREEAM tool, we obviously now have great tools like Green Star and Neighbours. So I asked the engineer, I said, look, what are we going to write? What are we going to draw? And the engineer looked at me and said, the greatest sustainability credential is the building itself. And it was so interesting because it was the building. And I think, although it sounds obvious, I think he was talking at that time about first principles. I think he was talking about this holistic thinking, which was really led by the building form. And sometimes we do forget, when we have changes like this with H1, we sometimes forget those fundamentals. And really, for me, it's always about the orientation on the site. Where's the sun coming from? Where's the wind coming from? In this region in Auckland, we have a lot of heating issues and heating issues, overheating issues, and that's not just office buildings, that could be housing, it could be healthcare projects, it could also be hotels. And so really, I think the engineer was alluding to, what's outside the facade. Is there shading from landscape? Is there thermal mass inside the facade? And I guess this is part of meeting the brief. It's also part of compliance, and it's about this wider picture around sustainability. I think a key thing is with the brief is to also focus on the user inside these buildings. And again, facades are very important for that. Glare, there's more research around glare. I mean, we see total solar glare, it's the total light, but it's also the contrast that we get inside a building. And we know that heat is generated. We've heard that mentioned today, that heat is generated by people and it's also generated by equipment. But generally, if we find out what's happening inside the building, where are the people, where is the furniture, where's the flow of people, what's the type of functionality inside the building, that's the key thing. I do generally believe what I've seen, if we design envelopes that are really resilient, it means that we can adapt future uses. Trends are always going to change for all typologies, so this means the inside will be more adaptive at a later stage. And I think the key thing, if we look at sustainability as something a bit broader, the key thing is also, the streetscape and the public spaces beyond the facade, beyond the envelope. Our design manual in this city in Auckland, it calls for dynamic street level, and we've seen that on the projects that we've seen today. And this, unlike the first criteria, this is not designing from the inside out, this is really designing from the outside in. It's about transparency. It's also about activating the streetscape and encouraging flow into the buildings as well. Finally, I think also human scale is so important. Jan Gale came to Auckland quite a while ago and spoke about that street level. And again, we've seen that in the projects today. How is the street going to interact? How are people going to go into the building and feel welcome there? But really, for me, it's really looking at the brief, it's looking at compliance, it's looking at a holistic sustainability. And it's not forgetting, sometimes it's obvious, but it's not forgetting these first principles. There's lots of them, there's a lot of engineering disciplines, but it's also, secondly, to focus on the user inside the building, on their comfort, on their experience, and finally, looking beyond the envelope and realising that we're looking into these buildings as well.
Yeah, look, I completely agree. That one of the things that I picked up was you used the word comfort, and I think it's one of the things that we need to realise is that we need to be comfortable in the buildings at all times. And it's an amalgamation of everything that the industry does, is about making a building comfortable for not only, we've seen already that we're actually looking at a building which is going to be a residence, it's going to be a hospital, it's going to be a place that we work all day. And so it's a tough job, it's a tough brief to actually bring all those things together with the sciences behind it as well. So that's a tough job for you, Richard, got to say. Gemma, the amended H1 code, it offers lots of pathways and for us to get to a compliant calculation, I guess, at the end. So there's the schedule, the calculation, the verification methods. Particularly for us at Thermosash, we deal with a lot of the high-performance bespoke projects. So we actually see that the verification method or the modelling method is going to be the very, very best approach because we don't see a lot of acceptable solutions actually applicable to what we do. And I expect this sits reasonably well with you as a facade engineer as well, giving lots of modelling work, which is great. So I guess from a facade engineer's perspective, can you talk to this as well, discuss the impact that you're seeing on H1, the H1 or the amended H1 building code, and designing an energy efficient commercial high performance facade? So.
Yeah, so I guess first of all we kind of have to understand where H1 has got to or come from and why it's had such an impact on the industry. Prior to the ratification of version 5 in November last year, we had a rather limited H1. I remember when I came back from Australia to start working in New Zealand, I read H1 at the time and was rather disappointed by the 20-page document that told you to go to other codes, and it didn't really read well how we were going to design energy-efficient facades. What we have now, well, what's been around for at least a year and a half, brought out by MB, is a really clear code with acceptable solutions and verification methods, where they've pulled a lot out of the standards and put it in codes. And I think this is really positive because it means that MB has a lot more control over what our future might look like, as opposed to trying to build things through codes. What we're seeing in our facades that we're working on under new H1, which it's still fairly new because it was only ratified last year, for those clients that weren't lucky enough to slip something of a building consent in before November the 5th last year, that are having to deal with new H1, is that, generally speaking, residential, even high-rise residential, would apply the acceptable solutions. What's happened is MB has ratcheted up those acceptable solution thumbsuck values that you would use to design your facade to, or judge your performance of your facade, so that it's at a point where the industry and facade contractors are struggling to provide now what is required in terms of facade performance. What we would recommend architects and developers do is that they look at the verification methods, which is a lot more modelling. But the great thing about going away from those acceptable solutions and going into the modelling space is that we all get to understand how our buildings perform, as opposed to just picking a value out of the acceptable solution and making our facade comply or ensuring it meets that value. So we're seeing a lot more modelling. But I think that that will improve the performance of our buildings in terms of energy efficiency, because we have a better understanding. On top of that, in areas, in both the acceptable solutions and the verification methods, we now have to use construction R values, or for those from other parts of the world, U values. That means we can't even use those acceptable solution thumbsuck default values. We need to understand what our facade, or the end game of our facade, is going to be, which means not only are we doing full building modelling, we're doing modelling of the facade itself, which is quite difficult when you don't have a facade contractor on board. So in terms of dealing with new H1, we need to engage with the industry. Designers need to engage with the industry more, and architects probably need to engage with facade consultants more to better understand what they're trying to achieve in terms of their function and form.
Yeah, I completely agree with all of that. I mean, this is one of the things that everybody keeps on talking about, is early engagement, getting the key people who can assist in actually getting the right answers early to influence the design on board, so that the architect isn't wasting time, the client's not being misinformed, and we're actually getting, like you say, doing lots and lots of modelling of the building in order to be able to actually see what variations of design will do to inform different performances of the building as well. So I totally agree with all of that. Do you think there are enough modelers available? Because like you say, there's a huge influx of consenting went into the council late last year. We're now starting to see probably people dealing with the issues of actually dealing with H1 on these new projects. We know, certainly from the exposure we've got, that we're seeing a little bit of uncertainty around what this is going to mean. So do you think there are enough enough of yous in
The
the
funny
world?
thing is, it's not actually the us's that we're seeing doing it. It's actually our friends, the mechanical engineers. And before we all jump up and say, that's a horror, you can't have a mechanical engineer dealing with the facade or the envelope. It actually, it's a really, building physics generally is a real crossover area. So I don't think it's a horror that we've got mechanical consultants doing the full building modelling. What is really important, though, is that those mechanical consultants understand the values that they are putting into their models and for the facade performance requirements, so for the R values or the U values, so that the client, there's no risk to the project that they put in a super high value or a super high performing value, and then you get to the end of the project or to where you're going out to tender and talking to the industry about what type of facade you might have. And the industry goes, we can't give you that. So facade consultants can do the modelling, but what we're finding is a lot of mechanical engineers are picking it up, and how we're supporting them is by helping them understand what the facade can do and what we might be able to do in a year's time. Because what I am learning, definitely from today, being in good company, there is a lot coming to help meet the H1 requirement, increased performance requirements now and into the future as well.
Yeah, cool. Thank you. I've got a question for Ben. So, as I touched on earlier, the New Zealand government has set up a mandate for New Zealand to reduce and ultimately become a carbon net zero country by 2050. In order to achieve this, there's going to be lots of strategies and steps that need to be undertaken to get us there, and we're already starting to see some of them come through, which is the electric car rebates, ute taxes, and removal of the oil refinery up at Whangarei. And these are all steps the government are doing in order to get us into a better position. And they've got 3 decades to ultimately get us there in order to meet the emission budget plan for reduced emission targets. So Ben, I've got what sounds like a really simple question to start with, but it's probably reasonably complicated. What is a net zero building?
Great, yeah, it is a great question. And it has been a big problem, not just in New Zealand, but internationally. There's different interpretations. There's been a lot of projects that claim they're carbon neutral, net zero carbon, but most of the time they're only considering one part of the building's life cycle. And what we need in New Zealand is our own definition, but we're close. The New Zealand Green Building Council has been working to actually develop a New Zealand-centric net zero carbon definition, focusing on upfront embodied emissions and then on operational emissions. And so the way they're going about that, the way it's currently looking at, that should be released this year. And so that means as designers, we all have something to actually aim towards achieving. And it isn't greenwash, it's actually third-party certified. Unfortunately, it's still based on offsetting your way to get to zero, but there's some other key kind of requirements, zero combustion of fossil fuel on site, going all electric, meeting minimum embodied carbon reduction targets and also operational carbon reduction targets. And this is all measured, so embodied carbon at the end of construction based on actual products and materials, and operational carbon mainly focused on energy, but also refrigerant leakage, potable water, operational waste, all measured and verified. So it's actually a scientific approach. So they're spending a bit of time trying to get it right. And also is that the way you actually offset, the type of offsets you purchase. So we're almost there that we can have this, our own definition. I've been working on a few projects that are targeting the International Living Futures Institute version, so that is subtly different from New Zealand's, but it is something, again, that you can aim towards. There's differences in terms of how you deal with sequestration of carbon in timber, for example. The boundary of what products and materials in a building actually gets assessed. Green Building Council is basically looking at the whole building, and so a facade is a big part of that, but secondary to structures, also looking at building services in general. So we're almost there that we'll have this clear definition, which the industry has actually been screaming out for, so it's going to be really good.
So do you believe that offsetting is actually the right way to go Because doesn't that sort of all sound a
It's
little bit greenwashy?
it's the last piece. You can't get to zero by you're emitting carbon when you're building a building, whether you like it or not. So to actually call it net zero, there is an offsetting component.
Right.
But there have been some projects that claim net zero just by offsetting, which is the wrong way to do it. You've actually got to reduce emissions first before you offset. Yeah.
Do you think New Zealand's in a better position to actually reach a net zero target than many other countries?
We're in a unique position because our electricity grid is that much greener than others. There's a shift that when we go all electric in our buildings and focus on energy efficiency, the shift is more significant to upfront carbon compared to others. I'm not sure the stats, but there's been some studies that suggest around about 80%, once you go all electric, emissions is an upfront carbon. And that's kind of why we're seeing this shift to more timber structures, refurbished buildings. When you do that, then the actual existing buildings, timber buildings, there's even a greater shift to facades in terms of embodied carbon. It's kind of the second cab off the ranks compared to structure. So it does require a lot of thought in terms of where you're investing your carbon, considering operational versus embodied. It's quite unique in New Zealand compared to overseas. So a lot of those stats in the previous presentation from Singapore, Europe, it's quite different in New Zealand. So our focus will be different.
What do you see as the greatest impediment to us in New Zealand with our industry?
I don't think there is much. I mean, because we're a small industry, we can actually move pretty quick. There's been a big shift to mass timber construction. I'm seeing a lot of clients that they go, yep, want that, I want net zero carbon, and we just work together and start designing to achieve it. In terms of facade, it's really just thinking, making the right decisions, spending the time to actually carry out analysis, thinking about H1, all the other elements to make a building work, but then overlaying that carbon lens, just changing the mindset. Some of the previously would just focus on operational carbon and investing a lot of upfront carbon in the facade, external solar shading, double skin facades. That doesn't quite work when you're looking at net zero carbon, so you do have to kind of reconsider some of those strategies that used to be the focus and focus on more kind of efficient, getting the glazing and the insulation to work harder, but actually considering it. We've got the tools to do it, so yeah.
So I'm going to ask Richard, do you think that there's enough information in the industry for you to be able to make the decision on material selection, early enough? You think about all the carbon inputs that need to be done. How do you manage that?
I think it's about information. It's about getting that data early, and so really we're looking at an integrated system and making sure that we can get that data, because it's such a complex issue around embodied carbon, operational carbon. And as we've seen from this morning, there's lots of facets to how this is measured. Obviously, overseas, we're seeing, real innovation in the supply chain is raising the bar, and I believe it will here. And from what I've seen overseas, in the last years, so it's really about upskilling, communicating, but also importantly, I think it's about the collaboration as well within the whole supply chain. Yeah. And I think with that collaboration, ultimately, you get downstream innovation, you get better outcomes from what we're talking about. H1 is part of that trajectory. These changes to H1 are part of that trajectory. So, the industry will definitely catch up as a collective.
Yeah. I mean, I think one of the things we've seen already is that, the advances in technology that's obviously happened with the glass, with low embodied. I mean, aluminium's another big issue. Obviously, it's close to our heart. We can actually provide some of the lowest embodied carbon aluminium into the southern hemisphere, and it's interesting that so many people aren't aware of these tiny little effects which will actually have an advantage to your projects going forward. So thanks for that, Richard. Hey, Gemma, for you, just following on to Ben's question on the net zero stuff, do you believe that the current building code aids or encourages carbon design? Do you think that it's supportive of it, or?
So just paraphrasing what the phases that we've already talked about in low carbon design, There's 5 of them. There's production, construction, usage, end of life, and benefits and loads. Where, when we talk about codes and standards and what we do already for facade, the areas which the codes and standards would have the most influence would be production, so material specification and design, and then usage, so H1, energy efficiency, and then B2, durability, or as Karl was talking about earlier, longevity. In terms of production, the codes and standards we currently use for facade, as I think it's already been talked about, is concrete, steel, timber codes, and glass and aluminium, of course. Those codes and standards have been developed over a long amount of time, and all those codes and standards also need updating, and that usually takes 10 years. We'll see a code, we'll be using the same code for, at least probably, 5 to 10 years before it gets updated for any new changes to the industry. So I think generally speaking, those at the production stage where we're designing materials, the codes and standards aren't really keeping up with the change for the existing materials that we use. And as well, for new materials that are coming out, we don't really have codes and standards or even like an organised way in which, as an industry, we can ensure these materials are regulated so that those suppliers, like the suppliers here today that are supporting the industry, they're doing the right thing and making sure that everything that we come to and have come to New Zealand is what we want and right for New Zealand and compliant. We've been through this before with steel in New Zealand, with products coming into New Zealand that aren't right for us. And so we really need those codes and standards to support the new technologies or materials and the existing to upgrade for the changes or maybe the strength or material differences that will change as we pursue low carbon materials. For usage, H1, thermal efficiency, we've spoken about already. We've got this fantastic new code that is a lot clearer as to how to use and apply it. That will slowly ramp up, I think, so that we have more sustainable buildings. And then B2, longevity. The question I ask myself with this one is that most facades, we only have a 15-year code requirement for the longevity of our facades. Is this long enough? I don't think so. I don't think it's supporting a low carbon design because we want things to last longer. So I think generally speaking, as we introduce low carbon design in New Zealand and perhaps legislate that or regulate it, that we should be really looking at all our codes to support that low carbon design. I think another important factor though when talking about low carbon design is to not forget the whole picture of sustainability. We can't just look at low carbon design in isolation. We also have to look at general or just resilience. We can't build a low carbon building in a flood zone because that building is not sustainable. So I guess to sum up, what I do hope is that even though I might pick some holes in New Zealand codes and standards, that as we progress towards our goals of carbon neutrality and more sustainable buildings, is that there's some great work that's been done by brands and by the New Zealand Green Building Council at putting information out there to support the industry so that we can make these changes and build more sustainable buildings.
Good answer. I'm not wanting to suggest this, but I can't help myself, but it's almost like we need a ute tax on non-carbon buildings. It's in order to encourage it. Let's not record that. That's a silly idea. Look, there's a really clear synergy between carbon and sustainability and the H1 code. I think it's a really, really important thing to note that these things are really, really closely entwined. And there's a lot of education that still needs to be done by the industry for the industry. So I'm just interested, Richard, you originated from the UK, and I think the UK went through this before we did, clearly. So could you just give us some insights on how that went?
Yeah, it was around 2004, 2005. I remember being in London at the time, and it was, there was a buzz because this was a big change at the time. I remember being in the studio and walking around, looking at what was on the boards, and we were saying to ourselves, will we be able to do this in the same way? But I think, we as architects, as engineers, as the whole supply chain, we adapt to these changes, and sometimes they are top-down change, legislative change. It's the Part L in the UK, the equivalent there. After that change, I was then in New Zealand, and I remember Ken Shuttleworth of Make Architects coming out and speaking at the NZAA in Wellington. And it was interesting because he actually talked about Part L and the changes, and I thought it was really interesting. And he showed the projects that have been developed in the UK, and I could see there was still real creative architectural license in what the works were there. And I think it's still always going to be striking a balance between solid and glass. That's always there in architecture. That's always there in design. And I think he was, his studio was just demonstrating that you use the tools, even though there was this legislative change. It didn't stop those fundamentals of design. And again, we can work with other design tools, proportion, rhythm, and human scale as well. And so I think there's still lots and lots of design opportunities when you get this evolution. And I would say also in the UK, from what I've seen, this is an evolution. So they've undergone some more changes quite recently. That doesn't just affect commercial buildings, that also affects dwellings as well. Perhaps in the UK, they also have the additional challenge that they've got a lot of heritage stock, a lot of listed buildings as well. So there's a bit of a tension there as to how they conserve energy, but they obviously want to preserve the historic building stock that is unique to different parts of the UK.
So I think one of the things we're probably going to see is we are going to see a different appearance of buildings, possibly as part of the generator of these new codes. Buildings are going to have potentially less, maybe less bling on them, potentially in order. There could be a bit of a change. Look, we'll summarise where we're going from here. Sort of one of the things we discussed was possibly doing 5 golden rules to implementing sustainable H1 applicable carbon neutral buildings. So Ben, do you want to start? What do you think?
First up, from my mind, is the workflow during design. Actually, considering carbon, considering your H1 strategy, if there's any curtain walling, you have to follow the modelling method. That does flip things around if it's an air-conditioned building, balance of heating and cooling loads. It's not always that intuitive, especially the further south you go, heating loads become more dominant. So you do have to get that right early, particularly before resource consent. So that's one of my kind of recommendations. Know your strategy, and then carbon is another lens to actually consider early. Things are changing from what it used to be. You could wait until detailed design. How are we going to achieve H1 now? You've got to actually consider it right up front.
Okay, so consider it right up front. Who wants to go next?
Well, I think for me, it's also remembering sustainability drivers outside H1 as well. There's a long list of them. I won't go through the whole list, but I think one of the core things around facades and how they relate to these changes is again, that user comfort, that we create buildings that are sustainable because they can be used in the way intended, and also sustainable with changes that will come on with technology later. So that's what's so important, to look at your first principles and the user comfort. Probably also, a second one, Kent, would be just remembering the vibrancy outside the building fabric, and really use all the tools together to really forge great buildings that contribute to the city. And obviously, cities that reinvent themselves are sustainable going forward, and that's what we all want.
I think to perhaps add to what Ben was saying, not only engaging early, but engaging with the right people to understand what that H1 assessment, that the impact that it's going to have on the facade. So you end up engaging early and having a solution that works, as opposed to engaging early and going and leaving a risk out there. This could be engaging with a facade consultant. It could be a suitably qualified architect who knows what they're talking about, and it could be the facade contractors who are now more familiar with talking about our values and U values and telling you what their systems can do.
I'm not going to interrupt on the 5 because I'm sure Ben's got another one, but we can't forget that whilst the H1 is dealing with insulation, we can't forget we could potentially end up with overheating and other issues. So we've got to make sure that we solve a problem over here. We don't end up with 3 more over here.
I was going to say, you've got to get that balance right. Daylight, views, you can't just, it's easy just to focus on carbon, operational carbon, but yeah, it could be a fail. Long term, it's not a sustainable building if people don't like being in there as tenants. So you do have to consider other environmental impacts at the same time, for sure. Yeah.
Brilliant. Any other closings? You're all good? No, we're all good. Hey, thank you all very, very much for your time and your contribution here. I really, really appreciate it. Still lots and lots to learn. So on behalf of the delegates here today, thank you, the panel, for giving your time and sharing your thoughts, and everybody just enjoy the rest of the Zak conference. Thank you very much.
Thank you for coming back. This is the second session of the all-day Talk About Facades event. So let's, I thought I'd just do a little bit of a survey, if you don't mind. It gives us an opportunity to stretch a bit as well. Could all the developers, how many developers are there in this room? Project managers, architects, facade engineers or facade consultants, contractors, builders, others. So great range. I think we just need more developers. Very shy. You got to work at it. Next speaker is Jonathan Hewlett, principal of Warren and Mahoney. He's going to talk about mud bricks and spiders, and I'm not sure if it's a horror or hope topic. Jonathan.
Oops, we're already on. Thank you for everyone, and it's an amazing conference. When I was first approached by Zak, I actually reached out to colleagues and said, is this real? And it's Karl from Mott, MacDonald, reassured me it was world famous. So it's fantastic to be here. Thank you for all the sponsors, and also welcome back from lunch. I trust this engages you, unless lunch sort of sends you into a slight comatose sleep. I'll try not to insist on that process. Mud bricks and spiders is really, I suppose, a little bit of a, if you indulge me, a little bit of a journey from where I'm from. And we're here in New Zealand, and I was actually born here in the continent, or in the state of Chad, or country of Chad, I should say, just south of Sahara Desert. So my home is actually a little town called Pala. And everyone wonders why I look the way I do. I said, well, my missionary father would be very sort of curious if I didn't. But essentially, this is where I lived. So I actually found, Google Earth didn't exist, and I actually found my home. And it's the first time in 40 years since my father actually saw the house that he built with his hands. And the mud bricks is actually the home that he built, because that was the local technology. So the mud bricks are made with straw and literally the dirt that surrounds the property. And they mix it by hand, and he built it. And this is actually a drawing by an American Peace Corps When you're the only European for 6 days' drive, people tend to find you out as you navigate through the country like this. And so this is actually the only complete picture of the house that I grew up in. I moved here and I never spoke English, and so I actually have no memory of this, only through the pictures that I have. This photo was actually only taken last year. Okay, yeah, okay. This is a photo taken last year, and it actually indicates just how little it's actually changed in the 40-odd years since I've been in New Zealand. This is me in the middle, and this is something that little boy here, my two brothers, and this is essentially everyday life in Chad growing up. My mother also had an influence on my architectural career. Humpty Dumpty on the wall, where she used to make novelty cakes in the middle of nowhere. She used to always make novelty cakes for us every year for all 4 children. One year I had hedgehogs, and I was concerned that if I cut into it, I might affect the baby hedgehogs that she had going out there. So this is actually the only memory I ever have from my childhood. And it's actually not the image, it's actually the sound. I didn't realize this until I was in my intermediate years. And as a music teacher played a game, Guess the Sound. And apparently, so what the picture of the woman here actually sort of grinding millet, which is how they created flour in Africa. But this process, the millet is very, very hard, and this grinding, the pounding lasts for days. And they sing a rhythmic song to actually do this, sort of actually make the flour. And that song is what was the only thing that actually somehow hardwired back into me. I reflect on this because it's just kind of an interesting, this is where I started, and the projects I'll share and the journey and the making of architecture, the making of things, sort of the memory. You wonder sort of how this influenced the sort of the journey, but it's also a remarkable contrast. So these are some of the recent projects involved in New Zealand. I've been at Warren & for coming up on my quarter century. I was a draftsman before then, so it's almost 30 years in the industry. But this project for Giltrap on Great North Road, it was actually a standard design developed in Europe, but it was a testament to the local industry here, and it's great to sort of catch up with so many people we've worked with over the years, because actually the people who make these buildings are actually the real geniuses, as a client reminded me. So this one here, they had a perforated facade, and the Ingolstadt, where Audi headquarters, couldn't believe a little country at the end of the world could make this facade. Metal Concepts produced samples, produced the quality, they sent it over, had to freight it over, and they couldn't believe the quality of it. So that's a real testament that we're a small village by world standards, but we produce amazing things. This is another project with the same client, built a few years later. Thermosash provided the entire envelope to this project. This is the Quad 7 project at Auckland Airport, as one of a number of projects collaboration with that client. And this project, Novotel, is the sort of the beginning of the story of the project I'm going to share. So this is the first project we did with a joint venture with Auckland Airport and Tainui. And it was a story about Tainui's journey and their people as they discovered New Zealand, because Tainui with Waka was the first one to visit New Zealand. And this site was significant to them because this is actually where their Waka landed in the Manukau Harbour. And so what was embodied in this project was the narratives. And this leads us to this next project, which is the Pullman Hotel. It's still under construction, so what I'll share to you today is just a small part of the project, but this illustrates the narrative and the story behind it. That should play.
Tarikinui Pullman Auckland Airport Hotel is situated on the shores of Te Mānukanuka, or Rotorua, the original name for Manukau Harbour. This harbour has held a special cultural significance from the time of Tainui Waka right through the generations to today. Its name, Te Nui, is a chiefly title gifted by Maori King Tuheitia to reflect its status as a 5-star hotel and key architectural landmark within the airport's multi-billion-dollar transformation. Kia tūpako ki te takahi I te rima o taku Karl, spoken by the first Maori king, Po te tau te wherawhero. This tongikura is a reminder of the historic and current links of Tainui and Tāmaki Makaurau and the protection the region receives within the korowai of the Kiwita.
So what featured in this Te Rariki Nui Pullman Hotel was what we refer to as the cloak. And the Te Rariki Nui was the name of the Māori queen. And one of the, in meeting with Tainui and then developing the stories and the narratives for the project, they talked about her cloak that reached around her people. And so we saw this as an amazing opportunity as visitors that visit New Zealand. Their first and last memory is this element, the cloak. There are other elements through the building, but today I'll just feature the actual cloak and the making of it. So the element, it's essentially it's a 4mm aluminium cladding panel. It runs inside and outside. And the development of it, I'll take you a little bit on the journey. So for those of us who work in current design, it's the HP pencil has been taken over by these sort of things. So grasshopper parametric analysis was required really to actually develop it, because essentially we had to knit together primary structure, secondary structure, all the way down to the actual cloak finish itself. We had to also develop sort of how many panels were involved in the process of making it. And so we're looking to identify unique and repeat panels. You can sort of see the numbers at the bottom, just 3,500 panels is the early phases of the project. And this analysis essentially was a sort of a live thing that we ran through the entire project. One of the key components of when you create a sort of a complex geometry is, well, how do you actually deal with the RAB line? What's the weather line? So we looked at various precedents around the world, and this is a local one in Sydney. Those familiar, so this is a project by BG&E. It was a lobby feature, and essentially adopted a process methodology where the RAB actually followed the geometry pretty closely of what the actual final cloak or triangular facade was. So the analysis sort of, we explored this and sort of said, what would that mean from a building process in terms of manufacture? And we're working with analysing maximum sheet sizes, efficiency, spans, structure analysis, and putting all that together to try and sort of work out what it is take us. It takes us to 1,800. We got down to 1,800 panels from about 7,500. And then we decided, actually, essentially what it creates is this sort of twin offset relationship between the RAB and the finished product. Now, if the RAB didn't really need to have any sort of, wasn't actually going to inform the inside geometry of the space. So we looked at sort of through a process, we explored other technologies like GRP, and what this highlighted through here was essentially dislocating the RAB from the external sort of facade itself. We analysed, if we made these in large panels, the triangulated pattern was actually embossed on it. You can see here with the whole cloak could be made in 82 panels, and that was essentially taking into account the freight size and packaging for actually transporting it. We even looked at hybrids around sort of where the internal portions could be made of fibrous plaster and the external portions made of GRC, or the more complex that would be subject to sort of impact. So after that exploration, the GRC, the only sort of manufacturers that we were able to find that could work at a sort of scale were actually all based overseas. And so there was a strong desire to sort of come back to finding local solutions to this. So we started actually a journey with Simonite and went back to the drawing board in terms of the analysis of the actual geometry and the panels involved. So we started the coarse geometry right up to a very fine geometry, and so the finer the geometry, the more triangles involved, the smoother the shape. That coupled with the sort of the secondary support that connects into the main frame of the actual building itself. So, but principally what it meant that we can sort of see the timber effect, that's essentially our RAB line. So we dislocated the external geometry and sort of finished the cloak from the actual weathering line itself. So then it was really around a sort of aesthetic choice around, and also working with budget in terms of the number of panels, what was the optimum sort of point. And so we went from coarse through to fine, well, fine-ish. And then we actually landed, so you can sort of see the actual, we actually landed in this sort of middle spot at 926, but once we did the final analysis of all the little individual panels and unique things around, we ended up at 960 panels. And essentially our target from Simonite was under 1,000 panels. So it was this type of analysis to be able to do it iteratively and a sort of and also bring all those components together was only possible essentially working in a virtual environment. Because that enabled us to actually get the tolerances between the primary structure and the secondary frame that had merged between it, the elements. It enabled us to make CNC components because some of these components that were joining these elements together didn't exist. So we developed extrusion prototypes. This is where the spiders come. So it was actually the real key moment was the discovery of this. So Matthew Harris and Stain from Simonite walked in one day and sort of said, we've found a solution. And it was this spider, this articulated spider, that enabled us to actually, as we moved from the primary steel with the tolerance down to the secondary, all the way to the facade, the tolerances had to get finer and finer and finer. And this enabled us to get this kind of the millimeter adjustment that we needed in order to actually sort of execute the cloak. And so series of prototyping tying back to the elements. And this is where when you get to the real world, and this is where the real genius of the people who actually execute and make these projects. So string is not to be underestimated. So this is where the digital world really actually sort of met the practical world in terms of, you'll see here, essentially as the subframe, so the black frame is, or the grey elements, so the primary frame, the black is what we referred to as sort of the secondary frame. And then the aluminium elements essentially enabled it all to sort of provide this direct support for the panels itself. And that was all possible through these nodes because it had exactly the right number of arms. It was a proprietary product to actually connect the nodes together. And so what they did in order to actually test back to the virtual geometry in the model was a threaded rod in the middle to be able to actually tweak in and out down to millimeter perfection. And we would actually sign off and cite the string lines first as part of the actual review process and Q&A on site. These are the two heroes from Simonite who laboured, Jimmy and Troy. They put up with us, so just tweak it down a little bit because as much as the digital plays a part, the eye also plays a role in finishing it. So they tirelessly up and down, up and down, up and down, tweaking things. And but it was a great process and journey. And as they've sort of these two trees, essentially 12 columns come down and turn into two columns at the base. There's 160 cubic meters of pile cap that join the two together. But that's another story. But essentially in behind, what was emerging is that sort of the clarity and the simplicity of actually this aluminium subframe, the aluminium panels themselves, where they got over to a particular dimension, we had strong backs in it, but then the primary frame. And you can sort of see how the layers of tolerance were enabled through the project, all the way through to the spiders. And the spiders provided that last tweaking to actually literally by eye look along each line and do the final adjustment. And then the great reveal, and that was sort of quite a moment as we started to sort of peel off the protection. And if you cast your mind to the video, we've tried to capture that photo. And it's going back to the cloak metaphor, the soft quality of the finish, the delicate nature of it, how it captures the light throughout the day, is something that everyone involved in the project was just. We've all been caught at moments just sort of standing there and just looking as a group, at a particular time in the day on site, and the right down to the finest detail. Is a real credit to the team from Simonite, who actually, and Jimmy and Troy and Stain, who actually really cared about every single aspect of it and every single detail. Thermosash provided the facade. That's another whole journey altogether. Mott and Simonite provided the terracotta end facades, but when the project's finished, we'll be able to reveal the whole thing altogether. So really big thank you to our client for trusting us again, Auckland Airport, Tainui, Dominion Constructors, who are overseeing the entire project, right from the sort of the piles on the ground, the 160 cubic meters of pile cap. But Simonite, who sort of really were involved in that design process and sort of making really what was an idea possible. Project architect on site, Jeremy Joseph. I have to give a shout out for anyone who's in the industry who knows him, knows that he lives and breathes this project. Matt LaGrice is our digital lead, and he was I don't know how many thousand iterations of the cloak, but he went for us through the whole journey and coordinated all that together. But it all wasn't possible with Lana DeBoca from Aurecon. She was a structural engineer that enabled the whole feature, the transfer of 12 columns into 2 at the bottom to actually make it possible. And then facade engineer Karl Jones. He didn't laugh at me once, but I'm sure he was tempted. But thank you very much.
That was fantastic. Our next speaker, Susanne Hundert, Technical Director of Aurecon, will be talking about my favorite topic, understanding air tightness. I love air tightness.
Thank you, Oliver. See, I got some, not as digital. We're talking here. Hello, everybody. Kia ora. It's great to see you here. It's great to see so many. I need to mention something before I forget it. The audience, we have so many more females than 4 years ago, so I'm really impressed. Welcome. So air tightness, yes. I came to New Zealand actually because of the leaky building crisis, aiming to help water ingress into buildings. Now I'm here to say that's not the only thing. It's not only water, it's air as well. So let's try to have a bit more of an holistic approach rather than hopefully being too technical. Let's give it a go. This is quite common misunderstandings, and I don't know what you think about, but these are all feedbacks I have received. And, some of them are quite outstanding. It's like, air leakage is great because it's passive ventilation. Or I don't like mechanical ventilation systems, I like fresh air. So there are quite a lot of misunderstandings because when we talk about air leakage, we talk about uncontrolled flow of air. So coming back to the, New Zealand lifestyle, we all love the outdoors, we all love barbecues, and having an airtight envelope doesn't mean that we cannot open windows or we can't have barbecues. So that need to be made clear. So back to the challenge. The challenge is actually the uncontrolled airflow through the envelope, through gaps, penetrations, unsealed areas. So why is it so important? For myself, very important, super important is thermal comfort of the occupants. So being in this environment here, I don't like it very much. It was freezing cold this morning. I'm heated up now because this is exciting what I'm doing here. Also, we talk obviously about condensation, which can occur within a wall when we have moisture built up unwanted. The energy losses are quite critical because, yes, we're trying to insulate the building much more. We're trying to create better performing buildings. But what we don't look at, that at the moment, the energy loss through the envelope is around 15 to 25%. So if we would altogether do a better job without investing any further sort of capital cost in materials, but just do the job a bit better, we could save these energy losses. And I'm talking heating and cooling losses, both. So that would improve the indoor air quality. It is fundamental important for the sizing of our mechanical equipment and ventilation. Of course, it helps the acoustic performance of the wall. And as our buildings become more efficient, we don't want the air leakage to influence or reduce our overall performance. It's great to look at the design, but what does it actually do? So we cannot have leaky envelopes. Coming to the building code and the new H1, I'm actually glad we had this great panelist discussion up front. So it has been updated, as we all know, and there is mention of uncontrollable airflow, and to actually account must be taken for the physical conditions, likely the airtightness of the envelope. So it is mentioned, but there is no numerical airtightness criteria provided in the building code, and there is no requirement to verify the airtightness. So when we look a bit more holistic about the entire envelope, it does a lot of things. So it is protecting against the weather. I'm not saying water anymore. I'm talking not water tightness, I'm talking weather tightness here. It is creating the comfort. It is keeping us warm. I want to walk away from, people telling their kids put a big jumper on to keep warm in winter, and they're talking about living in their own home environment. That shouldn't be, that's a no-go. However, having H1 for energy efficiency like that is a little bit, for airtightness, just make that statement and see what happens next, and you don't need to verify it, is a little bit like if we would do H1, but we don't give you any R value. You can do what you want, just use insulation. You don't need to comply with any value. As you probably have listened into my speech already, there are lots of terminologies. So I've used airtightness as topic. Then there is the airflow. You got the air leakage, the air infiltration. Same happens if you pressurize a building. You got exfiltration out through the envelope out, infiltration through the envelope in. The air permeability is usually relating to the volume of airflow per square meter per hour at a given pressure. And the air change rate is the total number of times the entire volume changes per hour at a given pressure. So the air change is usually when you, obviously, I would think you are aware of the passive house standard. They're using a limit of 0.6 air changes at 50 Pascal per hour at 50 Pascal. This is quite difficult when you get different units of values. So try to be careful with the units and don't mix them up. Don't just look at the numbers. It's important if it's based on the square meter rate or the volume. So how we do measure this, as I said, we have commercially, usually, we're going by the cubic meter per hour per square meter at 50 Pascal. Residentially, we take the air changes per hour at 50 Pascal. When we get to the design and construction stage, this is a very, very important item here to work together. So we need to have a design which addresses the air tightness, as well as a construction team who is aware of it and tries to address it. It cannot work in isolation. So some of the observations I noticed is like design sometimes is just an indication and does not address actual problems or actual material build-ups or actual tolerances we can have on site. Still, we are limited in three-dimensional thinking, and I'm talking here about really nitty-gritty, one-to-one, tiny little details like an air seal. Not modeling. I think modeling 3D, people are quite advanced now, but if we go into the smaller scale, it's still limited thinking. Our friends, main contractors, need to improve, and they're checking the works they do. They're subcontractors. I always say that a main contractor, what they can't build themselves, they need a subcontractor for. So this is not to blame any of the subcontractors. Of course not. We can't build a building without having specialist contractors on board. But I want the main contractor to be responsible for the entire building they are delivering and the function of that building. So it is crucial that they hand over, one is preparing the opening and they hand this over to the people who are installing the window, and they make sure it has been built correct. If it hasn't been built correct, we need to rectify it. That is really important. Shop drawings, specialist contractors do shop drawings, but sometimes they just do a copy and paste of the architect's intent rather than their own design. That can be dangerous too. So here's just a really super simple example of we having a precast wall, an inner air seal, a floor slab. We come to site. This simple detail indication of the architect drawing now changed because we had our Aurecon structural engineers getting involved, and they introduced all this steel inside to make the structure work, which was not visible on the drawing. So the red dotted line is the inner air seal someone need to apply, and it is quite difficult to get behind the beams and the bracings. So we need to be communicating better and be open and show, just say, how can we do it? Is it buildable? Is it accessible? This is an example of a window shop drawing, and probably a good example from what I just said is you see here is just a dotted line of the membrane, and the red is the inner air seal of the window system. When you look at the photo, I have actually taken the photo, so I wasn't highlighting this, which needs to be the continuous air seal, but more important is that membrane build up here, overlap, so the air gap, which is nominal 10 millimeter, was reduced to 0 and not able, couldn't be applied. So that are the problems which causing air leakage. And the window has been manufactured or made of the shop drawing, but obviously the building of that weather-tight opening was never allowed for. that membrane buildup. Just to wrap up, the common leakage paths, they are obviously what I just showed you, but also surface penetrations, wall and floor, structure interfaces, suspended ceilings, roof junctions, often the interfaces to unconditioned spaces. So when we go and we look at residential, if you can imagine, you all got your house and you got your garage attached to it, but then you have a door between the house and the garage. This door needs to be airtight because that is your thermal envelope. It stops here because you're not heating your garage, I assume. But that is, for example, a great leakage path usually because we do not treat those areas from unconditioned to conditioned space well enough. Of course, to find out what the building really does, we do need to do testing. So most common is blower door testing for the airtightness because the blower door, the red part, is a temporary installed fabric which keeps the actual fan to pressurize the volume of the building. This can be done in a larger scale. You can have multiple fans, you can have larger fans, or you can test compartments to get results out. So that's for the whole building done. The on-site envelope testing I've just adopted from the Window and Glass Association. They have methods for field testing. At the moment, they're focusing very much on water, which is good as well, because we don't want water-leaking buildings. But similar could be adopted to test components and just see how much airflow do we get through the components. Then the laboratory testing is done, again, on facade mock-ups or components to prove evidence of their air leakage rate or air permeability. When we do found leaks, then we can investigate them, and thermographic imaging. We can use those two images. It's a ceiling hatch in a house, massively leaking around its perimeter. You can use smoke tracers, sound detection, or anemometers. This is the most difficult word I tried to learn. I still can't say it. It's terrible. But anyway, you know what I'm talking about, right? We measure the airflow. To improve airtightness, and I'm not saying that we need to do and invest lots of money. I'm just saying we need to become better. So all of us need to become better. So first of all, we need a target. You know, how can we work without a target? So we need an airtightness target. We need to keep design simple, don't get too complicated. We should actually do a review of our concept and just draw the thermal envelope with a big pen. So just imagine you got a section of your building and you just take a pen and you say, I'm going continuously around the envelope, and I didn't have to stop with my pen. It all worked well, and there could be a basement, an elevator shaft, a difficult roof junction. As long as I can do this, I have a pretty robust design, and I'm sure we can make that work. We do need robust materials, and please no substitutions on site. That's a big problem as well for the airtightness of the envelope. As I said, we need to think about in 3D junctions. We need to communicate, collaborate, work together, talk together, and we all building it together. We don't need a really good design team make a marvelous design, but the construction team is not handed over to the construction team and they're not on board, or vice versa. If we have a really bad design from the beginning, how can we expect it to be done better under construction? That's not very likely. A real key for good quality is QA on site, absolute crucial, important, and site management processes need to be in place. Supervision need to be in place. keeping records, all that. I would also like to see more testing done, so we have more data to compare. And at the end, if we have a test certificate which shows the building performance, that would be ideal, maybe in the future, hopefully. And then if we do post-completion monitoring as well, we could actually look what the performance, what does the performance, we said we want to achieve this, but does it really do this? Here I've used some numbers. Commercial is from the UK, residential took out of the Healthy Home Design Guide. And here comes my piece of paper. I thought I need to do this because I've got architectural background. So I like, old-fashioned. What I have done, I don't know if you can see this in the back. Maybe you can. I have introduced holes into my piece of paper, which I tried to represent 1 square meter of envelope. So I just thought I'd try to visualize that. You can come and see me before I recycle this piece of paper. So this up here, this tiny little hole, I can't put my finger through, is the passive house limit. This is 1 air change per hour. This is 5 cubic meter per hour per square meter, and this is 10. So the 10 was a limit in the UK in 2006 introduced. They are now better than 10, but if you see, it's quite a, it's a big hole in 1 square meter, and we still would be compliant to the regulations at the time. So don't be too afraid. It is possible. We can achieve good values. Just give it a go. This is just a wrap of what I've said before. We need to be very careful when we automatically go more airtight, that we have to think about ventilation. We should not forget ventilation. That's absolutely crucial. So if we go more airtight, we need to have ventilation systems. Thank you very much. And we need to make sure that we not under-ventilate our indoor environment. And this is me, just an outlook, and I think we all need to do this together. We need to actually get the building codes interacting. It's a performance-based building code, but the different clauses seem to be little pockets rather than one, we come all together. So when we look at airtightness or H1, we need to look at ventilation, we need to look at the durability, we need to look at everything together. We cannot do this in isolation. And I'm talking here as a producer statement author. I do sign off certain clauses, but I do not cover everything. And I don't want to cover everything, don't get me wrong, but we need to look, we cannot, having all these high-performing buildings because we added insulation and we made the thermal performance better, but we're still losing all the energy through unwanted airflow. It's not good enough. And so we must consider air tightness control, ventilation, and energy efficiency together. Thank you very much.
Devil's in the detail, isn't it? A small little gasket can cause, get it wrong, 15 to 20% energy loss. So we got a show and tell here. Good segue. Next speaker, Andy Russell, General Manager of Proctor Group. Thinking outside the box. You sound like an architect. Air tightness simplified.
Good afternoon. Thanks very much for the opportunity to come along and speak. Now, we've had a few discussions of boxes just this morning, picking up from Karl's discussion. Here's one I prepared earlier. I don't know if anyone's familiar with this box, a piece of artwork from the 1960s, where moisture in its various states recycled within the box. So it's a particular piece of artwork which I like because it's the space which I sadly think and dream about. But when I looked up Wikipedia, it says, from the outside it can be viewed as an ordinary cube with water. As conditions around it change, so does the state of the water inside. Any art lovers in the room? Art lovers are marveled by the simple process of life and how the surroundings affect life. Now, we're doing a pretty good job with our buildings and managing this kind of state and how water is interacting. So today we're going to do the very quick journey of a sort of evolution of airtights with facades. Now, the end journey for us, where I think it's going to be, is that we're going to have a single external air and weather-tight control layer. We end up to it heading towards continuous external non-combustible insulation, where we're required to be non-combustible, and towards discontinuous, like non-thermally broken subframing, and also really nice attachments for our rain screen. So you're all familiar in terms of managing air tightness, condensation, thermal. We've got a number of tools to play. So often when we have discussions about condensation, it's all about vapor barriers and membranes and breathable membranes and smart retarders. But we have a number of tools in our game, and air tightness, as we just heard, is a very important part of that tool. So very simply to go through, we start off with a box. And initially, the first try, we make it watertight with cladding. Now, to improve thermal comfort, we insulate it, and then we chuck some uncomfortable holes in there. And with those holes, we add imperfections in terms of our thermal bridging and air leakage. So we're destroying some of the efficiency of a thermal envelope. Now, what I've been hearing in New Zealand of late is that the increase in thermal requirements is quite an issue. So we are starting to add more thermal insulation. So we've got a bit of space in the roof. We'll put it up there into the floor, and somehow we've got to squeeze more material into our building envelope at the walls. Then comes the question: how do you address vapor? So how do we keep the building? It's really not about stopping vapor. It's about allowing the building to dry out, and where we put our secondary weather control layers with vapor permeance. And then when we come to the roof space, how do you manage ventilation within the roof space, introducing ventilation and drainage within our interstitial cavity spaces, and not impacting on the air tightness of the building. So a lot of discussion we're hearing now is about where do we put that, just mentioned that red line of air tightness. If we look towards a lot of stuff coming out for Germany, for example, we see this idea of this air tightness layer on the inside of the envelope. And I've been coming around seeing a few people over the past week, and I'm not hearing much appetite either from the facade engineers, developers, or the builders about trying to install internal airtight layers. So I think we have a different approach. So I'm going through, there's this pathway to where we're heading, but there's a few sort of bypasses. I'm going to suggest if we, sometimes in life we see a few dark alleyways and distractions. Now, often they can be quite interesting. We're tempted to go down there, but we're going to try and get to the end of the journey as fast as possible. So some of the things that we might try to do to achieve air tightness, which may be destined to failure, and that's using external mechanically fixed membranes for air tightness, which is the big thing which we're trying to achieve in Australia. The idea of battling internal air control layers. And then one of the big issues as well is that if we do make our buildings airtight, we have to absolutely consider effective ventilation, continuous ventilation. So where do we put it? If we don't continuously ventilate, what happens is we end up with a very sweaty box on the inside. So we need to look at visual measures. It could be continuous ventilation with make-up air through trickle vents or through the facade. It could be full mechanical ventilation. But if we have that continual air change rate, we're allowed to keep and reduce the moisture load in the building envelope, which makes things far easier to achieve. So one thing is, well, can't we just manage with an external wrap? And as Bob Dylan said, the answer, my friend, is blowing in the wind. And we're going to huge lengths now in Australia where we don't want to use rigid air barriers, and we're trying to wrap up these high-rise buildings with a flexible piece of foil, previously pieces of foil with holes in them. And we're going through quite a process to do this, and what we've done, which no one seems to have done before, is actually provide some fixing details for our membranes. So we've gone through some facade testing with the whole range of the membranes we do, so that's probably about 2.2 kPa. We take this on, this failed after about 9.5, and we had a bit of a failure with the frame at this point when we took it up to the point. So the result of this is we've actually produced now span tables of how, depending on the washer size, type of washer, how to fix these flexible membranes. When I'm around here and seeing lots of sort of lightweight membranes stuck in the timber with a few staples, it does cause me some concern. So we've provided details for different brick ties and the likes for how that fixed. But if you do want to achieve that air tightness and water tightness with an external membrane, it's bloody hard to do. We're putting a piece of butyl behind every fixing. We're talking about perhaps each individual fixing to achieve that. We're putting through a cyclic wind load test. So over 2 weeks, we put it through about 500,000 cycles at 0.75 hertz, and then at full design wind load at 0.25. The facade engineer wanted to see what happens to fatigue around the fixings in the membrane. And we did without a cladding. We put it through a 4248 test, and we were looking at how we actually manage these fixings to avoid fatigue damage. I don't really see much of this happening on site, but it's now being asked for. Facade engineers said take it off the wall and fill it up for 24 hours with 100 mils head of water, which we managed to do. Now, we did divide this test into 2 parts. The developer said, oh, we don't need to do this, we don't need to do this, miss out the washer, miss out the butyl. So we had half of the facade as we like it, and then all things the developer wanted to experiment with. And one half, as you can imagine, worked quite well, and that's how they're building at the moment. So if we go back, that is the dream. This is the reality. We see replacement of stone wool insulation being replaced with glass wool, and then trying to wrap it up with membranes. That's going to blow off it's being held up with pieces of tape hanging off fixings. It's just it's not going to work. And then we see often with our rigid air barriers, like quite closely with high wind loads, the first big gusts of wind, all those nice square edges on the bracket systems are going to tear away, and you're not going to have any water tightness or air tightness. So when you think about internal air and vapor control layers, this idea of having it on the inside, we find it very, very hard to achieve. In the office, we have terms of affection for all our different wall systems. We call this one the masochist. I mean, trying to achieve that airtight layer on the inside with the numbers of fixings, multiple tapes is very, very challenging. And some people do like to spend the time with the smoke gun running around there and getting their photograph taken, and oh, well done, that was painful. But what we have is separation of air and vapor control layers on the inside, and again, water control on the outside. Now, it's quite hard if you take a walk through the building and see the type of penetration we have to manage if we're going to get air tightness on the inside. You have to consider complexity. There's multiple tapes, gaskets, sealants coming in there. And then also you're dealing with multiple contractors, electricians, plumbers, for example. And you have to train those contractors. So when you think about sequencing, someone told me a little story about sequencing that might stick within your mind, is that if you're going to be picking your teeth, you're picking your nose, and then wiping your bum, sequencing is quite crucial. So have a think about it. So this has huge cost and implications, but also once you actually move into the building, you have to consider the durability, what's going to happen to these penetrations long term. So I don't think this is going to really get much traction beyond small areas. So where New Zealand's certainly ahead of Australia in one respect is the use of rigid air barriers, which is really encouraging from certainly what we see in the UK and the States and overseas. But can't we just manage this with only a rigid air barrier? And I was helped with some photographs this morning of some interesting installation of rigid air barrier. Now, these fantastic products out there, but there's so much taping and detailing involved there with vapor impermeable tapes. I mean, what is the point? You're just completely almost wrapping up the rigid air barrier. And again, no fault of the product on site. You're going to see abrasion damage. Sometimes that's tapes left out there for an exposed period of time, exposed to damage, abrasion. Really, we tried this in the UK with rigid air barriers, and the end result was we're just going to wrap the whole thing up. And I think that's from some of the suggestions we're seeing from this morning, and then the move, and certainly commercial construction is actually taking a rigid air barrier and wrapping it up completely. Now, a big change happened following Grenfell in the UK, in that just after Grenfell, there were a lot of buildings which were previously designed with combustible external insulation, your phenolics and your PIRs. Now, that just stopped on day one and had to be replaced by stone wool, by rock wool type products. But how do you achieve the same thermal performance with a material which hasn't got as good thermal resistance? So the move came that a system where you could actually fully wrap the rigid air barrier and you were getting good airtight performance. So that allowed the systems, when you had external insulation, to remove your internal vapor control layers. It allowed you to sort of downgrade the sheathing because you're wrapping up the sheathing board. It didn't need to have the same. It could be a cheaper type product. And we also be able to reduce the thickness of insulation because the permeability of the building envelope was much, much shorter. So when you actually model the energy efficiency, you can improve the energy efficiency of the building by making it far, far more airtight. And this is how it looks like. We're wrapping up the sheathing board with a fully self-adhered wrap. We like the red ones. And that also gives a lot of simplified expansion joint detail within the RAB board, and a nice simplified detail of the corners and the joints and that detailing. So then in terms of where does that put our red line of airtightness? So actually we think, well, do you move it out to the outside of the installation? I think where it's actually going to end up is on the outside of the structure with some degree of external insulation. Now, the amount of that, the fact that these wraps are vapor permeable allows you to work a lot easier with the balance between the internal and the external wraps. So we got a bag load of testing from the UK, the CWT standard for building envelopes, a 50 square meter test of air tightness with all the fixing in there. What you'll see with the green line is the line which is what is acceptable. And that's what the ratings are based on. And right at the very bottom with the blue and the red lines is what this was achieving. And there was that evidence of improved airtightness of your building envelope, which allowed, in those cases, to reduce the amount of insulation that was going onto the facade. In the States, they have a very nice test, which you've got set details which you have to manage. And that goes through a test both in terms of providing permanence of the materials, but also an assembly test to look at not just the material, but how it all comes together. And in terms of the product development space, the wrap type product we do, which we developed for the US market about 15 years ago, is now really, really taken hold around the world. We also have our mechanically fixed UV resistant for open joint applications. In the past couple of years, we've actually joined those two products together to come up with the Proctor Passive UV SA, which is now a fully adhered UV resistant, highly vapor permeable membrane. It also is great compatible with some of the sealants and tapes, which likes of the polypropylene and wrap type have had issues with. So in terms of that, we've got stock on the ground with our friends at DrySpace, a full detailing guide we can pick up today, mats of testing from around the world, and window detailing guide. So when it comes to air tightness, we're quite simple. We're a simple guy. We're doing now these passive house projects with buildings where they're actually using one single external air tightness layer. Blower door test straight off the bat, passing very, very easily. So it doesn't need to be a stressful thing. The blower door test can be a really good way of getting that level of quality assurance. So in terms of the systems we come up with, again, the affection names, we have the extrovert, which puts all our insulation and the bright colors puts it all out on the outside. One single air and water control layer. We have our tree hugger, which goes onto the CLT. Likewise, one single air and water control layer. And then we have the outsider, which is where we're really trying to understand, even for steel frame construction with rigid air barrier, to add that additional external insulation. One single air and water control layer. Now, to make that possible, have a look at the stand. We do have a subframing system called Envelope, which offers you options for any of your rain screen with concealed fixing systems, also your face fix systems. And we do the full range of SFS, keel, fissure, concealed face fix anchors. So we often get the question, well, geez, you're doing this. Where's the vapor control layer? There is no vapor control layer. We're not needing one. We're actually using the positioning of the thermal insulation and the air control layer to manage condensation risk. So these types of systems, we run them through 10-year modeling in WUFI, just to give you a look today of some of the tools that you need to know and understand to make these types of system work. So the first one we think about in terms of climate. So we've got the 6 mil fiber cement sheet, fully wrapped with wrap tight, R2 insulation, the stud frame. Now with the permeable wrap tight, that can work in Christchurch and Auckland. With the ASHRAE standard says you don't want to be getting to a mold index of 3. Wellington's getting up there. When I see that increasing year on year, that does cause me some concerns. So climate's important, but also importantly the type of rigid air barrier you use. The gypsum-based ones are far more vapor open and have a degree of porosity. So if you look in Wellington there, what was causing me concerns with fibre cement was achievable with gypsum, which is a far more vapor open type of product. The other factor is you really need to understand the vapor permanence of your wrap. So ours is in Australian terms, we call it class 4. In the North American vernacular, it's vapor permeable. If there are other products out there which are vapor semi-permeable or class 3, they've got far less vapor permeance. So then you can see in that kind of situation, what would work with the vapor permeable is causing concerns with semi-permeable. So we do our own sort of illustrative tests with a bucket of water with plywood over the top, and then we put the wrap and see how long it takes for these assemblies to dry out. So again, the highly vapor permeable gives you a chance to dry out quickly, but the semi-permeable was taking twice as long. And then underneath you can see the evidences in the number of mold growth on the underside of the timber. We need these assemblies to dry out quickly. So that's after they've dried out. The other thing we need to consider is the cavity change rate. So that's the air change rate behind the facade. So the analysis there, we had a 10 air changes rate, the red line, causing some concerns in Wellington. But if you bring that to an air change rate of 50 air changes rate, more air movement within the facade, we give that drying potential to bring that down. And you'll see again with semi-permeable membranes, because it's not that open, you're not getting that full advantage of the additional drying rates from cavity ventilation. Now the simple solution is adding external insulation. So by adding a certain, we've got 40 millimeters of a stone wool insulation. What we're doing is keeping that critical layer well above dew point. And as we add external insulation degree, it makes all this far easier. So to come back to the mystery of box, if I can ask Jeff and Ginny to come up on stage, because we've got a round of applause for Ginny and Alex. Alex and Drew. So what we have is the system, all of the wall systems have been packed up inside the box with the traditional approach of internal insulation. Now we can certainly unfold those wall systems to put them on the outside. So what we're really getting to is this idea of first thing, and it draws on the earlier presentation, is we don't forget the inside of the box. We need to consider ventilation. Ventilation is managing air quality, it's managing the internal moisture load, it's managing the health of occupation of our occupants. But it's only when we've got an airtight building envelope that makes this possible. So we're also certain we're all about having continuous insulation, having that continuous insulation, enough of it on the outside of the building envelope. So all these systems we've had with insulation on the inside, we can move that to the outside and move that airtight layer, that continuous water air control layer onto the outside of the building where it is vapor permeable. Thanks very much, Alex. Thanks, Jenny. So what we're now achieving is a really good project. If you're on the Proctor set, looking at there's a webinar on certainly one of the first passive house leisure centres on the world. And that's one of the hardest buildings to achieve that performance, and all done with external airtight control layers with multiple moisture loads within the building. We're seeing a lot of these high-rise projects again going with external air tightness, rigid air barrier, external insulation all over the UK at the moment. We're doing some pretty nice work across in Australia as well with CLT is one of the areas where we've got something to actually stick to in Australia. We would like to see a bit more rigid air barriers to stick to in Australia for the steel construction, but that's coming as well. And then one of my favourite CLT projects in Victoria, and we're starting to make some inroads here in New Zealand as well with a number of projects. But just to round up, I really want to. The takeaway is that air tightness does not need to be frightening. It can be simple. It can be simple to achieve, and the benefits in terms of improving air tightness affects both air quality because it allows for effective ventilation. It helps you for managing your acoustics, helps you manage thermal comfort, it helps manage smoke control. So if you get that right, the benefit is getting air tightness right in a safe manner without knocking on and giving you different issues is well worth a little bit of investment. So thank you.
Our next speaker, Richard Fairhead, well known in the industry, director of Building Envelope Group, BEG. I'm BGE. We should do something together. We just swap the letters around. QA, not just another dirty word. Can't wait.
Well, thanks everyone. When Zak approached me to give a presentation, they're saying, what good projects do you want to talk about? And I chose one of the hardest things to try and articulate, and that's quality assurance. Now, we all talk about it, we all know it exists, we all ignore it to a certain degree, but I do a lot of work in expert witness work, I do remedial work, I do new design as well, but it all comes together. And if I have a takeaway from today, is I just want people to look at things from a different perspective. So put it into a bit of context. I started Building Envelope Group after working for some large companies that begin with A. I had enough of the corporate world after being in Australia. I've been in Australia for 15 years now, and I've worked around the world. And the same issues apply, whether you're in New Zealand or Australia. So I've been working in New Zealand for about 10 years. So I've seen the good and I've seen the bad, still seeing the bad. But I want you to look at things from the legal side when I do expert witness, how this applies. And if I can get people just to think differently when we get to site, then I think I've done my job. We'll all talk about it. There is a reluctance out there, and I'm speaking from personal experience. I'm not saying every contractor is bad. What I'm saying is there's a reluctance because people don't understand. It isn't that hard, but we also understand that there's a lot of pressures on time and materials, and everything costs money. Time is money. Being in Australia, and I'll show you some funny photos next, is we still have the destroy and compromise, design and construct contracts a lot. And there's a lot of dramas associated with that where material substitutions happen. To give you an idea, this is a project on the Gold Coast. I won't names, but this is a 8-year-old building. And I'm not quite sure if you can see in the photo, but there are cast-in bracket anchors for a curtain wall system, which it was originally designed for. Developer, who is no longer in business, decided, I'm going to go and put in some SHS posts to support, and I'm going to put a floor-to-floor system in it. That is a picture of the SHS fully corroded, and there is no steel. You can see in the bottom of the photo, you can see the bottom leg of that is gone. So, and as you can see in the photo on the bottom right, you got a beautiful, beautiful shot of the Gold Coast hinterland. So this is up 30 stories in the air. They've gone and done some emergency works to try and get what is there to stay in place. So when we're talking about quality assurance, how did it happen? Why wasn't the original curtain wall done? Okay. And why didn't you follow the original design? Come into another project that I'm working on. This was what I call a tier 2 builder and new construction. And Oliver pointed to it earlier, in Australia we have FP 1.4, which is weather tightness. We say there's no deemed to satisfy provision for weather tightness. It is all performance solution, and that's a one-liner. That's what we have in our code. You have a 200-page document in New Zealand. The specification calls for, and ITPs show what's supposed to happen. As you can see, the waterproofing for the roof is done there onto the concrete full of holes. Where's QA? The reveal prep on the right side there, where there's pinholes and it's not a smooth surface. We don't have the proper coverage onto a block wall. Bottom left, there you go. You've got your building wrap that was alluded to earlier. and we don't have the proper overlaps. We have holes. And this is 12 stories in the air on the Gold Coast, where the winds are, the wind pressures on this building are near 5 kPa, so about 2 times what you typically see in the Auckland market. Just have a bit of fun. Site observation, we went and saw a site, we come to site, there's our self-adhered membrane wrap over top of a RAB. There was a lot of holes in it, a lot of staples from temporary works. Our site observation report says remove all staples and repair the building wrap in accordance with. Come up to site. I gotta give this guy an A for perseverance. The number of pieces of tape on there to seal those, I wanted to shake his hand. He was so gutted when I said, sorry, that's not good enough. You have to start over and you have to put a new sheet on. And he just dropped. He thought he did a great job. So, you know, it's fine. That's fine. So when you're doing it, when you think of quality QA, there's a lot of cost to it. And people have talked about that today. When you think about it, at the last Zak conference, there was a statement on the payments made out by council. It was in and around the neighborhood of about $600 million in leaky claims. That's quite a lot, and I'm sure it's a little bit higher from that. You think the insurance premiums, so for the people that are in the building, the consultants, the contractors, etc. But what are the costs of loss of revenue? Having to go back and fix warranties. That doesn't apply just to builders. As consultants, there's a problem with the building, it's leaking. You got to go back out. So you need to work together on that. You've also got, you know, worst case scenario, companies disappear or people can't do any work. But at the same time, the end users, was talked about this morning as well, the relocation costs, property values are affected, the health of the people, the health of the buildings as well. When we talk about it, we talk about quality assurance. And there's so many different levels in which that we need to go into it. So obviously in the factory, you know, I was talking about everyone's offsite modular construction. You have your factory QA. It's under a controlled environment, so on and so forth. You have it, your steps, your checks and balances. So the product going out meets the tested performance. You also have your main contractor who is looking after your site. They're going to have their own QA. So they're making sure that they're following what needs to happen. And then under them, you also have your subcontractors that have to do their own QA. So we're already at 3 different levels of QA in a job, and we haven't even started. But you also have other checks on there as well. So you got producer statement authors coming out, you know, on regular reviews to check for general conformance. In a different way, you also have the council that does their independent reviews as well, just to check. It's checks and balances. Then you can also have some mock-ups as well. This is a project that we're involved in a few years back where the contractor decided to build a mock-up to try and understand what it could look like and to get an idea. Now, don't look at the plastic cavity battens, that's fine, don't worry about it, this is just a mock-up. But just to show what can be built and get an idea. It's benchmarking. So it's on site, it's a small mock-up, and what it did is it showed that it could be built and how to build it. So any questions and trying to understand the sequencing in the middle photo, you see there you've got the person doing the cladding, person doing your membrane, person doing your RAB and wraps, so on and so forth. There's so many people involved in the project. It's not hard, guys. So you can do different types of documentation and checks. You know, pen and paper. I'm fine with pen and paper. Photographs. There's 1,001 different cloud-based software programs out there that you can use. You know. So a couple good examples here. Apologize for the quality of the imagery. What you can see here, this is on a site. We were having some issues originally when the joiner was going in. We didn't have our proper air seal around the perimeter of the joinery to the reveal. So we told the contractor we want to ensure that we maintain that air seal. So what he did is he provided a little sheet on every window. And the best part about this is it's not perfect. What is it? There's about 6 different pens on there, different dates, initials, but he's got photographs to back it up so that my air seals on that window have worked. It's got the proper depth to width ratios that are required. Tick. Same thing again. Well, this is just checking the RAB before the building wrap goes on. They provided this here to show we'd seen it as well, but they came out, they did their measurements, they did their checks, general overview photos as well. You can be reasonably assured that you've got it right. Not saying that every fixing and screw in there is perfect, but you can see they're getting the gist of the manufacturer's minimum requirements. Now, I'm sorry, I've had to delete this a bit to make it so you couldn't understand who this is. This is, I'm paraphrasing here, QA for the membrane and some subframing, and it comes back, it's all good and installed. That was a contractor's QA. That's not QA, that's a statement. There's many, I'm just showing what we do. We use field wire. We put our plans in, you can see in the bottom left there, there's a whole bunch of little dots on there. That's where we've made an observation. It's a traffic light pattern. Don't worry guys, this is an Australian-based project, not New Zealand. We've got the red, amber, yellow, and green. Quite simple. Red is really bad. You got to deal with it right now. Next one, still severe. Yellow's an observation, and the green are the ones that have been closed out efficiently. So as you can see, there's a fair bit. But how does that come back into play? From our side of things, we got a phone call during a weather event. This is where an example of QA has helped us. We get a phone call and saying the ceiling of unit X has collapsed due to water ingress. I said, okay, let's have a look. I looked at the floor directly above that, and lo and behold, we had some deficiencies that had yet to be closed out. Guess what? That was a problem. So, defects are part of construction. We all get it. It normally is found, we deal with it. But it's to show that we have systems and checks and balances in place, so if you have an issue, you can deal with it. A lot of the times we get people saying, here you go, here's my QA, it's all good. Perfect QA is incorrect and it's false. So when we get it and says, here you go, it's perfect, everything's ticked off. We reject it immediately. Because what building do you know doesn't have a straight wall? What building doesn't have issues with the steel? There's always an anomaly in how you need to deal with it. Why can't we just call a spade a spade? You get an issue, how do you fix it? So this got me thinking, based off of what we've been doing on the legal side of things as well, is nowadays, if you look at the labor market as an example, originally we used to have trades and apprentices. Now, you can tell by the no hair, gray hair, I've been doing it a little while, but you used to go up and used to glazier. So if the guy's putting in the glazing, you used to have a couple of trades, you had their apprentices, you might have had one laborer. Nowadays, if you're lucky, you might have one and a bunch of laborers because of the methodologies. And more scarily, there was an article in the paper a few years ago that said the average number of years experience in the New Zealand construction market on site was between 4 and 6 years. We've made that switch from on-site to off-site, so most of the stuff is being fabricated. Another thing that we're seeing as well is your site management. Site management used to be guys that were on the tools beforehand, guys who understood construction. I have a project that I just finished up in Canberra, and the site manager was the same age as my daughter, and was 2 years out of university with no construction experience. How are they supposed to know what design people understand, or people who've been in industry for so many years? So when you take that and you look at it, what is that going to do? Coordination with other trades. You know, who's in first? What does the next trade require? Compatibility, it was talked about material changes. But as I put in there, you know, a joinery, someone who's putting in joinery, they're not going to understand what the cladding guy needs because they're there to only install that aspect. So that's the doom and gloom part of it. But on the on-site verification, it's good. We need to do it. We call it up. The PS3s call it up for things like membranes. We have to test the membranes. We install it. We prove that it works. Tick. It doesn't. What was the cause? Let's fix it. Same thing with joinery. We mandate it in all of our works that we do a water test. We're not testing the joinery unit. What we're doing is we're testing that interface to the trade to make sure that we're getting it right. Okay, so that's just proof. It's just proof of installation. It's a gross area check. So what we actually had as an example on the next one here is, and now I've mixed up the photos so no one can understand what project is which, but we did the testing and we tested the interface of that seal between the window reveal and the joinery. What we found, we had 100% success rate with that interface detail. What we had was leaks in the joinery itself that was tested to NZS 4211. We went back, we had a discussion with the fabricator, and we went through their QA and we found an anomaly in their QA. What we ended up doing is going and deglazing all the units, fixing it, retesting every single one of them to check it. What did that do? And in the on-site testing, which is another form of QA, we just saved multiple trips back and multiple complaints and potential lawsuits by addressing that on-site. And all that was just to prove that something was working. As consultants, we need to make sure that we get QA right for our own understanding. So this is just an excerpt out of our PS2 reports. This is what we need in order for us to sign off at the end of the day. Okay, what does that mean? Take an excerpt from what the council is requesting of us, basically saying if somebody finds a defect, that person must be able to sign off on that defect. So that's from my side of things. That has nothing to do with what the contractors are doing. So it is, you really need to be on top of it. And if you look at it as a proactive means, you can get a good result. When I do my expert witness work, it's the first thing I look for. Okay, I get called in saying, we've got some dramas on a building. We want you to do an expert review and report. That's usually what we find. There's a lack of quality control or documentation of how they got to the end product. So usually little to no testing or confirmation on site, huge coordination issues, and material substitutions. That's what it says to use. There's a reason for that. When we look at materials, we have a look at it from a compatibility of all the things going together. It's the sum of the parts. And it's the interpretation. No one builds it wrong. They just might not understand it in its full context. So quality control or quality assurance, think of it as a bit of a protection for you, if you can take that away. Basically, it's a form of proof of the design. If you do it right and you do the testing and you get passes, pretty good chance that is proof that you've installed it correctly. You've got to think about what it's going to mean to your reputation and your integrity going forward. It is a legal document because that is something that's in the contracts and it's a requirement. Don't be afraid to get your manufacturer's reps out. We have a pretty good rapport with the manufacturers where we'll say, get them on site to make sure you're installing it as per their recommendations. And 9 times out of 10, they're quite happy to come out to make sure their products are being used in the correct manners. If you don't know, ask. What's your time worth? So to go back and fix it if you can do it right the first time. People were talking earlier about carbon, and we're trying to reduce our carbon. If you build it right the first time and not having to go and do a reclad because it was done incorrectly, what is all that carbon worth doing it twice? Let's do it once instead. Thank you.
QA is so important. Our next speaker, Shane Hart, Business Development Manager, Insol, and he'll be talking about wind effects on feature facades. Shane.
Thank you, Oliver. A facade is not only the first point of defence against external conditions. We've talked about air and moisture predominantly today, but it will also be a filter, bringing in light, minimising solar gains and making a building aesthetically pleasing or delightful. My talk today is on wind effects on feature facades, and we're just going to cover off at a reasonably high level about wind testing and some recent case studies that we've worked on. First of all, a little bit about us. We're Insol, we're a specialist facade contractor. We focus on facade screening, so perforated metal or louvers or various different materials, and predominantly for privacy, for solar shading or and for architectural feature. We've been in business over 20 years, and we remain a family-owned company founded by on the right there, our founder and CEO Greg Simmons and his brother Tom, and we're a team of experts, and we cover off with it internally. We have the capability from design, facade engineering, right through to fabrication and installation on site. Just to cover, jump through a few recent projects we've completed. Rolleston Library in Canterbury. This is a extruded rain screen facade extending to open louvers over the windows, over the glazing. There was around about 10 different custom profiles on this. It's designed to let the light shimmer off it from different angles at different times of the day. Park Height Hotel, so here in the viaduct here in Auckland. This is operable screens which are pivoting, sliding. All the screens do move. They can be either adjusted if they're in front of balconies. They can be adjusted by the occupants, or else the ones in front of the glazing can be have a small latch which can be slid to one side to allow access for abseilers to clean the windows. And there's also integrated LED lighting, which makes the building look pretty smart at night. Wellesley Street Car Park, or the Les Mills Car Park, again here in Auckland. There's a perforated sheet metal facade. The open area obviously provides adequate ventilation for the car park behind, and geometric folds and to create the diamond shapes with some polycarbonate infills to let the light out. Looks quite stunning at night. In the AOTS Centre, so this is a ribbon of louvers around the top, integrated LED lighting, light up in the full spectrum of colours and geometric folds. It's representative of a dancer's movement as it wraps around the top of the building. Now, wind testing on feature facades, we have a lot to do obviously with these porous facade types, and they do create their own unique set of engineering challenges. So for that reason, we've built and commissioned a wind tunnel, which happens to be the most powerful wind tunnel in the southern hemisphere. Just a quick video run through over there. So it enables us to put a full one-to-one scale facade mock-up or rig in front of. We can hit it with around about 500 cubic meters of wind every second, at up to wind speeds of 47 meters per second. It's also capable of sustaining quite relatively low wind speeds, which at a very flat or laminar flow, which is ideal for testing for acoustic. Is the facade going to make any noise? Is it going to whistle? So a key enabler of what we do, and definitely a centerpiece of our work. So with wind testing, well, what are feature facades and why do we need them? Humans have been building or making facades for screening on buildings or on structures since the days of grass huts, and they are an integral part of a building, and generally it's for solar shading, for privacy or architectural feature. They do obviously, do have a function function enhancing the performance of the overall building. And as our cities intensify, as we build closer together, we build more apartments, the need for these facades only increases. What are the risks? At a general high level, there's probably three main areas of risk we look at. So structural risks obviously is the thing going to blow off the building. Audible wind noise and excessive deflection and flutter. So a couple of case studies on this point. The picture on the right up there is the Beetham Tower in Manchester, which is well known, especially well known by anyone living within a 3-mile radius of the building, because on a windy day or a windy night, it can make a hell of a din. The top section is a 9-metre high feature fin on top, which is created with glass louvers. And the glass louvers, with the air flowing over them, obviously cops a fair wind, a lot of wind pressure at the top of the building there, but it makes a lot of noise the way the wind flows over the louvers. The architect, I understand, is well aware of the issue. In fact, he actually, I believe, had to buy the penthouse apartment because no one else wanted it. So there we are, what are the risks? Closer to home, it has happened before, and inevitably they do make their way into the media. Auckland's Screaming Balconies was a newsweek article a couple of years back, and even in the World Trade Center 1, the building that replaced the World Trade Center in New York, apparently made a noise like a train rushing past before it was completed, and attracted a number of complaints to the local authorities there, which weirdly enough it actually disappeared when they removed all the propping and closed off the lift shafts. So I'm not actually sure what was the cause of that, but they obviously it did self-resolve. Why does it happen? Well, we don't know, and every case is different, every facade is different. But there are some materials which are particularly risky or particularly you have to be careful around. Perforated metal is one of them. Grating, anything with flat slats at fairly close centres can present a relatively high risk of wind noise, and especially if there's open area behind. How their process work? We typically work with the consultants, or with the architect, and with the contractor in a project, and obviously, if there is a risk, not every building will need to be wind tested. Not every facade is at a risk of it, but the idea is that you know your risks up front. You test it, you diagnose it. So why is it making? If it's making noise, why is it making noise? If it's attracting excessive flutter or deflection in the wind, why is it doing it? What can be done to change it? And then cure. So working with a design team to make sure design intents met, and the building is the building can proceed once that case. So in our work, we have a fair bit to do with car parks. Typically car parks, according to urban design rules, will need a facade and a lot of open area in behind, and generally fairly exposed environments, so they can be at a higher risk. Currently, we're working on the Auckland Airport Transport Hub, which is in construction at the moment, and it's got 3 sides of effectively effectively perforated metal facade. Across the front where there's glazing, there's perforated metal fins, and they extend around the side as well. Couple of high-level risks which were identified earlier in this project is the exposed environment. Obviously, airports are in themselves fairly exposed areas, especially the Auckland Airport. There is not a lot of terrain to break up, or terrain or urban build-up to break up any wind flows, and perforated metal itself can present a risk. We know that because there's a whole section of an orchestra dedicated to making noise with wind in holes. Now, on this particular project, the first screens that we tested did make a considerable noise, and it definitely wasn't orchestral. In fact, it was quite irritating, and it wouldn't have been a good idea to put it on the building. Looked at a number of things. So we looked at the perforation shape, we looked at the perforation size, we looked at the materials, we looked at the coatings. So taking them all into account and working through testing iterations basically until we find a cure which works, and it will de-risk the whole project. We look forward to putting some of the first panels up on this project later on this year. Another area where wind testing can prove beneficial is on testing the structural stability on dynamic facades. And when I say dynamic facades, I mean a facade which has something that moves on it. So think screens maybe that move in a sliding, pivoting or bifolding action. So 32 Shelley Beach Road apartments, another project recently completed, and what the wind tunnel enabled us to do on this project is, and where we used it, where it came into its own, is in development of the hardware. So with a sliding screen or a dynamic facade, it's generally not a problem to make something move, fairly simple. Making it not move when you don't want it to move can be the challenge. So with this particular project, we used it to develop the latching hardware, which a lot of cases it's not actually available off the shelf. It needs to be developed. It needs to be actually tested to make sure that the screens aren't going to fly off the building in a high wind event. Now, apologies to our friends at the Auckland Council, but I don't think they exactly thought about that either, because the shop drawings went right through the council and several reviews with no mention at all of any latching hardware on it. Now, we always intended to put latching hardware on it, so they would actually, they could be moved, but they could latch. The council picked up on a number of smaller other things on the shop drawings, on the drawings, which they often do, but unfortunately they missed out the most important feature, the bit that makes it stop. Now, we're big fans of Malcolm Walker, and we think that every conference needs a Malcolm Walker cartoon, so he's allowed us to share this one with you today. There's some real bangers on there. There's a few. I'll just zoom into a few, so the benefit of a few at the back of the room. Obviously, not all of them are relevant to what we do, but it does make you think. I'm not actually sure whether this chap here is an architect or possibly a subcontractor, possibly a main contractor. But he's clearly thinking. There must be some perfect houses in there for the regulators, I'm sure. This one here, in particular, took my fancy. I don't know. The feeling's probably mutual with facade engineers, and don't get me wrong, there's good ones. But we do see some real clangers in this game, and I think it's because it is a relatively new profession. I'm told that 25 years ago, in London, for example, there was no consultants, and now there's over 50 practices in London alone. And the result is that a lot of consultants can often lack the actual building experience or how things come together. And the information that comes from them could just as easily have come from a specialist subcontractor. So for that reason, the best idea is also to speak to specialist subcontractors alongside your facade engineers and get them on board early in the design development so we can work alongside the facade engineer to develop systems that work. Obviously, the standards aren't. Now, yeah, one of the examples we've seen recently, we do some clangers. One of the examples we saw recently was this one here. Now we have an extruded aluminium louver with an end cap on the end. So it's a 3mm aluminium plate on the end of the louver. There's nothing structural at all, purely aesthetic, to stop vermin or to stop spiders or whatever it is getting. That's got drain holes, obviously. But yeah, the drawings were returned because, as previously commented, fixings to meet minimum edge distance requirements. Now, understandably, there's a time and place for edge distance requirements, and they do need to be, respected. But for an aluminium end cap like this, and to return a set of drawings because of this is, it made us think. The situation isn't helped by the lack of clarity in current standards, where there's very little to refer to in regards to louvers and porous facades and facade features. So currently there's a lot left to engineering judgment, and would like to see more standards, but standards obviously take time. Now, the only way, what we can do until then is we need to work together more. So work together, take a collaborative approach to these sorts of challenges. What can we do as a subcontractor as well? We would like to share more of our knowledge. We'd like to. We know that subcontractors traditionally like to cling on to their specialist knowledge, especially when it comes to dealing with consultants. I'm going over time, but I'll just finish this bit off. But we realise the need to share the hands-on experience we've built over the year. So in summary, there is engineering challenges associated with feature facades which aren't covered in depth by the standards and design guidance. Furthermore, some feature facades will have unforeseen risks, i.e. wind noise, which are best resolved at design stage. Wind testing is often the most effective way to manage a risk that no one wants. Our wind tunnel is always open. We welcome people to come through it, and look forward to talking to you. Thank you.
One more presenter, and then I think it's a coffee break. So Gary Hall, Specification Manager, Technoform, talking about thermal isolator clip.
Hi everybody, as he just said, I'm Gary from Technoform. I'm mindful of the time and the fact that we might have run a little bit over and you're going to want a coffee, so I'll try to keep this brief. This will be fairly high level stuff. I know you've had a lot of information to take on over the last few hours, so hopefully this will be nice and easy to absorb. You've been lucky to have a lot of really good speakers here today, and I haven't done anything like this for quite a while, so hopefully your luck hasn't just run out. The reason I've got this here is I'm going to need your help today, and I'll have a few questions that I'm going to ask, very simple stuff, and one lucky person who answers one particular question will win this to take home, okay? So I need your help. You're going to have to answer some of these questions, real simple stuff. Simple guy, simple questions. Okay, let's see if we can make everything work. Does anybody know, this is the first question by the way, does anybody know who this guy is? Anybody know his name? It's a bit random, isn't it? What's he doing up there? This guy's name is Armando Basile. I don't know him either, but I know a little bit about him. Armando's claim to fame is that he has cycled more than 1 million kilometres all over the world. Can anyone tell me, second question, how many metres that is? Come on, there's a lot of engineers in that in here, you can calculate that in your head pretty fast. Approximately. 1 billion. Who said that? That guy. All right. Yeah. Yep. That is, you're dead right. It's about 1 billion kilometres, or approximately 25 times around the Earth on a bicycle. He's still doing it too, and he's pushing 70 now. Okay. The next. Oh, right. This is not the third question. But I do want to know, how many people know who Technoform are in this room or have had anything to do with them? Hands up. Anthony, you're going to have to work a lot harder, mate. Not enough people. Right. So hopefully you'll get to know a little bit more about us over the next few minutes, because I've only got a few minutes left. Technoform are one of the few global family businesses. Technoform are a team of over 1,500 people across 40 countries. We run 14 production sites worldwide, and we extrude over 1 billion metres of high precision plastic and tube every year. Can you see where this is going? That's enough to go around the Earth how many times? This is the third question. Who said that? There he is, 25 times. You're right. So if you have thermally broken windows in your home or your office, designed by companies such as FMI, APL, Altus, Omega, or our main sponsor today, Thermosash, although you're probably not going to find their stuff in your house, there's a very good chance Technoform components will be part of those systems. I'm going to play a short video now about my main topic today. Hopefully, all going well.
When most people think of a thermal break, this is probably what they think of. Whilst we may not be offering relaxing holidays on your own private island, we do offer the same level of peace of mind and comfort, knowing that your building project will be energy efficient and future-proof. At Technoform, our external insulation solutions provide more design flexibility and improve building performance. Introducing Technoform's thermal break facade solution. External insulation layers using thermal breaks are not a new concept. However, our products offer a unique set of capabilities we believe you won't find anywhere else. Up to 97% energy efficient, economical and fast to install, enables flexibility of facade design, provides structural stability under extreme loads. And whether you're using concrete, timber or steel framing, the installation process is simple. With your chosen structure in place, install the rigid air barrier and underlay as normal. Next, install the sealant tape to the back of the polyamide block. Then fasten using the proprietary screws and insulating washers. The polyamide is the real magic of Technoform's solution and provides superior strength and thermal efficiency. We use various aluminium clips for their strength and versatility, so they're suitable for virtually any facade or cladding system. Your chosen insulation product is next, and should be installed so that it is a snug fit around the clips. Finally, the rail system and cladding complete the assembly. The process is now complete, so you have a long-lasting and high-performing external envelope that will vastly improve thermal, acoustic, and fire performance of your building. So, if you want to give thermal bridges the cold shoulder, join us on our mission to lead the way in energy-efficient solutions. Experience the benefits of our thermal break products and make a positive impact on the environment and your bottom line, so you can go back to the thermal break we've all been dreaming about. Technoform, leading the way in energy-efficient solutions.
Okay, so the guy in the video mentioned thermal bridging. All common structural systems have thermal bridging problems. They also tend to have problems when it comes to installation of adequate wall insulation. Questions are coming up again. Are you ready? Where do we typically put wall insulation? Someone said it. Inside. This man's going to get this bottle of wine. I can see it a mile away. inside the cavities, right? There's a lot of cavities on that building, so they're going to be there a while. Is it a good idea to put insulation in the cavities in a steel frame building? We all know this. Excellent. Where do you think the insulation would be most effective? He said it, I think he was first. That is actually the key question. So this is all yours, sir. Look at that. It wasn't jacked up. It wasn't a jack up. All right. So no cavity here. So what do? We create one, right? Where do we put it, usually? Anybody? You can still keep asking. I might have another prize. You just never know. You might even get to have a coffee with me or something if you're really lucky. So where do we put the insulation normally? Inside. It's you again. You may as well just take over. Okay, so yeah, on the inside. Pretty much of the exterior walls, right? So can that cause condensation problems? Yep, it certainly can, but it really depends on a lot of factors. And it's a big discussion that we don't really have time to go into today. Thanks to all those other guys, but anyway. But it's a discussion that should always be had during design. I'm not really sure what's going on here. It might be a different take on mass timber construction, perhaps. But this was actually in one of the brand's books. I think they were kind of saying it's probably not the right way to go about things. But where do you put the insulation in that situation? Because there's not a lot of cavities left. You've got 140 mil framing. That might have a better R value than 90 mil framing. But if 140 mil framing is going to be installed like this, I really don't hold a lot of hope for it as a performance insulation solution, do you? It's probably not really what they meant. And what do we got here? Some beautiful CLT. So there's no cavity here, so what are we going to do? We should put it outside. We should put it outside. But the chances are there'll be plenty stuck on the inside, right? They're going to strap and line it or something like that, cover up all that beautiful timber, and probably get condensation, unless they deal with a whole lot of other things that everyone's talked about earlier. So obviously ventilation, etc., is going to be needed to try and control that. We can't really go into too much about that. It's a big topic. Let's talk solutions. That pretty much sums up what Technoform are all about. Here in New Zealand, Technoform talks solutions with local manufacturers in the fenestration industry, helping create high-performance window and facade solutions. If you're planning to specify New Zealand-made high-performance fenestration, there's a pretty good chance Technoform products will be part of that solution. There's a pretty good chance imported systems will use our products too, but the Technoform New Zealand team are really focused on supporting New Zealand-made. Technoform's collaboration with New Zealand manufacturers has grown over 15 years and continues to grow today. What we see in this slide is light gauge steel framing done better, the external insulation, where this gentleman said it needed to go. Technoform thermal isolator clip and early engagement in the design process can make external insulation pretty simple. The isolator itself is suitable for virtually any project, including retrofits. So it doesn't have to be new build. You're recladding, why don't you take the opportunity to redesign things and make the old dunga a bit more, high performance. Here we've got precast done better. So again, continuous external insulation doesn't need to be complicated. Cladding can be installed over any structure without thermal bridging. And our external insulation solutions will provide you with more design flexibility and better building performance. And here's CLT done better. And in this one, even including a bit of SG timber batten there. So if you're doing single level stuff and things like that, if this is for guys, maybe passive house, that sort of thing, and you want to just stick to timber construction as much as possible, you can do it. So this could have weatherboard straight over the top of it, nice and simple. Retrofit on an old villa, you name it. So virtually any cladding type from lightweight products like aluminium panel or long run roofing, weatherboard as I mentioned, to heavy ceramic tiles and stone can be supported by that isolator clip. So as I said, exterior insulation can be pretty simple with our clip, but you've got to give careful consideration to some of the components, and the rail system particularly. Not all rails are created equal, and many proprietary systems are not really designed to suit or to cope with external insulation, or certainly not the depths that we're looking to specify at times, or you guys are looking to specify actually. The wrong rail can really limit your design flexibility, and ultimately it can have a negative effect on the thermal performance and possibly even the durability of the system. Technoform can help get the best components together, and in some cases we can even custom make components for your system. So I only have a few minutes left, obviously, so I'm not going to go into graphs and all that sort of stuff and internal insulation versus external insulation. I think a lot of guys have covered this off, like this gentleman here, so we know exactly where we should be going with that. Collaboration is a key for Technoform in creating successful solutions. Technoform generally manufacture components and collaborate with specialised manufacturers to create thermally efficient systems. Technoform's latest collaboration has been with the Bulgarian company Stoa and their builder agency here in New Zealand. The builder system is an extremely innovative and versatile cladding carrier system. Builder is already established in Europe with many high-profile projects and architectural awards to the company's credit. Projects such as this recently completed Zelmhaven Tower in Rotterdam showcase the strength and versatility of the builder system. On this project, 45mm granite slabs were pre-assembled onto panels and lifted into place to clad the 215-metre tall tower. Zelmhaven is the tallest prefabricated building in the world. Technoform have worked with Builder customising our thermal isolator clip to support the components of their amazing cladding carrier system. Builder and Technoform's aluminium components are now being sustainably manufactured here in New Zealand. Here in Auckland, the Technoform builder system has recently been specified by Peddlethorpe Architects on the stunning Generous Living Group Development Foundation Village in Parnell. The superior span capacity of the builder rail combined with the structural strength of the Technoform isolator clip enabled Builder to configure their cladding carrier system to suit the specific needs of this project. The result was a stronger, more thermally efficient and cost-effective system than was initially thought possible. I'll skip a few notes because the pictures kind of tell you the story here. It looks like that guy with the tape's been here. We didn't put that up, so it's not quite as bad though, is it? What we managed to do there is, with Builder's system, is optimize the number of clips, and so the span capacity of that rail meant we ended up using about half the number of clips that were originally specified on this job. So obviously that has a massive effect on the thermal performance, the speed of installation, the cost of installation. So originally there was 2,800 clips spec'd on this floor of the project. We got that down to 1,300. And the components there, polyamide, locally made aluminium, and proprietary fasteners. The fasteners are key, you can't substitute anything, these have all been tested. Rock wool, 50mm and 75mm rock wool. And then that's the proprietary builder rail made here in New Zealand by Inex Metals. And that's me. Thanks, people. Oh, that's the wrong video. Here he comes again. You can watch it again if you want to. Kill the sound. Thank you, people.
Coffee break back at 4:15, please. Thank you. Welcome back. Welcome back. How are we doing so far? We're almost there. We've been talking about facades for close to, what, 8-9 hours now. Before I introduce the next speaker, we have a networking reception hosted or sponsored by Glass Corp at the end of this event, so hang around. There's more. So our next speaker is a real veteran, Dr. Marc Zobec, talking about you don't know what you don't know.
Thanks very much there, Oliver. Welcome, everybody. I'm always bemused at these events because sort of the consultants and architects consume all this time in the morning, and then there's this guy ringing the bell trying to get the contractors to bring this event in on time. So I'm just wondering, do you work for a main contractor? Anyway, I'll try to make it short and sweet and as light as possible. For those that don't know you, my name's Marc Zobec. I've worked for over 32 years for the Perma-Stelisa Group. We're a company of about, I was when I was with them, was about €1.5 billion a year, 10,000 employees. We had about 1,500 engineers, designers and technicians. Present in about 30 countries, 30 design offices, about 40 fabrication plants. Now, what I just wanted to bring across was, as my role as technical director, what I actually had to do was, wasn't just the technical aspects. I had to coordinate also not just design, engineering, research, development, IT, but also incorporate procurement, production, site installation, quality, health and safety. All those considerations were considered intricate and integral to design, to actually getting the good facade out. And someone actually mentioned today on one of the presentations, if you don't get the design right, you can't hope to send it downstream. I think it was Susanne actually. You can't just send it downstream and hope that they're going to get it right. So what I want to do today is I want to talk a little bit about this trend that's happening where you tend to find these contractors now, main contractors, are thinking that, we're just going to subcontract or self-procure everything out. Facades are easy. We just have to go out and farm out these segments and processes, and what happens is that it all just come together like mixing up a cake, and it's all going to taste wonderful at the end. And it's something that I've noted over my last 20 years where I've seen it occurring like a pandemic across the world. It's starting to reach here in New Zealand. It is just something that's bound to fail. So my presentation, I start with this collage of all these projects that I've been involved with over years, each one having a certain technical material or performance difficulty. So how you just farm these things out, I have no idea. But I want to show you some of the things about the risks associated with this approach. And also I want to try and give you some examples, pure examples where this fails, and I think people like Richard and other people who spoke before will appreciate this. So if I start here, this is just a quick holistic facade project delivery process. When I say holistic, I mean it's like acupressure, okay? In the process, you should press, if you press somewhere here, it could actually affect your body down in your back or your foot or something like acupuncture. So the same with the design delivery process. You should actually know that if I do something in the design, what do I affect the downstream processes? What am I influencing? So this here is just a simple problem creation. So when we actually deliver a facade, it's just a problem-solving process. So it's not linear. You don't just farm out these processes. You have to actually firstly collect your data. You comprehend the data. Then what you have to do is conceptualise what could be, and finally you start to create. And this is an iterative process that could repeat many, many times. What we get a lot as contractors, what I've seen in my career, is that you tend to get this intent information. I'm amazed what I've seen in New Zealand these past few days on just intent information you're supposed to tender on. But what it is, it's always drawn in situ. And you tend to find that it's in situ, and then we get to site and we check it, and somewhere in between this stream, there's this perception that it magically just happens with logistics, okay? And this is definitely not. It does not start, or design does not finish after design and engineering, and then it just flows down to these subcontractors from all parts of the world, where the people are now starting to source the cheapest type of places they can get to. This becomes what I call a silos approach. Now, when you get a silos approach, what ends up happening is it starts to demarcate responsibility. You don't have that ultimate responsibility when things go wrong, and also you get a breakdown of collaboration and communication, to paraphrase Susanne's, one of Suzanne's phrases. So what actually happens in a holistic design and drawing and design, I always try to tell people that don't confuse drafting and drawing with design. Design's the end product. Drawings are the end product of the design process. Now, if you get a full-service turnkey type of organisation, maybe someone here in New Zealand like Thermosash, you'll see that they will start to think from installation backwards, totally iterating and having those people involved to give us the constraints. Someone used the word constraint this morning, I believe it was Angus. You need to define your constraints and get that contractor involvement all the way. How do you do that if you just subcontract all these portions out? This is a thing that's called a T-shaped designer. It's been used by a company called IDEO, one of the preeminent design companies in the world. IDEO recognised that to be able to collaborate in an effective design team, what you actually need is to understand all those processes down the line and then be honest in what your expertise, level of skill and expertise in it. So there's a cross-understanding, vertical knowledge base. Where you don't have that expertise, you need to call in a friend. You need to be able to call. Someone said, call in your contractor. Call in your consultants, let's say, if you get the right consultant. Call them in where you need them. So what does an effective team look like? Well, effective project team, what I've seen, I've spent some time with some companies whilst I've been here. At the centre, you have a hub structure. You have your project manager, project design manager, which is one marriage, one union. And around this, you have all these different teams. Now, I showed those before as linear processes, but here what they are, they're around a hub, so anyone here can actually speak to the centre, get the communication effectively going, and then you can actually inform everyone to be informed into the process. So you need to have sort of a hub-type structure if you're really going to do effective design. I have no idea how you can do that if you self-procure it out. It's quite common. They think about sending something in maybe India to draw, nothing against drawing in India, produced in China. You'd be amazed how many subcontracts things go out to where you can never even trace it. Somehow it floats over the creek, comes here, and then some installation contractor installs it, and there's no continuity in the information. Who bears the risk? The other thing too, you can see here, this is a big difference that I always say, don't confuse managing design with design management. Okay. Managing design is getting the bits and pieces and the right and the nice aesthetics and everything else right. Once that's complete and you start to actually produce digital data, all that data is a Pandora's box of information that goes out to many, many streams within the actual procurement process. You may be producing here, as I said, once you've completed your design phases, you may be developing wireframe information which will generate information which goes down to understanding what your work breakdown structure is. How are you going to organise your lots? This is determined from people from site. You also want to know what production can cope with. What is your production stream? You'll have to get other types of information. You can actually see that the 3D modelers are also depending on the system designers to come in, and they need to collaborate one together. How do you actually do that if you're going to farm that out in a self-procured approach? This is just an example of a project I've recently looked at. If anyone knows, it's the Battersea Apartments in London by Frank Gehry. If anyone's done a Gehry project, you know the actual complexity of it. But just goes to show from the generation of wireframe, all these colours, what they designate are things like panel typologies, different configurations, lot structures, different types of glazing configurations. You have to generate a mega model, which is used, and someone actually said, we just streamlessly sent it out to somebody and it all worked brilliantly. I'd fail to believe that. But anyway, from that you will generate bill of materials. Your digital data today being parametric, you're not anymore just producing a visual image. You're actually producing data which can be sent out in millions of different ways to be able to do things like generate purchase orders, material requests, codify material. This, for example, is a generation from what was created from here to a parametric drawing. For example, this one panel had 2,500 components on it. How are you going to just farm that out and hope that every part comes down? Like Richard said, You just need to do QA. It's so appropriate. Richard's company is called Beg. I've been begging for QA and good QA control for years and years. The other thing too, if you want to do a holistic process, what's one of the disadvantages? If you farm things out, what ends up happening is you start to have information loss as you're transferring information across. Not only do you have information loss, people use different platforms. They do conversions. I use this. I remember doing a job in China and I asked them, can I transfer your drawings? The supplier, he said, yes. Do you use AutoCAD? Yes. After they had started, they turned around and they said, sorry, I can't do it. I said, why? Well, we have Chinese AutoCAD. It's not like real AutoCAD, but it's Chinese. So you had to go back and redevelop all the part drawings for them to produce. So there's a loss of information and such. And the other thing too, which is important, if I come back just here, sorry, if I come back here, what's very important is what I call here a buyer and an inspector. An inspector, not a quality controller. Someone who actually goes out at the point of your supply, works with their quality people. Inspection test plans. Anyone heard of inspection test plans? How often do you see them on projects? How often are they submitted? How often do you see the documentation done? Okay? Quite often you don't see that. Who here, when they get a panel, you see a facade panel on site? Anyone know what a birth certificate is? Birth certificate, simply a documentation that has different types of quality checks online as a panel goes down a production line. And it should have, like Richard stated before, it should have a plethora of different signatures on it. Some scratched out, some incorrect, some done. I've seen some that have been done the same, just tick, tick, tick by the same person. They must have done it on Friday night watching the footy because everything was done by the same person, everything was perfect. You also generate the information, as I said, from there when you do this type of integrated approach. You'll generate files, in this instance step files, that can be used to actually then generate CNC machining, automated machining operations. How do you transfer that information? What protocols do you know that the other person has? How do you get this streamlined system? I keep asking myself because on all the subcontractors that all the contracts that I've asked, you're met with crickets. So the other thing too, everyone should actually realise this type of example. This was a simple thing when you get a breakdown in communication. This was a job in Kansas City. If anyone knows the walkway, it was 2 walkways suspended from 1 rod. They subcontracted it out. The contractor thought that there was no significant change and they cut the actual rod. The actual above platform actually ended up holding twice the intended weight that what it did. It collapsed on grand opening and killed 114 people. So this is another thing where we're taking a grand risk where we could have communication loss through a lack of collaboration. This is another interesting slide. I show this because a question was asked by some risk researchers. They asked the fact, if someone asks you to paint your house, or your boss asks you to paint their house, or help them paint their house, what would you say? And they went around the world and they asked thousands of people in various countries, and you actually see the response from the no down to the yeses. Now you laugh at this and you might say, well, that's very funny. The same people who did this risk study actually matched this up with fatal and near-fatal incidents in their national carriers. So does the people that you're going to get this material, do they have a culture or a culture of quality? Ask yourself. It's not critical to where you go. It's the mentality of how they approach projects. The other thing too, to have a true procurement team, as I said, you should have a buyer, expediter, you should have an inspector and a shipping coordinator. Ask the subcontractor or the contractor, if you're an architect or a client in the room here, ask them, do they have this team? Have they got this? Who takes the risk and liability if there's a breakdown in one of these? The expediter just ensures the right goods are placed at the right time, and the buyer actually is an expert in the material who knows not just how to procure the material, but actually knows the material itself intimately, almost a material specialist. The inspector themselves are people who actually work at the source, not when it arrives here in New Zealand, you open it up, you think, it's no good, I have to send it back. Too late. But I have a consultant. That's what everyone tells me. I have a consultant. I heard here you've got 45 facade consultants in New Zealand. I thought, amazingly clever country to have all these facade consultants. So I looked up the word consultant, what it says, and it says, well, it's an expert. I thought, oh yeah, what's an expert? Well, it's expert in someone who has a lot of experience. I said, okay, well, I always looked at education when you're choosing your consultants and the speciality that you need. This is not a criticism on the consultant. It's just to make the right person for the right job. Do they have the right experience? Education's how you do it correctly. We go to school for that. But experience only tells us how not to do it wrong. I saw some of the presentations before, Susanne and Richard and the others, more mistakes than anything else. And they were brave enough to actually have brought that up as a learning process to you all to give you the experience. Some of the notable types of damages, this was a project where all those little orange dots are granite panels. They ended up having all fractures on all, and this was a breakdown again. Contractor decided to actually source the stone, provide the stone. The consultant said, we will pin the stone because it was cheaper than to actually cut a curve and retain it in there. They specified a pin fixing. They went and did some testing, and what ended up happening on every single position where the pin was put, stone cracked. And why? Well, it was a mixture. The contractor didn't do effective testing because they didn't get a proper stone consultant in there who said, check the fracture toughness of it. Stone's a brittle material, it has micro cracks. What's going to happen if we get volumetric change with that resin? Well, the consultant said it's not a problem because I've done a test, I've squirted it out, I measured it linearly, but I turned around and said, but it's not linear expansion, it's volumetric expansion. Did you check the bulk modulus, which could be 8 times the amount? And what we ended up doing when we actually checked, we actually found that for a range which was within the actual volumetric expansion, it would exceed the fracture toughness of that stone. So again, a breakdown in the consultant to the architect, what they preferred, to cost savings, to other issues that caused what could have been a £40,000 check result in a £4 million fix. Again, nickel sulfide in glass, in heat strengthened glass. Who would think it? We all think it is in toughened glass. What did they fail to do? They failed then to check the surface compression. We know that it has to be within a range, but we have those different tail ends of the standard deviations. This one here, it was approaching 12, 14, 18% exceeding that range. Whilst the mean was still what was specified, no one had checked the deviations. No one did surface spectrography testing. And we ended up finding that a number of projects were rupturing from different types of stress levels that we had in the thing. Again, a breakdown in information. This was another problem that happened. Glass. We all think it just arrives here. It's a great product. No. This was another one where it's quite often in Europe, glass supplier will provide you the coated glass. They have what they call assemblers who put it together. The supplier stripped the coating so they could assemble it and put it together. They changed the grinding wheel. Composition of it caused micro abrasions. Now, the silicon supplier to the glazing contractor, they didn't even check what type of sealant you have. You think they're all the same? No, they're not. They have different types of cure formulations that produce different types of volatile organic compounds. These are volatile organic compounds. They ended up condensing in the micro grooves, and they acted like bond breakers. So what could have been a quick inspector check at the supplier for a few flights, maybe stayed there for 2 or 3 weeks, ended up being a $17 million change. Who's going to accept the liability? I'll tell you, in these instances, we didn't have anyone putting their hand up for a technical thing. The only person who spoke were their lawyers, who denied it any culpability, and they said, we'll see you in court, which lasted 5 years, but in the end, you need to finish the job. Who pays? What risks are we playing with here? Another one here, you get stripped glass, okay? Usually it's a single pass, only of around about 10 millimetres. 12 millimetre was required. Someone took it upon themselves from a broker to not pay the extra cost of a double pass. The actual sealant, the actual coating actually was into the actual structural silicon itself. What it does, structural silicon is very vapor permeable. It absorbed into the actual material and it ended up causing oxidation of the coating. Who pays? Who checked? You think you can do this if you farm it out into a self-procured process? Who's willing to take the risk of this if you want to have a contractor propose this to you as a consultant or an architect? Because believe me, everyone, when there is a problem, we all get dragged into this. I've been in numerous court cases in my life. Other one here, again, the numerous problems with laminations. Okay, we get delamination problems. I'm pretty sure if I put a survey in here, I don't think there'd be 5% of people could actually tell you the origins or the reasons or what quality measures you need to put into place to prevent all these types of phenomena and different types of mechanisms for things. But is it detailing? Is it the storing of the PVB, moisture content? Is it the surface conductivity of the preparation? Was it contamination with the water? Is it overstressing? Is it the cutting? Is it the autoclave process? I'm probably throwing out 1,000 terms, which you wouldn't realise. I've never seen them written in specifications. Because all the specifications that a contractor receives is, this is what the material should do. Someone before used the word, the compatibility of the materials, how they work together. We're talking about a system when we're putting all these components together as systems. A specification will not save you, because a specification only states the minimum that you need to achieve. If you read the front page, the first page of any spec, it says these are minimum performance requirements. You need to actually do due diligence, if technology allows, to actually go above and beyond. So it doesn't give you any leeway. Last slide here, what I wanted to actually show you is what we have here is what I call the actual consequence curve. Okay, as you can see, as we progress through all these processes, we have the design engineering phase, we go to the procurement phase, we come across and we go and do the fabrication and installation phase. What happens if we don't have a total design system with a good consultancy team, the right information up front very early with your subcontractor, and you think this is just farmed out in a silos approach from one country to another to one department, fingers crossed it comes here, we'll take some subcontractor, we'll just throw it in and slap it on. It doesn't work. $1 in design, if you pick up $1 error in design, if it gets through to procurement, it'll cost you 10. If it gets through to fabrication, it'll cost you 100. And once it gets on site, it'll cost you 10,000 times of what the original fix could have been, just through proper coordination, the right team set up. And actually, as I said, if you don't know what you don't know, then don't make assumptions. Get the right team together, get a team of people who do know. Rely on your specialist facade contractors. Work in with the team if you can. And whatever you do, try and avoid this self-procured approach. I've seen numerous major companies, major organisations who have actually gone broke from trying to make this approach. They're littered all over the world. Don't let it happen and come into New Zealand. I leave you with one school of thought, or one thing of thought. When we talk about risk, I remember, if anyone remembers in the early days of the cheap carriers, when you went around the world, you used to have Ryanair, was one of the first ones, the Irish carrier through Europe. You get about £30 trip anywhere, very cheap. And then they came up with a solution. Everyone was all for it, because you didn't have to pay for, seats were just happy-go-lucky. You didn't get any food, you paid for it. They even wanted to charge you to go to the toilet. Baggage was limited. Everyone put up with that. Until the CEO said one day, I think we can make it even cheaper. We make planes just fly on autopilot. These pilots cost us a fortune. Why don't we just fly on autopilot? Now, when you're the one placed with the risk, you know how many people put their hand up and say, yes, I'd love £10 cheaper on a flight? No one. So when I look at all these PS1s and 2s and things like that, I always think about who ultimately wants to take the risk. You don't know what you don't know. Thank you.
Oof, that was a lot of, I'd put that under the horror category. But there is hope. Give Marc a call, or facade consultants. Our next speaker, Lachlan Stanton, talking about future trends from Guardian Glass.
We've almost made it to beer o'clock, I promise. Well, thank you. That was very interesting. As you can see on my introduction there, my name's Lachlan Stanton. I'm the Architectural Design Manager for Guardian Glass in Australia and New Zealand. I'm very pleased to stand before you today, present some of the immediate future trends that are ever so critical in our world of facade design and, importantly, material specification. I noticed today we've seen lots of presentations on what the industry can do from a design standpoint, but understanding how the materials that we use and what the manufacturers are doing from their end to reduce the operational embodied carbon, I believe is just as relevant. So from an operational standpoint, starting with high-performance low-E glass, this is obviously one of the best ways in which we can reduce the reliance on artificial heating, cooling and lighting for our buildings. In ANZ, the built environment accounts for around 40% of total carbon emissions, and the vast majority of this operational carbon can be reduced with more stringent building regulations, which you're seeing here in New Zealand, and more responsibility being placed on the specifiers and the procurement teams on those projects. Starting with the substrate itself, so we've got many different variants here. The iron oxide content of glass does influence the appearance of that material, with lower levels of iron facilitating more neutral aesthetics when looking through the pane of glass or at its edge. Generally speaking, the standard clear glass has an iron oxide content of around 700 parts per million. Reduced iron or mid-iron glass has an iron oxide content of around 500 parts per million, and you can see there low iron generally below 150 parts per million, which can give you a very different base to what you're starting with your specification. To boost light transmission and achieve more accurate colour rendering, which is what we like to see today, we're now very used to seeing low iron glass substrate being specified in our architectural projects. Once the correct substrate's been established, we then look to those high-performance low-E coatings to improve the performance and the visual transparency of those units. Architectural glazing enables building occupants to visually engage with the outdoor environments while still enjoying maximum indoor comfort. Low-E sputter coat technology is constantly evolving. It's dynamic, it's moving very quickly, and major glass manufacturers are always finding new and innovative ways to tweak their coating stacks and comply with updating building codes, remain durable enough to have high processing yields all the way through on their way to installation. We see the IGDB, or the International Glazing Database, updated often multiple times per month with newly registered products, so specifiers remaining up to date through educational programs like CPDs, independent learning, we believe is essential to ensuring the highest performing products are finding their way into our projects. Just because certain products have worked before or were suitable or compliant does not necessarily mean they will continue to be in the future as we evolve. These coatings can change a multitude of things, one of them being the appearance, the light transmission and the reflectivity of glass. The term visible light transmission refers to that percentage of visible light that is directly transmitted through the glass makeup. Typically, we're looking for a high VLT with low light reflection, both externally and internally. We may also look to introduce a coloured reflected light, whilst the transmitted light remains as neutral as possible. This light and how it reflects and how it plays off facades can have a massive role in how those projects are viewed and experienced. For an architectural project located in a warm or moderate climate, a low solar heat gain coefficient, or SHGC, is preferred. Placement of a low-E coating on surface number 2 typically facilitates the best performance because we're reflecting that solar energy before it can enter the glazing units. In particularly cold climates, a higher SHGC could be beneficial to allow some level of passive solar heat gain. So placement of the low-E coating on surface number 3 marginally increases that SHGC compared to the same coating on surface 2. This works to allow more passive heat to enter that building or home. A big one for New Zealand, as we know, is the insulating performance. So this refers to the reduction of heat transfer associated with exterior versus interior air temperature differences. Insulating performance obviously is more advantageous, especially in cooler climates. In those cool climates, the glazing may allow incoming short wavelength radiation to enter and then retain that heat inside the building or home. Long wavelength radiation from artificial heating sources is re-reflected inside the space also. In warm climates, the glazing should block both incoming short wavelength radiation and incidental incoming long wavelength radiation. thus reducing the need for air conditioning in the internal space. So really, regardless of the climate, hot or cold, a glazing that blocks that heat transfer is always going to be advantageous for energy performance and will provide a quantifiable reduction in the operational carbon of the building. Natural light penetration, as well as coatings and their placement in the glazing, are critical to support occupant comfort. The term spectral selectivity is used as a ratio to demonstrate the amount of daylight transmission relative to solar energy blockage. Spectral selectivity is calculated by dividing the visible light transmission by the SHGC. Greater spectral selectivity is achieved when more visible light and less overall solar energy is being transmitted. Generally, the higher the spectral selectivity, the more efficient that glazing unit is at transmitting light and blocking the heat. So this space is quite interesting. This is where a lot of glass manufacturers have been making leaps and bounds in terms of their coating developments. Once upon a time, spectral selectivity of around 1.9 to 2 was considered fairly cutting edge. Within the market now, there are products with spectral selectivity of 2.3, 2.4, even 2.5, providing a far more neutral aesthetic with solar control that was once seen by dark body tinted glass substrate and low VLT, really highly reflective coated products. These highly selective products offer a uniquely clean appearance with an exceptionally consistent appearance that helps achieve more uniform design contours at different viewing angles. They perform far better in terms of colour shift as well, which can be a negative consequence, anything from viewing perpendicular all the way to really narrow angles, which we find helps designers fulfill their desire to resonate uniformity across a facade and try and get that balanced, flat, neutral appearance. Spectral selectivity also goes hand in hand with CRI, which we call Colour Rendering Index. This describes the extent to which the natural light is modified by the glazing. Typically, if we have a coloured facade externally, we suffer the consequence of that same colour transmitted light and thus giving us a poor CRI. So essentially, for those that aren't aware, it can range from 0 through to 100. Basically, we're looking at 0 being the least consistent with natural daylight and 100 being the most consistent. So if we have a value of 100, that means the colour of an object observed under filtered daylight matches the same colour when observed under direct daylight. Low iron substrate, which we looked at earlier, for example, that will offer you a higher CRI than your standard clear glass, as well as thinner glass offering a higher CRI than thicker glass. Things like tinted glass are a tricky one because the CRI metrics involved with them can vary massively. So being able to achieve high levels of solar control with relatively clear glass, that has nearly eliminated the need for tinted substrates in some applications. This also means by default we're seeing improved performance across the board, as well as a significant drop in thermal breakage instances. Today we find specifiers actually putting a huge importance on aesthetic and CRI, and these values are often being specified specifically and asked for. Values that we're all familiar with, like the VLT, SHGC, and U value that I mentioned, they can sometimes feel like a box-checking exercise with multiple equivalent options available in the market. However, when it comes to spectral selectivity and colour rendering, we must be far more vigilant with the products that we're choosing. Taking it even one step further, we can actually specify exact external, internal, and transmitted colour and what we want to achieve there. We specify using the 3D coordinate convention you can see here, LAB colour system. Any colour can be described as a point within a 3D space, and this enables designers to take their creations one step further, incorporate exact measurable glass colour shades and to match other building materials, match the external environment, and the context that their buildings are going to live in. Moving away from the performance of individual products, the focus now more than ever is on sustainable material sourcing, putting a microscope over building materials and the carbon emissions associated with their manufacture. In the construction industry, especially in Australia, where minimum compliance and the cheapest price seems to prevail all too often, embodied carbon guidelines and regulations are proving to be a thorn in the side of many well-established supply chains. The New Zealand Green Building Council describes itself as passionate advocates for better buildings because we know that better buildings means happier, healthier Kiwis. Together we've led changes to woeful building codes and helped ensure hundreds of projects in New Zealand are designed and built better. So this year we're seeing the implementation of a major change to the ratings framework, moving from Green Star Design and As-Built to Green Star Buildings. Typically, you guys in New Zealand are a bit of a window into the future of code compliance compared to Australia, but when it comes to Green Star, we actually got in first on this one. So the benefit here, I guess, is that you guys can take real-world learnings from us and from our implementation and understand how the rating scheme can help control the embodied carbon and materials that are being used. The aim for Green Star buildings is to meet the current and future demands of the built environment with aspirational benchmarks for addressing key issues over the next decade, as you can see there, such as climate action, resource efficiency, health and well-being. The shake-up will provide a new definition of what constitutes a sustainable building, measured by the 8 categories you can see at the top there, and will create clear expectations of what must be achieved to gain a Green Star rating, everything from minimum legal compliance all the way through to what they're going to call world leadership. One of the ways we have control over this is through a section of the responsible product framework known as responsible envelope. The vision of this framework is to drive procurement and supply chain to deliver transparent, healthy, low impact, net zero carbon products that are part of a circular economy. This framework will outline criteria for scoring how responsible a product is. So manufacturers that are committed to investing in certification schemes will now have their credentials recognised. Things like Cradle to Cradle is a global standard for products that are considered safe, circular and responsibly made, ranking items like material health, product circularity, renewable energy and carbon management, water and soil stewardship, and social fairness. The framework also encourages public access to material data from suppliers through things like environmental product declarations or EPDs, life cycle analysis, and product lens documentation. All of this helps to eliminate substandard or environmentally detrimental products entering New Zealand. So through this framework, Guardian Glass has managed to become the first glass manufacturer able to award Green Star points through Green Star Building in Australia, and once that conversion is made to New Zealand, the same will apply here. As specifiers, decision makers, customers, end users, we're all stewards for the country and the world that we inhabit. Many glass manufacturers are continuously experimenting with ways they can reduce their embodied carbon numbers. Currently, one of the best ways of doing this is by increasing the recycled material content in our furnaces. Guardian's proven that there is long-term feasibility here in float manufacture with a higher cullet ratio. This can significantly contribute to reduction in emissions and energy savings. So we ran a 10-day experiment in our Gould plant in the UK, manufacturing float glass there at 60% cullet compared to an industry average of around 17%. You can see the numbers on the screen there. This reduced our CO2 emissions by around 38% and showed a gas consumption efficiency improvement of almost 12%. This also opens the door for interesting things like payback schemes and rebates for customers that can return their waste glass back to suppliers where possible. We mentioned earlier as well that the built environment is responsible for around 40% of global energy consumption and emissions. So in the chart down there in the corner, of that 40%, it's approximately a 50-50 split there between commercial and residential. Of that commercial piece, around 57% is directly influenced by the building envelope. So looking at that as a percentage of the total global emissions, around 10% can be directly influenced by the facades that we're all here designing and the products that we use to create those facades. So it does sometimes feel like we're too small to make a difference, but when you look at the numbers like that, I can promise you that is not the case. Not only are codes changing in the commercial space, but the MBIE has issued compliance. Am I the first one to get the hurry up? to meet minimum insulation requirements in homes across New Zealand. So these changes specifically around insulation aim to reduce the required energy needed to heat new homes by about 40% and cool new homes by around 23%. So the focus here is on the people, resulting in a dramatic reduction in energy costs and overall improvement in occupant wellbeing across New Zealand. Performance revisions will mean clear IGUs will move to low E clear IGUs, with thermally broken frames being a requirement in certain climate zones. Those climate zones have been reviewed and separated into 6, allowing for insulation requirements to better reflect the different temperature experienced in each of those zones. These changes are required to support New Zealand's effort in achieving net zero carbon emissions in the future. Glazing requirements are only heading in one direction, and resistance to change will be at our own detriment. Fortunately, there are local processes already set up in New Zealand, such as Metro Performance Glass, who stock compliant coated glass solutions, meaning you are well positioned to meet these required changes moving forward. Much of today's world would not be possible without glass. Almost everywhere you look, there is glass in some applications surrounding you. It does offer the design world unique advantages in terms of aesthetics and performance, and all of these facets are constantly growing. It's an essential structural component in the architectural projects around the world. And as I said, it can literally be found everywhere, all the way from your phone through to the most iconic high-rise buildings around the world. Really, the more that we develop in this space, the future of glass really only seems to be limited by our imagination. So a big thank you to everyone who made it to the end of the day. Thanks to Zak. Thanks to everyone who came by the booth. Cheers.
There was an extra loud ding there. So while they set it up, I'll just take probably a minute just to run through my takeaways for today. I think it started with Karl setting the scene with horror and hope. Very apt in the climate we have today, but basically my points would be talking about insurance, challenges in insurance, getting the details right, working together, issues about QA, low embodied energy, recycled content, air infiltration, very important, testing as proof of installation. I think there's more to come with carbon, low embodied energy, and the environment. It's talking about standards and a lot more about sharing and sharing in this industry. And I guess that's why we're all here. I hope the session has been good today. It's not over yet. Don't forget, after this, we've got cocktails in glass. So I'll just introduce the moderator for the next session, John Hawkins, Technical Director of Mott, MacDonald. Got that right this time. Built environment. And the topic is smart, informed facade procurement, another favorite topic of mine.
Thank you very much. First of all, a huge thank you for everyone to hanging around. It's very tempting to go directly to beer. I was kind of hoping this would be a Graham Norton set where I could sit and have a beer while we all sat and had a beer. Preferably without the big red chair, so I couldn't be dumped when I was boring. But yeah, that's us. I'm happy to say we've got a great bunch of speakers today, panelists. Marc, who we just heard eloquently speak, Dan Bosher, General Manager Aurecon, and Tim Melville, which Bagot. I'm not sure what he is these days. Marc's spoken about himself. We let these. Do you guys want to say a little bit about yourselves? No. Dan's came for a drink. Let's get on with it. Anywhere, pick a chair. None of them's a booby trap, promise. Cool. So we'll get straight into it. It's on the screen. I guess is the role of the design team dovetailed to be more collaborative and less confrontational? I think Tim, if you could take that first one, based on your extensive experience of leading design teams and being part of design teams, have you seen like an evolution that we've started to move away from a them and us position?
I think one of the things that's been mentioned already today is key to this, which is it's really, really important for us to have the design team together from the beginning, particularly having our facade engineers, building enclosure engineers, services engineers in there in the early design stages. I'd like to say that's happening more, but I don't know that it's happening enough. And, you know, we know the value of that. I think the other aspect of that, because essentially design is about collaboration, and it's having all those voices there and bouncing ideas and thoughts, particularly in those early design stages. It's not something that we don't want to defer technical things to later on. We want to have those things as part of those early stages of the design thinking. And the other thing that obviously New Zealand's a bit different from Australia in is that we don't have as much design build here, and we don't have as much ECI. And I think ECI with really good people, and also potentially with subcontractors, specialist people like the Thermosashes of this world involved in the design process, is just so valuable. I don't think we're quite there yet, but
working towards it.
Working towards it, I think, yeah.
And we're lucky to have Dan here from a main contractor perspective, who does do a fair amount of D&C. I guess my question to you is, how do you feel that dovetail is working when the team's novated to you? Do you feel that there is all the gaps are filled, or is there some actions required by the main contractor to coordinate those parties and integrate that back into the construction?
Sure. So our workbook at the moment is about 50-50 design and construct only, which is we're the only region of the Aurecon business that's in that model. Everyone else is heavily D&C. We have a strong preference to D&C on the basis that the design team is novated and that we have the opportunity to plug the gaps. So on a typical job for us, we would, at time of contract award and novation, review all of the scopes. You and I have been through this process before, and typically increase the scopes to cover things like, say, on facade. We joke about it all the time, but the whole E2 wrap, rather than just, you know, the curtain wall, which is the simpler part, really. Where we have more trouble with that is on construct only, and particularly construct only where, say, the curtain wall's a D&C element, and then it's all the other interfacing details where no one's got the ball. That's really hard. An interesting sort of comparison between our teams, and in a design and construct job, we might have, say, a design manager, a coordinator, and a commercial team. The number of design bodies or coordination bodies that we have in a construct-only job tend to be higher, in the tune of like 20%, because the whole relationship's different. It's defensive, you don't know what the other party has, and it's hard to close out issues because we're always navigating a gap. So being front-footed in the D&C space tends to help because we've got overall sight and we've cleaned up the consultant agreements.
I think, again, if I could just lean on Marc for his experience. I think the concept of the team is massively important, but I think too often we see teams put together by project managers and tenders and bids that don't necessarily relate to a holistic view that closes all those gaps. And I was just wondering if you had some insights as to how to build that team well, or whilst we're on the topic of the day, some horror stories about how teams can be built badly, and so we can try and avoid that moving forward.
In my experience, well, firstly, the design team is a terminology. We have to try and think about how it falls within the scope of a project and how the project's set up. My experience of the most successful projects I've ever worked with has always been in the UK. You probably may be familiar. They have a thing that they called a pre-construction services agreement, which is usually then something broadly done in the US as well now. I initially started in the early 2000s, tried to do one or two, and within 2 or 3 years, we had 67 of them running at once. And what that was that the client would engage the main contractor and wanted to form the main contractor as part of the design, because they viewed design as not, as I try to present, it just stopped at drawings and then it went downstream. Foster's was a famous one, Norman Foster, who said design doesn't stop until the last screw's put in to the thing. Now, from a subcontractor point of view, I beg to differ, because at some point we'd like to finish the job. But what I had found that the best teams were when you had the pre-construction services agreement, it built a level of trust. And what that first thing was that we always used to ask the client, set us a budget. It may not be the true budget, make one up, but we will work together to deliver to you a design based on your budget. When you're happy with that budget, we will give you a value engineering list. You can take out the jewellery, we can put gold, we can replace it with silver, we can do whatever we want. Value engineering. And the third thing we intend to do is every type of specification that I see that falls within design was always the Achilles heel, because they are so generic and cut, copy, paste. They're never specific to a project, particularly complex projects, which you see coming up. If you're a very confrontational contractor, they will use it and utilise it in a very contractual, confrontational way. So when you've got that design team dovetailed and put together from an early stage, the specification's usually written directly into the design that we've all designed and have a stake in. We don't have a recourse to come back and say, well, I didn't know about that and this wasn't allowed for and such. They're usually the most successful projects that I've seen. I've seen the most confrontational usually when it's the usually rigid one, and the pre-construction services agreement, I've seen the most successful projects. I mean, you see a job like that one in Battersea by Frank Gehry. Frank Gehry jobs are never easy. But it was a pre-construction services agreement. When all parties came together, everyone made money, and the client was extremely satisfied.
Yeah, I think that, I mean, you're right, the design team is perhaps terminology we need to knock on the head. We are a team of designers, and we're all working towards the same outcome, which is, I guess, ultimately better buildings. So I think that's probably enough for the first point, because we're rapidly chewing through our beer drinking time. So moving on, is the design process structured for innovation and brainstorming leading to an optimum procurement strategy? I think Marc's answer there is get ECI, get intellectual engagement as well as commercial engagement, and get people to put their best foot forward. So I think for Tim, my question is, who decides who designs? Obviously, the architect and the consultant team has the right to delegate design responsibility as they see fit to subcontractors to complete, those subcontractors being better placed to complete the design. But who decides that? Is that client, consultant, QS? So again, if you could just let us know from your experience.
The ideal world, or how it really works? Because I'd come back to the point that you've made already about design teams. I'll still use that term, sorry, but are engaged by client project managers. Our scope is set, our responsibilities are set, and often procurement, which this is question sort of about, is set in place. That already starts that siloing in a way, because everybody's got, well, this is mine, this is what I've put my fee in for, this is what my liability is, this is, and that creates that situation right from the start. It's counter-collaborative, in my view. And if you're really to get the best result, that early conversations that you were talking about, Marc, of, right, roles quite apart from looking at early design thinking, it's roles and responsibilities. How are we going to do this? Who's going to do what? How will, and how are we going to do that effectively? And at the heart of that, and this is something that the client also needs to buy into, is that this is about risk share. It's not about risk allocation. And particularly in New Zealand of recent years, that's what's led to the adversarial situation we find ourselves in, because everybody's trying to hand it over. It's like, well, I think as speakers have already said today, we're all taking risk here. So it's not about pushing it away, it's about who's best to do what to minimise the risk to the client and to ourselves with the final result. So I think that if there's a change that needs to be made, it's actually looking at how the teams are engaged in the first place. And then, when it comes to procurement, that the design team also is able to input into how they see the best of that, and obviously ECI and contractor and subcontractor involvement in those early stages, so you can collaboratively work out the best way forward. That's the ideal. I mean, you were talking about the best projects you've been involved in, and at the heart of it for me, it's been collaboration and real buy-in by everybody in the process. You get the best results with the best quality in my experience. So, yeah.
Absolutely. I think the fixed service and fixed scope for fixed lump sum is kind of a hiding to nothing. You carve out your niche and go, this is all I can see,
Yes.
and I'm just going to focus on that. There's something, I guess, quite charming about being able to divvy up the pie, as it were, between your own team. Go, like you say, this person's best placed to manage that. We'll take it from them. We'll give it to them.
And it's as you were saying, Marc, just in terms of this is holistic. It's not, we're not talking about elements. You're responsible for that bit and that bit. It's how they all go together, the indoor environment that it creates, performance of all those things. We all need to be thinking about this, not just bits of it.
Yeah, and we don't know how it's.
Yeah, exactly.
And we don't know what the parts are
That's
until
right.
everyone's appointed.
Everyone wants to split parts up into budgets.
Cool. So that gets rid of one of my notes entirely, because I was going to talk about single supplier and negotiated price, and I think we've decided that's probably a good idea. And I guess moving on to the next question, because we are rapidly running out of time, I'm trying to get us back on program. Does performance-driven value get placed higher than pure cost? So I think my interpretation of this is that sometimes the contractor is somewhat boxed in by decisions made without them being at the table. And so this is typically in a competitive tender. And so you end up with this, you have to competitively tender, and then you have to meet these overly onerous performance requirements. And I guess there's a real risk associated with that, like you say, with not being at the table early. So I think I've answered my own question. Let's move on. We're running out of time. Is program often well designed to cater for timely procurement and completion of the project? So when do you need the sub? I think the general consensus is at the table as early as possible.
Yes.
Yep.
Yes. I have to say that we keep looking at program in terms of when we hit site. I always, and this is not a dig at any architect or anyone, or a consultant or anyone. We always receive, as a subcontractor or a contractor, we always receive a set of design details. I've never built exactly the design details someone's given me, because they are intent drawings. And I could imagine how much effort and time and cost has gone into you having to develop a package that you can put out, because there's not a trust, because you think there's a collusion or not a collaboration. Instead of saying, why are we producing all this paper? Why don't we get a team together and we can produce the right solution straight off? We can play with options, variations. We can look at sites from different types of construction typologies. Today I see in New Zealand, if you are going to import anything in, your constraint is the width of a container. Why can't we do like in the UK and places like that, 4.5 metre module units? Why can't we do full column widths? I mean, have you seen when the builder wants to collaborate, give you maybe within a second shift, the ability to use the tower crane and put in an entire column-to-column unit that you could be easily transported on a low loader, brought in, the speed of operation, the coordination where you can get other trades to come in and start chasing up is so much quicker than thinking we're going to go the old classic style of loading out 1.5 metre modules or 2.5 metre modules. So that I really think it's performance for me and is always about, and design, and program, I suppose the question was. The program really has to concentrate not on when the contract's given out, but how much time does it take to develop all the drawings? I know that the job goes on for 2-3 years before a subcontractor even gets involved. Why can't we utilise that to really get the definitive design in? That's always my mystery. I don't understand why.
Yeah, absolutely. I think going for that is quite often perhaps in the competitive tender. You find that some of the lesser subcontractors can't actually fulfil the original design intent, and so you end up with this gap. And Tim must have experienced this. We've drawn it as something magnificent and curved and wonderful, and what we're actually getting is something planar and chunky, and I guess I don't think that's ever built into the program.
No.
It's just it suddenly becomes a constraint of procurement.
Well, it's a classic, isn't it? I mean, to that point, if we've been working on a stick system, facade system, and we, in a traditional process, and we go out to tender, and the best price that comes back is unitised. It's like, well, okay, that's fine, but then the design team, it's not just the architects, the design team need to go back to the drawing boards to an extent and say, right, what's the implication of this on all aspects of the building? That takes time, and if your client's willing to pay for it, it costs money as well. But I think the other thing about program is it was a little bit like we were talking about with scopes of services and for the design team and being handed to you when you put your price in. So often we're given a program and a design program that is short and doesn't even allow for that, even if we've got the situation where we can get that collaboration and ECI and engagement. It's like, nope, we've got to get there. And we all know that investment in the early stages and time, it just pays dividends down the track. But if someone's trying to keep pushing you, you lose that the value of that early inputs, and it can cost you down the track in terms of program.
It's interesting that in terms of program and procurement of facade and the consent flow now, that's really well understood, right? It's still volatile, but it's pretty well understood. The thing that pre-construction of one form or another, whether it's a formal ECI or whether it's a significant lead-in, is a fundamental to whether we're interested in participating in a project or tendering it. And interestingly, the market now is, everything I see is some kind of ECI process. Now, we can talk for ages about how far on the spectrum and when, but what's interesting is that even through those processes, I guarantee you we will hit go on manufacture before we've got an approved building consent. And a matter of fact, we've got a 42-storey tower in Auckland with 20 levels of facade in Auckland, and that all arrived before the consent came up. Consent's fine, but it's just one of those things where we're not solving some of these issues around big picture risk, which in that instance, that's all my risk, unfortunately. But that's what you have to do to hit program. And there's an element of the world used to have really linear design processes which were great, right? In the sense that you could work through the steps, but they were unaffordable. The holding costs, how far you can go sailing in the wrong direction with a design before you get market feedback, all those sorts of things. But we have definitely overstacked it now. And what takes my breath away is that I thought an ECI process would stop that issue of everything being overstacked. Instead, I see us more frequently going into foundation, consenting and construction, you know, in the first month of detailed design, and all these other things. It's kind of had the reverse effect where we're going further into construction with less documentation and more parallel work streams. And that's scary as hell.
Oh, the risk
You know, it just makes no objective sense. And so I feel like the market's just got its head around ECI and that it's a good thing, but it's already weaponized it into crunching the program and increasing more risk. What the, you know.
I think one of the things that I see is, particularly from the architect, one of the first constraints I would have looked at in a job.
No, you can blame Tim, it's okay.
Sorry. Apart from specification, apart from everything, is what's the client expectation?
Yeah.
Right. What do they want? What are those unhidden things that never said? What you're trying to achieve, and how can you actually satisfy the client? And I'm looking just here at innovation of the three questions, but they're all interrelated, really. I've seen where you try to put something innovative in a project. I always get asked by the contractor, I want something innovative. No problem. I've got it. Here it is. Great. Second question. Where's it done before? Well, you asked for something innovative by definition. It's not the very first to bring it in. How do I know I'm not being ripped off? How do I know? Well, let's sit down and I'll break out the price for it. And when you come up with innovation, particularly facades, we looked at today, energy, comfort, condensation, all these things. It's not just something that hangs on the outside of the building. I've done many times a dynamic facade where we never would have got on, because by then the mechanical engineer and the mechanical engineering HVAC contract is fixed. The whole system of how you want to condition the building for comfort, for daylight, for glare control, for natural daylight into the building, for aesthetics and everything is usually fixed. You don't have any recourse to say, can I try something? No. Most successful is when I've been able to sit with the mechanical engineer and say, I can dynamically change this facade so that at the peak of the day, I'll shade it to the max. And in the afternoons, you'll be able to see straight out and have these wonderful views across Auckland Harbour. And they go, wow, really, you can do that? Because what that'll do is I can reduce my condenser, I can reduce the actual, the size of the mechanical. Hell, I could even maybe start using something like radiant cooling. I could use another type of, which opens incredible possibilities, not just to the architect, but to the architect and the consultant, trying to convince the client that this building is going to be an experience. It's not going to be just, you know, something that you're going to go out. And the only way we've tried, one way I've gotten around of trying to do it is I've always had the opposition because people didn't want to spend the money. So what we did was we went to the real estate institute, to the real estate, who leased out buildings, and we got them to redefine what they would call a grade A building. So when they started to incorporate energy efficient things with such and such a facade, that could only be done at an early stage where you could collaborate them together, because really the facade is part of the energy system of the building. It's a dynamic, integrated. Yes, that's right. Well. And if you get it there, and then what was happening was you would have the contractor would come in and say, or the person they were trying to lease to, the prospective clients, were saying, well, we want a grade A building. Well, no, this one's a grade B. It doesn't have this. Well, you can only get £300 per square metre rent. Well, no, but it's a great building. It's got all these fancy bits and pieces. No, if you want to do it, we need this, this and this, and you get £500 a square metre. So once it became statutory, novated into the general way of the way it's the norm, it's what we do, no questions were further asked. And projects became brilliant after that, you know. Every time I've seen it piecemealed, it was always dog eat dog, you know.
Change the rules.
Yeah, it does.
Easy way to win the game.
It does, yeah.
I reckon a really good innovation for New Zealand would be not stick building facades and just getting a curtain wall that is affordable, right? Locally made that we can rely on, right? Some of the most frustrating things constructing mid-rise work is this, let's take a residential approach and let's make it big.
Yeah.
And, you know, and I'm sure, I didn't make David's speech, but I guarantee you talked about a full wrap solution. We have to get to a point of an affordable, high quality curtain wall that's readily available to be rolled out. And that's the innovation I want.
Unitarised, panelised,
Give me that for $900 a metre.
Done.
You know?
That's a target. So there's an order winner. We'll move on to our last question. Can sustainability or embodied carbon be a voluntary consideration in design and procurement? And I think, I'm going to change the words. I don't think it's a voluntary consideration. I think, can it be an order winner? If we've got our classic triple threat of cost, quality, and time, do we make that triangle three-dimensional, add a fourth point, and say that's carbon?
It's coming, right? It's coming either way. I don't see the clear answer through it, but it's a matter of time before it gets regulated as part of the consent processes, and it should be. Haven't got my head around it, but we have to.
I would say we look at sustainability. I look at it in two ways, sustainability. Everyone's talking about sustainability with carbon. They all talk about sustainability with energy, all sorts of things. But I always look at, my definition of sustainability is, I don't want to do something today that my grandkids have to pay for in the future, right? And one of the most inefficient ways as we build buildings today is we're transporting masses of concrete and which are crushed from even further distances away and bringing it in. And then you've got all these trades running up and down, and the energy and the carbon to bring all that stuff onto the site is enormous. And I think that just like facades are modularised and prefabricated, the next real innovation has some involvement with the Australian Research Council, one of the largest government grants that were ever given was in modularisation. They're looking now modularising entire building modules. So you would instruct buildings off-site, modules of them, and they'd come together like Lego units. So you can actually put these things together. They're amazing technology. And so if you could concentrate things closer at the source, you know, say a factory setting for quality, for everything, and all the main contractors to really concentrate themselves about lifting modules in. I think that's a massive, massive amount of energy that can be saved. When you look at the cost of pumping concrete, 50 floors up on top, rather than making it on the ground and sending it up. We do it with precast. Why can't we do it with entire building modules? The facade's on, it's fitted out. You're working at ground level. You're not worrying about vertical transport apart from, when you get on site. These sorts of innovations and these sorts of, I think, things is what I call sustainable. I think, I look today, everyone's going, we're going electric, we've got to drive a Tesla. And then when you look at the Congo, what they're raping in the ground and got 8-year-old kids mining lithium, I mean, Jesus, what are we talking about with sustainability, I think it's the way we build, we like the, I don't want to use the term, but we all have this righteousness about us. It's like someone once said to me, I don't want to be crude, but it was like the prostitute doesn't kiss on the lips, We're all just like, we close our eyes to all these things that happen, and we should be thinking of construction sustainability as what effect are we going to have on the future, if we're not using energy and all our efforts in the right way. I don't think climbing up these 50-storey buildings with hundreds of people in vertical transport systems, I think, is the go. Build it on the ground. Let's hoist it up in one hit.
All right, for like a tangible short-term thing towards that for this market, I think is to be more consistent. Like we have structures are the same. We have hybrid structures that are part concrete, part steel, that are part precast, part in situ formed, and these sorts of things. And they're a horror show to build, right?
Yep.
Just can't build them in any type of program that makes sense.
Yep.
But the facade's the same, stick built, bits of this, bits of that. A huge thing that would unlock better quality outcomes and more consistent delivery from the supply chain would be a more regular pallet. Do you know what I mean? Mm-hmm. Like in Oz, and they don't do much right, but at least what they do have is like a consistent kind of typology around high-rise, like flat slab, PT, curtain wall, done, that's your apartment. Mm-hmm. Or at least that is a really constrained, considered, repeated typology that you can scale up to. The supply chain can build up capabilities for, and then you can start, predefining details and getting repetition. The first time, every time thing in New Zealand is a killer.
We're unique.
Yeah.
Unique and
Every
special.
job's a precious snowflake, right?
And on that note,
I was just going to say, I think it's something, though, that we do really need, as you were saying, Dan, it's coming. We need to address, the government, in terms of being a client, have mandated ministries to start carbon measurement and to be potentially doing Green Star. That will flow on to the commercial sector. So it's time for us to innovate now and prepare for this now and make it business as usual, which is what we've been talking about, rather than an add-on that you can take away. And I think obviously a lot of it comes down to our clients. Are they prepared to pay?
Yes.
But, we've got some of the biggest investor developers in New Zealand now who have got sustainability policies. They've committed to reducing carbon. And, the other aspect of it from institutional clients who are keeping buildings rather than selling them is that it's the whole of life costs. It's, actually investing up front in quality pays them back over a period of time.
Yeah.
We know that residential's moving to build to rent from build to sell at the moment because of the market. Well, those institutional clients will want to be considering quality, maintenance, all these things. And that's sustainability in action, whole of life costs, and investing up front. I think that could be an opportunity for us to actually get better quality.
But somehow we always get to the discussion that is the client willing to pay? There's this perception that it's going to cost more. I don't know. I haven't seen that. In PCSAs, I haven't seen it because you're constrained to working within a budget. The question is, are they willing to trust us to work as a team? They don't, because they think there's a collusion. You drive the prices up, you guys will do this. And are they willing to trust you? That's the thing. Are they willing to try something new in a new way?
I think
And if the client's involved too with that decision making, it makes it an entire different way than just buying like a supermarket shopping trolley, going down and throwing pieces in the trolley and hoping that you're going to mix up your dinner and it's going to be tasty at the end of the day.
I think that trust in your co-designers is a sort
Absolutely.
of recurring theme, and the client having trust in that team to deliver what they want. So I think that's a very positive note to end on. Our hope is for a more trusting future, and we'll go from there. To the beer.
Thank you.
All right, thank you very much. That was wonderful, intriguing. I hope you've enjoyed the session today. Everything about facades we've tried to cover, we've tried to talk. And next one will be happening in Dubai. So anyway.
So thank you everyone for attending today's event. But I think we need to give a round of applause for Oliver. I think he was fabulous. Thank you, Oliver. Those who recall last time around, we had a great host, John Perry. I think Oliver stepped in seamlessly. Thank you, Oliver. So as I mentioned in the morning, we've recorded today's event. We'll send the YouTube link of the same a week from now. Yes, so this is it from us until we meet next time, hopefully with newer topics, newer speakers. I'd like to thank you all for taking your time out and coming for today's edition. I hope you enjoyed it. As Oliver said, we have a networking reception now sponsored by Glasscorp and their partners EGC and Dow. I would love to invite all of you to join the same. We are done with the event. We'll take some photos and we'll join you out over there soon. So thank you all.